Good morning, everyone, and welcome to Themes and Styles Demystified. I'm Alan Viverette. I'm a tech lead on the UI Toolkit team and the engineer responsible for the material themes.
Hi, I'm Chris Baines, an engineer on the developer relations team. I also work on AppCompat, so I deal with themes and styles quite a lot. So it's great to see so many faces in front of me, especially sunburnt ones, because it's been hot here in Mountain View over the past day or two. So it's 9 a.m. here, and I can see quite a few tired faces in front of me, so I thought I'd start with a quiz. So the first question I've got, in what Android version did theme.holo appear? Right, so Android Eclair, hands up. Honeycomb. Hey, too clever. That's an easy one. How about the dark action bar variant? Honeycomb. Honeycomb 3.2. A few. ICS. A third one. How did selectable item background change in KitKat? Did it change to a ripple? One. No, I changed to monochrome. I pressed the wrong button then. Don't worry, I got a fourth. In what version can you use Android foreground on a view? Is it Android 1.0? Oh, we've got a few. ICS? A few again. How about Marshmallow? So this is my trick question. So you can actually use foreground on frame layout from API 1, but we only actually moved it up to view on Marshmallow, so that's why it's trick. Anyway, hope you're awake now. So this talk is all about themes and styles, and we've realized recently that there aren't that many people who know it. It's quite a dense topic, and there's lots of intricacies into it all. So we thought we'd write this talk to try and give everyone like a level playing field. So before we actually go into like the guts of it all, I thought we'd sort of take a quick refresher course and see what they actually are. So technically, themes and styles are exactly the same thing. Internally, they're both declared using the style tag. So in your resources, you create your styles. And you'll notice that when you actually create a theme, you're still using the style tag. The only difference between them is how you use them in your application. And we'll talk about more about that later. So at their simplest, styles and themes, because they're the same thing, are just key value stores. So here we've got a very, very simple style. And you'll notice that the actual key is the attribute, so Android background in this instance. And then the value is color blue. So we've just mentioned the word attributes there, and they're the kind of key to what themes and styles are all about. Now let's take a quick look at what they actually are and how they work. So as we mentioned, attributes are just keys. They're declared in the Android framework and also in your apps. The important thing to know, though, is that, yes, they are keys, but they also declare what type that can be set against them. And that's important because it affects how the data is stored. So when the attribute is read internally, it can affect how the actual value is read. And it also affects things like type conversion. So the system can actually convert between types for you. And because of that, we can do some XML linting based on this. So if you're using an attribute with a wrong type of value, we can put that into lint, and we can sort of flag it to you and make sure you're not going to shoot yourself in the foot. So these are types of attributes that you can, format types that you can put on attributes. The ones on the left are all resource types. So they directly map to a resource type that you can set in your resources. So things like fraction, float, string, blah, blah. The ones on the right are special in that they are only used for attributes. Flag is exactly what it sounds like. It's a bit all. So you can have multiple flags bit all against each other. And then the second is enum, which is exactly what it is. It's an enumeration of ints, so you're going to get one value back. And then you've got the last one, which is reference. And that's kind of a catch-all for everything else. So drawable uses this, because we don't have a drawable type. But basically, it just points to another resource. It points to a resource ID. So how you actually declare attributes is like this, using the attr tag. Again, in your resources, so everyone's quite inside each other. And here you can see that there are two things you need to set. The first is the name. So this is the actual declaration for Android background using the framework. So it has a name of background, and then it declares its type, its format. It can accept two types, reference and color. Reference because it expects a drawable, and color because, as we said earlier, it can do type conversion. So what will happen is it can accept a color, like an int value, and then the system will automatically change that into a color drawable for you. So that's the type conversion we were talking about earlier. So all attributes provided by the framework are in the Android schema, which is why at the top of all of your layouts, you have to declare this namespace. Now, the name for the namespace, in this case Android, which is in bold, is just a convention. You don't have to use this. You can name it whatever you want. But I'd advise you to keep using this because it clearly sort of separates what are your attributes and what are Android's attributes. You can also declare custom attributes in your app. And indeed, you're probably already using libraries which declare their own attributes. Now, it's important to know that all attributes that are declared in your app, so even libraries, are in like a global namespace. Now, what that practically means is that if two libraries or basically, there are two declarations of the same attribute name in your app won't build because you'll get a conflict. So it's something to be careful about. Now, as I just mentioned, any attributes which are created in your app are in your app's namespace. So instead of declaring the Android namespace, you declare your app's one. Now, you do that via this syntax, and you insert your package name. Now, we know that's slightly clumsy to use, so the tools have a quick shortcut. So instead of actually putting the / your package name, you just do res auto, and it will do all the hard work for you. So we've just talked about what they are. Now let's talk about the differences and how you actually use them. So themes. Now, themes are tied to your context, which is why it takes two methods. It has two methods on the context, one called setTheme, which takes a resource ID pointing to a style. Now, there's one thing to note here. It's a kind of a badly named method in that it doesn't set, it applies. So you already have a theme on your activity, and then when you call this method, it'll apply it on top. It doesn't actually wipe anything out underneath. And then you have a getTheme, which will return an instance of the current theme. Now, you'll typically set themes in your Android manifest, so you'll set it in like the Android tag or whatever it is. Now, internally, all that does is just before your onCreate is called, it will call setTheme for you. So it's exactly the same APIs with the framework are calling. Now, themes don't actually really do anything. I like to think of them as like big configuration stores for everything else. So let's take a look at some of the things which are actually in there and how, what kind of configuration things are in. So the first thing is default widget styles. So when you create a widget in your layout, say edit text, it will have a default style applied to it. And the way it finds out what that default style is from your theme. Now, each different widget has a different attribute for its default style. Edit text is called edit text style. Text view is called text view style. You get the idea. But yeah, so that's the default style. We have some color values. There are the ones you'll probably mostly use are for text colors. So it's text color primary, secondary, tertiary. Alan's going to talk more about these later, but there are others. Text appearance styles. So again, Alan's going to talk about text appearances, but they're basically mini styles which affect only text. Now, this is where I think the bulk of stuff is in themes, and that is window configuration values. So when your activity is created and your dialog, a window is created for you internally. And that is where your whole view hierarchy sits. And above that is a lot of framework stuff. So if you're using an action bar, it will inject a load of views for the action bar. And this is, so all the configuration values in your theme is how that affects it. So there's also stuff for like window transitions and all that kind of things. Then we have some drawables. Wouldn't it be nice if we provided some sort of off-the-shelf handy drawables to use? And we do. The most important, I think, is selectable item background. That will give you a really nice drawable to use as a background for a view, like a clickable view, and it will like, give you a highlight. So on a material and above, it will give you like a ripple. Before that, it's kind of like a state list. And then lastly is a section we call themeception. Alan's going to talk more about this later. But it's basically, there are certain components when created allow you to override their theme, and they'll pick it out from your master theme in your activity. Right, so that's themes out of the way. Let's talk about styles. Now, styles do a lot. They're the things that do the bulk of the work when styling your views. They're really handy for sort of decomposition of common styling, so you can reuse stuff across different views. So let's take a look at an example. So here we have a view, and we want to reuse this background tag. Now, this is kind of a trivial example, because you're only reusing one thing. You wouldn't usually do this. You probably reuse 3 or 4, but it's a bit of a unwieldy example if we do more. So we're going to reuse this background tag. So here's our style for it. So we'll create a style, and then we'll put an item in there pointing to the attribute, so the name, and then we'll put our value within it. Now, each attribute you set goes into the item tag. Then once we've done that, we can go back to our layout and swap the Android background and replace it with a style tag, pointing to the style. Now, if you've got more items in that style, they'll all be applied too. Bit of a pro tip for you. Android Studio does that whole flow for you in a really nice way. If you go to the Design tab when you're looking at a layout and right-click on a view, go Refactor Style, it gives you a nice little UI where you can pull out attributes and put them into a style. It will do it all for you. But the other really good thing it does is that it will try and find other views in your layout and then automatically reuse the style. It's really cool. So hopefully now you know the difference between themes and styles. So let's have a look at sort of the intricacies of actually creating them. So one of the things that you can do with styles is that they support inheritance. Now, themes and styles can inherit from each other, which is handy for when you're creating sort of derivative styles, and you'll see examples in a minute. The important thing to know is that they overlay each other. There are a couple of ways of implementing inheritance in styles. The first is implicitly, using the dot notation. So the parent here would be widget.material.button. So it's the style before the preceding dot. You can also do it explicitly, and that's done through the parent tag. So here we've got a style called myButtonStyle, and it sets an explicit parent. And as you'd guess, the parent is what you've set. Now, there's a small gotcha in that the explicit way always wins over the implicit. So we've got style here, which is using both dot notation as in the name, but also has a parent tag, and the explicit version always wins. Now, the really powerful thing when using styles is that you can reference values from your theme. And that's that attribute thing we were talking about earlier. So here we go back to our style that we created, which sets a background to myDrawable. And instead of using that, we want to use this selectable item background, which we talked about earlier, which is that nice clickable highlight. So this is the syntax you use. So let's break that down a little bit because it looks a little bit alien. So let's break it down. First thing is the question mark. Now that denotes that we're going to be doing a theme looker. The second bit, the Android colon, is the namespace we're going to be looking up. So the name of the namespace that the attribute is in. Yeah. So if you're using a custom attribute, you can put whatever attribute, whatever namespace you're set into. Then we have @/. Now that denotes the type of thing we're going to be looking up. Now in true Android fashion, we only have one type, which is @. So you can actually omit this, which you'll see in a minute. And then we have the last bit, which is the actual name of the attribute we're going to be looking up. Now, as I said, the type is optional, which is probably why you've seen this syntax. So the @ is omitted. It works the same. So now I'm going to hand over to Alan to go through theme.material.
Thanks, Chris. So Chris just gave you the technical side of what is a theme, what is a style, and how do we create them. So we're going to go hands-on with some of the material styles to learn what we have as a base building blocks for our own styles and how we can apply these in practice. All right, so first we have themes. Themes in Android are prefixed with theme dot. In Material, it's theme.material. So everyone should be familiar with these. We've got the Material Dark theme. We have themes that have window attributes for dialogues. And of course, we have themes that do some special things like give you a dark action bar on top of a light theme. And if you look at the actual framework definitions of these, it's just a huge bag of attributes for colors, window attributes, things like that. We also have overlay themes. So these are themes that define a subset of values that, as Chris mentioned, get applied on top of your existing theme. So for example, material.light contains only the colors relevant for a light theme. It's not going to change any of your window attributes. For people who are developing for older platforms, you may have noticed on API 21 and 22 that if you set a color accent in your theme and then you open a dialog on API 21 and 22, you're still going to get teal unless you explicitly go and create a dialog theme that redefines your accent color. In API 23, we added a dialog overlay theme. This only redefines the window attributes specific to dialogues. It gets applied on top of your activity theme, so the host activity that creates the dialog. We apply window attributes on top of that, so your color accent, anything else you've set, gets propagated to dialogues in API 23 and above. Overlay themes look like this. Again, it's just a subset of the things that would have been defined in the overall material light or dark or whatever themes. You can create these yourselves very easily, and then just use theme.applyStyle or setTheme in your activity. The material theme spec also defines a number of text appearances. So for larger text, you change the opacity a little bit. For buttons, you may set all caps. These are prefixed with text appearance in material text appearance.material. At the XML level, these are just sets of attributes specific to text. And these are either defined in your theme with text appearance small attribute, or you can apply them directly to a text view using the Android:text appearance attribute. So this is just going to apply a set of text attributes to style your text. We also have a number of default widget styles. So these are prefixed with widget.material. They're going to implement things that you'll recognize from the material spec. So for example, in API 24, Android N, we've added a seekbar.discrete, widget.material.seekbar.discrete, which is going to give you these little tick marks along each progress point in your seekbar. You can check out API demos for a longer example of some of the different variations that we have on widget styles. But these you can apply to your widgets with the style attribute, so style equals seekbar.discrete will give you these dots. And these are just sets of attributes that are going to provide defaults for your views. So for example, the seekbar discrete has implicit inheritance from the material seekbar, and we just redefine tick mark so that we get those drawables at each progress point. So while we're here, anybody who's really dug into the material theme may have noticed something unusual about our widget styles. And this is that the light themes and dark themes are identical. So our light themes typically just inherit directly from the default themes and don't redefine anything. But under different parent themes, so if your activity is light or dark, you're still going to get correctly colored widgets. How do we do that? Well, as Chris mentioned, we have colors defined by the themes. And we're going to use these in the widgets. So this allows really high-level styling of what things look like. Everybody should be familiar with color accent from Material. This gives you a little pop of color that shows up in various places. For the background of button.color, the foreground of borderless colored buttons, radio buttons, etc. One example of how to implement this, so for the colored button that we just showed, we have a background that points to a drawable. In that drawable, which is just a ripple wrapping a rounded rect shape, we actually don't use PNGs anymore, we have a tint, and that tint points to a color state list. And that color state list has an enabled and a disabled state. The enabled state points to color accent. So when you see that colored button, the default color is going to be color accent tint on a white-shaped drawable wrapped with a ripple. So let's talk a little bit more about theme colors. We also have foreground and background colors. So these are going to be white and black, or black and white, respectively, for the light and dark themes. And what good does this actually do us? You may not be using flat black or flat white in your application a lot. Well, let's take the switch for an example. So the switch has a couple of different colors, and we could have defined theme attributes for switch foreground, switch background, and they're all basically just variations on white or black. So let's dig into the XML for this. The switch track is defined as a rounded rect shape. Again, we don't really use PNGs. And it points to a color state list for its tint. In the enabled state, this is going to be a dropped alpha. In the disabled state, this is going to inherit the disabled alpha from the theme, which varies based on light or dark theme, and it's going to use the foreground color. So in the dark theme, you have a dropped alpha version of white. This is applied on top of a rounded rect that already has a dropped opacity, so we're going to end up with everything being a slight variation on the foreground color. And you can very easily use this in your own widgets to get something that's going to be consistent with your theme. We also have text colors, as Chris mentioned. So we have a primary text color, which is used to provide very high contrast for things that the user needs to be looking at immediately. We have secondary text color, which is just a dropped opacity, and these are going to follow the material spec, so I believe 84 and 56% opacity. And they're going to follow the theme colors. We also have inverse versions of these, which we don't use so much on the platform anymore. But if you're going to be displaying content against, say, your accent color, text primary inverse or secondary inverse is a great way to do that. We also have color accent primary and primary dark, which we added in material and are going to provide your branding colors. So if you're pulling in color accent, you get that color pop. You'll probably want to use a white or use color primary inverse on top of that. So in a light theme, you'll have a dark accent. In a dark theme, you'll have a light accent. And you can pull these into your drawables and your color state lists. We also have color control normal and activated. Control normal is great, and I really recommend everybody use this if you have icons. So for example, checkboxes are going to use color control normal by default. If you're pulling an icon into your action bar and you tint it with color control normal, it's going to be the exact right opacity. And the number of times that I've seen applications where the toolbar icons are different by like 5% alpha, it kills me every time. So please use color control normal for your icons. So looking at an example from API demos, you can probably guess how a lot of these widgets are set up. So we have compound buttons, which is text color primary. We have that switch text right below it, which is text color secondary. We have the accent color in the activated state for our checkboxes and radio buttons. And we have the color background as our overall background, color background floating as our card background. So you can look at a screenshot of something or look at an application and probably guess where a lot of the colors are coming from. Right, so now we have an overview of what's available to us and how these are used to build the framework themes and styles and how we can apply these to our applications. And these are very powerful tools in Android, and theme attributes are especially powerful starting in API 21. So starting in API 21, you can use color state lists and theme attributes to tint your drawables. So you can specify color control highlight for your ripple, which is what we have as the default. And you can specify a color state list as a tint or as a color for XML-defined shapes. So if you'd like to step away from using PNGs all the time, maybe you have a bunch of different PNGs for different colors of states, you can just directly put a color state list in, and when you press a button, you'll get a different color. Color state lists support theme attributes starting in the next API version, 22. And this means that you can start pulling in the foreground color, the accent color, setting the alpha to match the theme in your color state lists, which is going to, again, help you step away from having drawable selectors or individual PNGs for all of your assets. AppCompat also supports color state lists. Starting in version 24, you can use AppCompat resources, which is going to provide an alternate inflation path that can read theme attributes from your color state list XML. It does this automatically internally, and you can do this at runtime for specific XML files. We also support view tinting. So what this means is for views that own drawable assets, things like the thumb in a switch, the track in a progress bar, you can tint these either from layout XML or at runtime using some accessor methods. So for example, switch has a thumb and a track, and because it's a view, it also has a background. All of these have separate XML attributes that you can use to set a tint. These can take theme attributes. These can take color state lists. In API 22, they can take color state lists of theme attributes. And this is a really powerful way to tint just a one-off somewhere within your layout. So you need this switch to be red. You can make it red really easily. You need it red with a disabled state. You can set a color state list. As I mentioned, we have a bunch of text appearances in the material style. These are just bags of text attributes. So you can apply these to your text views using Android Text Appearance. And you can reapply these at runtime, which is actually something kind of unusual for Android styles. So for most views, styles get applied once at inflation time. For text views, you can restyle them at runtime whenever you need to using setTextAppearance, which takes a style which should be a text appearance or something that inherits from a text appearance. It just defines a set of text attributes. All right, so we've learned some cool things about what's available to us for creating styles and creating theme drawables. How can we apply this to do something kind of cool? Well, we introduced the day-night theme in the support library, and this is something that we've supported in the platform for actually quite a long time. So day-night is implemented as a resource qualifier. This has existed since API 8. Starting in API 23, this is something that any application can toggle through UI Mode Manager. So if you write an application and you want to toggle the global state of day-night mode, you just go into UI Mode Manager and you can set night mode. When that changes, it's going to be treated as a configuration change, like you would have for changing device orientation, which adds the landscape resource qualifier. So this is going to really simplify swapping light and dark resources if your user either prefers dark or if you want to set it up for automatic, where at nighttime maybe your user will see a dark theme and daytime they'll see a light theme. So the actual implementation of this relies on inheritance. So we specify a day-night theme, and we have the same name in both our values and night-qualified values directories. And the only difference is the parent that we're inheriting from. So under not night or the default qualifier, we're going to inherit from theme.material light. And under the night qualifier, we're going to inherit from the dark material theme. Now the magic here is that when we have this resource qualifier change, the application is going to go through a lifecycle event. We'll get an on-configuration change. And we're going to reload our theme using this new parent, which means everything that we inflate is going to have different theme colors. Now, you can also define explicit colors. So if you want to have a hard-coded color and define that differently under night or not night, you can do that. But it's easier to rely on theme colors. So the end result of this is that because everything gets inflated against your theme and we're using a different parent, you're going to get either dark or light resources. And in custom widgets that you've made where you're using theme attributes, you're just going to automatically get the right colors. So you don't have to do a lot of work to switch between implementing a light and a dark theme. As Chris demonstrated in our What's New in Support library talk yesterday, this has been backported to API 14 through AppCompat. So if you want to implement a light and dark theme support in your application, super easy. Most of the work is already done for you. You just need to add a little switch that will toggle night mode. Right, so using themes and attributes can help simplify switching the visual presentation of your application. But what if you want to change just a small portion of presentation in your application? So we know that theme.material can make your application look dark. We know that theme.material light can make your application look light. But what if you want to have something like a dark action bar, but the rest of your application be light? Well, there's one way you could do this. You could use the light activity light theme and then just specify everything in your action bar manually to be dark. That's a little complicated, so maybe instead we'll have a dark theme and we'll just manually specify everything in our activity, all of our content, to be a different color. That ends up being really, really tricky, so please don't do that. Don't hard code text colors. So there's an easier way, and that is through overlay themes and specifying themes on portions of your view hierarchy. And this is what we do with the dark action bar theme. So we actually redefine the theme that's used for the toolbar section of your application. So everybody recalls we have overlay themes. We have a light theme that pulls in light colors. We have a dark theme that pulls in dark colors. And these are implemented using the Android theme attribute from XML. So this gets picked up by the layout inflator, and it's going to replace or overlay the theme used to inflate a subsection of your view hierarchy. And the actual implementation here is pulling the theme attribute from your XML, and then applying that as a context theme wrapper, which is exactly what it sounds like. We take your inflation context, and we're going to apply a theme on top of that. We're then going to inflate all of the child content against this new wrapped context. So what you will get is, effectively, the dark theme in the section of layout that has Android theme equals dark, and light everywhere else. Now, the actual implementation of this relies on the default layout that we provide for an activity that has an action bar. So if you dig into some of the XML files in the Android framework, screen action bar is what we inflate if you've requested an action bar in your activity. And we're going to set the Android theme attribute to inherit from the action bar theme attribute defined in your theme, which has attribute and theme a lot of times, which is why we call this themeception. So we're going to pull in the dark theme on top of the light activity theme. We've defined action bar theme in the dark action bar theme as material.dark.actionbar. This is the dark overlay, which pulls in the dark theme colors. It switches the text, foreground, and background colors. And action bar sets up a couple of special things for displaying the, let's see, accent color in your toolbar. But the important part is that we're pulling in dark colors on top of your base light theme. We also redefined the pop-up theme so that you get a light pop-up on top of a dark action bar on top of a light activity. So we have 3 themes that work here, all overlaid on top of one another. We also support Android.theme through the AppCompat library. So this is going to work all the way back to API 7 for XML that gets inflated through AppCompat. And inheritance of the parent theme is going to work on API 11 and above. And what this means is that if you put Android :theme in your XML, on API 7, we will apply it to that view only. On API 11 and above, we will apply it to all of the views that are inflated as a child of that view. All right, now Chris is going to cover some common mistakes that developers make when using themes and styles.
Thanks, Alan. So as Alan said, we're now going to go through some of the things we see quite a lot, both in Google Apps and also externally on things like Stack Overflow. Now, hopefully, I'll be able to stop repeating myself, because we see this a lot, and we always say the same thing. So the first thing we're going to go through is using the incorrect style parent. So it's easier if we go through an example and show you what this can actually do. So here we have an edit text. Well, we have multiple edit text. And what we want to do, we want to make every edit text have a different font, the medium font, but it could be anything. So what we're going to do, we're going to change the default style for edit text, and then set it to have a medium font. So here we have the example, and here's our style. So our style here is my edit text view style, could be whatever you want, but it sets one thing, which is font family, and that sets it to medium. Now, once you've done that, we'll then reference it in our theme, so it gets picked up as default. And then you run your app, and you see this. Suddenly, all of your edit texts have gone. You've lost all of your styling. They're no longer editable. But you have changed the font to medium. Now, the reason why this happened is that you didn't set a parent on the style. And what that happens is that you no longer pick up all of these system defaults. So you no longer get the background, the fact that it's editable, all sorts of weird and random things which are in the style. So the way to fix it is you just set the correct parent. Now, the best way of finding out what the parent is just look at the theme you're inheriting from. So if you're using theme.material, just go into it. It is big. It's about, I don't know, 200 lines-ish. But it's all quite nicely spaced out. They're all grouped together. It's not too hard to read. And suddenly, once you fixed it, it all looks good again. Now, this is quite a technical mistake. You're only really going to mistake this if you're kind of writing custom views. But it's the difference between default style Atra and default style res. Now, there are 2 places where you'll use this. The first is the for-arg constructor on view. Now, that was added in API 21, so I doubt many of you are using it. But the main place you're going to use this is in obtain styled attributes. And that is the way you actually read attributes in views. So here you can see at the bottom, the last 2 parameters are default style Atra and default style res. And the problem is that default style Atra should always point to an Atra. So the default style Atra should point to an attribute in your theme to pick the default style from. Now, the last one, default style res, should point to an actual resource, so an actual style resource. In this point, r.style.widget, blah, blah, blah. Now, if you mix them up, basically things stop working. Now, following on from that, there's some intricacies in how obtain styled attributes actually works. And it's to do with the order preference of how it reads an attribute. So when you're trying to read a set of attributes, this is the order it goes through. So the first thing it looks for is the value in your attribute set. Now the attribute set is what contains all the attributes which are set on your actual layout. So if you have a layout and you've set Android background on it, it will be contained in the attribute set. The second thing it looks for is the same value within any explicit style. So if you're using the style tag pointing to a style, it will then look for it in there. The third thing it looks for is in the default style res. So that's in the actual concrete pointer to a default style. Lastly, it looks at the attribute, the default style in your theme. And then finally, it looks at the base value in the theme. Now, please don't rely on this, because it leads on to the next mistake, which is using view attributes in themes. So this is a mistake which actually someone on our team made recently. So here we have a theme, and we've set the Android background tag on it. Now, Android background is something you usually use in a view, but here it's set in the theme. Now, going back to the obtain style attributes bit, the last thing it looks for is in the base value of the theme, which basically means that because you've set that in your theme, any view which doesn't have a background set in it will then use this value. Which basically means if you set a background in your theme, say it's I don't know, color pink, every view which doesn't have an explicit background will have this pink background. And that's a really big mistake which we see quite often. Now, we are actually going to write more of these mistakes up into like a blog post, so follow us on social and we'll post them up. All right, that's it. Hopefully you've learned some stuff about themes and styles. Thank you very much. Very good.
Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 live stream. It's been a great day so far, and there's lots more to come. Stay tuned on all 4 live stream channels for sessions throughout the day. We'll also be on the ground and behind the scenes, finding the coolest and most innovative things to share with you right here on the live stream between sessions. And if you want us to track down somebody with your question, use the hashtag AskDevShow. Hello and welcome to the Developer Show. I'm Timothy Jordan, and I'm standing here with Mary Grove, Director of Google for Entrepreneurs.
Hi, Timothy.
Hi, Mary. How are you?
I'm great. Thanks for having me.
Thanks for being here.
Absolutely.
Okay, let me jump to a question about Google for Entrepreneurs. It's been on my mind for a little while because developers ask it,
Right.
and I think it's fair, and I think we should give them an answer. Why is Google doing this?
It's a great question. I'm glad you asked. So there's 2 ways that I look at that. One is if you look at Google's own history, our own journey as a company, entrepreneurship is such a core part of our DNA, right? Google began as a startup in a garage now almost 20 years ago. We are a company founded by entrepreneurs, built by entrepreneurial people, and then it makes sense that we are passionate about empowering the next generation of startups like Google to become successful, to launch, to use the internet to grow their business. So that's the first reason. The second reason, though, is actually an economic one, right? We believe that by investing in communities, long-term investing in startup communities, these are the next set of companies who are going to come online, use the internet, leverage Google's products as well. So really it's this notion that all boats rise, and long term it's also going to benefit our own business too.
Now, before you were the director of this huge, amazing thing, you were a BD principal at Google. And I'm curious, what did you learn doing those global partnerships that brought you into this new job?
Sure. So my personal story with entrepreneurship begins with my parents. So my parents are both immigrants from Thailand, and they moved to America, sort of personify the quintessential American dream. They were entrepreneurs and really showed me firsthand that you can really, create whatever future you dream for yourself. So at Google, fast forward many years later, I was working in new business development, as you said, looking at emerging markets for Google. And everywhere we worked, we looked for 3 things. One is how can we increase access, so internet and mobile penetration. 2 is how can we increase content created from these regions. And the third bucket, which was my personal sort of passion, was entrepreneurship. So how can we work with students, developers, any emerging entrepreneur ecosystem to really help them create the next generation of companies and really create and grow their own economies?
So let's say you're a budding entrepreneur out there with an early stage startup. What's your first step getting help from Google?
There's many ways to look at that, right? There's so many amazing groups and networks that Google has. Of course, Google Developer Groups being one of them, Women Tech Makers being another great example. We, at the heart of it, are a technology company, so we hope that our products, our platforms can help you be successful. Beyond that, in the Google for Entrepreneurs umbrella, our mission is really about bringing together startup communities. So working with partners of all types, whether that's physical space, co-working, tech hubs, to accelerators and educational curricula. We try to knit together this global partner community of about 50 organizations who are supporting entrepreneurs. So we encourage you to get involved with one of them. For example, Techstars is a global accelerator running all sorts of programs ranging from Startup Weekend to their vertical accelerators. And you can find all these resources on our website, which is google.com/entrepreneurs.
Awesome. Is there anything else that you'd like to say about the program that you don't often get to talk about?
You know, I think that we're based here in Silicon Valley, but Google is truly a global company. The internet has really democratized access to entrepreneurship, right? You can launch a company from Sao Paulo, Brazil, and have users in Seoul, South Korea instantly. And so what I would say is we passionately believe that entrepreneurship's thriving all over the world. It's about getting more access, getting more opportunity, and helping companies really go global from day one and think about their market opportunity as not just their city or their country, but really the whole world.
Mary, thanks for joining me today.
Thanks, Timothy. Thanks for having me.
For more information about Google for Entrepreneurs, make sure to check out the show notes for all the links that you need. I'm Timothy Jordan, and I'll see you next time.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes. That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
So service workers are powerful for offline caching, but they're also really good for giving you instant loading performance benefits when it comes to repeat visits.
Yep.
Right? And you can achieve that using an application shell architecture.
Yeah.
Now,
so that's kind of the idea of kind of separating content from the actual visual UI. So in my head, it's kind of like native apps. You always have the banner, you've got the navigation drawer at the side, you might have some other bits. That could be common through like 90% of your app.
Yeah.
You always want it there.
So when we talk about the shell, we're talking about the HTML, the CSS, and the JavaScript that's making up the bulk of your UI.
Yeah,
Stuff that, you know, if you cache that, you can still just like load up content in the very middle.
Yeah.
And save yourself having to constantly reload that stuff, right?
Yeah, and it's super nice when it comes to like, let's say they're visiting a page they've never been to before. If you know the layout's always going to be the same, you can still load that while you go and get the content in the background.
And it just makes sure that your user has like really good perceived performance.
Yeah.
So the first time your app loads, you're going to have to render the shell itself. You'll cache that in your service worker, and you might show like a toast just to let them know, hey, this application now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of Service Worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache. Afterwards, you'll be super fast. But that first load, if that takes so long to the point where the Service Worker doesn't even get registered, that's pointless. And plus, for other browsers that don't support Service Worker, you're then kind of just damaging yourself.
Yeah, that's going to make your users go and cry in a corner.
Exactly.
You don't want that.
So you still want to be serving up just that static render of your site, just so then it just loads up as fast as humanly possible, and then progressively enhance with Service Worker to then use the app shell model.
And if you are using the app shell model, as you can see here, we've got really good, we've actually slashed our load times for first meaningful paint on repeat visits. Speaking of like actually taking a look at what impact server-side rendering has on this, you don't have to use Service Worker to actually be able to get good gains. If you're building with the app shell model in mind, with server-side rendering in mind, you will get like a really good first paint, even in like Safari and like mobile Safari on iOS.
Yeah, all the other browsers that just don't have Service Worker.
Yeah. Now, if you're wondering, okay, well, should I be using the application shell model on all of my applications? There are going to be types of apps, like super simple apps. This might be overkill.
Yeah.
But if you're building something that's a little bit more complex, a little bit more dynamic, this type of model makes a ton of sense. At Google, we're using it for things like Inbox, and it's working really well there.
Yeah, I think it's one of those things you end up falling into the sit there and figure out whether it makes sense for your site or not. But I think it's a good overall model that works for a lot of different scenarios.
There's a whole ton behind this model that we way too much to explain in just one video, but we wrote up a pretty amazing article on this, if we do say so ourselves.
Well, you wrote it up and I just read it. So
You just added your name to the end of it.
Yeah, that's how I
pretty
roll.
much. Impact. That's worth checking out.
That's the format of this
It's a
show,
mediocre
Eddie.
article at best, but it's got pretty graphics.
Yes, it does.
People should go check that out.
Yep.
Learn more about AppShell.
And then there's also the Getting Started guide for your first progressive web app, where it actually talks about the application shell model, how you can take advantage of it, as well as how it applies to the demo app that you can build in this lovely code lab.
And in that article, we also link out to tools that can help you get started with the application model like really quickly that we're working on. So check that out.
Yeah, build a weather app.
So what if I told you there was a way you could compress nearly any stream of data by a factor of 10x or more? Wouldn't that be something you'd be interested in? Yeah, I thought so. Let's find out more on this episode of Route 85. So I want you to take a look at this array of numbers here. Imagine that we wanted to send this array of integers from a server to your user's device. Looks like just a bunch of random numbers, right? Well, that word random is actually the key to compressing these in an incredibly efficient manner. As you probably know, a random number generator isn't truly random. Supply a random number generator with the same seed, and you'll get the same results out every time. And we can take advantage of that fact to recreate that list of integers using a random number generator. You see, all I need to do to regenerate that array on a device is to supply 3 parameters: the seed for an agreed upon random number generator, an upper bound to apply to these results, and the length of the list. I simply supply those numbers to a method that looks a little like this, and I can recreate that original number stream. Just like that, I've built my array of 30 integers using just 2 integers and an int 32. That's a 92% compression rate. Now granted, finding that initial seed did take some work, but you know what? That work can happen in the cloud, so it doesn't really matter. What's important is that on the device, I'm able to decompress that number stream in order and time. And then of course, once you start looking around, you can see that there's a ton of data you can compress this way. I mean, need to compress a text string? Well, what's a string but a stream of encoded integers? Once I have my stream of integers, I simply figure out what seed I need to generate them, and voila, I've compressed my string down into just 3 numbers. It's a pretty amazing savings, right? Anybody with the username of stidjexmisdizixgoodquibpubpa will be singing your praises in their reviews. And my gosh, if you think about it, an image is really just a stream of numbers broken out into several channels. Take a look at this image here, and you can see how, using our random number generator, I've been able to replace it with just 3 sets of integers for the red, green, and blue channels, respectively. Now, once again, finding the right seed can take some time, and I haven't found the perfect seed just yet. So if you look at the results carefully, you can see that this is not quite a lossless compression scheme. But I think you'll agree that for this kind of savings, these trade-offs just might be worth it. Anyway, I hope you consider using this technique the next time you have data that needs to be compressed. Remember, the more efficient you are with your users' data, the more they'll love you. Thanks again for watching. Be sure to check out other episodes of Route 85. And remember that, as my coworkers on the Android team like to say, perf matters. All right, thanks guys. I think we're done.
Who let him into the studio again?
I couldn't say no to Elijah Wood.
But that's...
Elijah Wood.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real data set we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The data set includes 3 different types of flowers. They're all species of iris: Setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at Scikit provided a bunch of sample datasets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a Setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first Setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have 1 flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials, and because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these two examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left, otherwise go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the fourth feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint.
How's everyone doing today? Is everyone super excited about the new Firebase? That sounds like kind of excited, like, you know, like 9, 10 a.m. excited. Let's get like real. Let's be like, you know, 6 p.m. concert excited. Like everyone, how excited are you about the real time? All right, that's a lot better. So I'm here today to talk about 2 things. And those 2 things are real time and offline. And it's kind of funny when you talk about real time and offline together because they're kind of opposites. Because real time is a fresh stream of data, and offline is data that we usually get served from a stale cache. So getting them together, it's not that easy. And trust me, I know. I once failed at a startup doing just this. My startup's name was Kale. And we had one mission, and that was to change the world. And we were going to do that by building a collaborative grocery list app. And if it was going to be world-changing, then it needed to be in real time, and it needed to work offline. So when we went to build our app, we started with the back end. And we were like, OK, we need a server. That makes sense. Then we need a database, because we have to store data. So let's do that. And then we had to build a real-time wire protocol just to talk to our devices in real time. But then there's more than one device, so we actually had to talk to multiple devices. So we had to build a synchronizing mechanism so we could talk to all the devices in real time. And then we also had to deal with offline, so we had to build a local cache on each device that could emulate a real-time server so we could serve the changes to the device like it was in real time on the app. And then after that, once the app went offline and went back to online state, we had to send that data back to the server, to the database, and then update all the clients in real time. So like a year later, we realized, oh my God, we haven't even built an app. So we built an Android app, an iOS app, and a web app. And the Chrome team was like, guys, you only need to build a progressive web app. And we're like, I'm sorry, we can't do that. And they're like, why? And we're like, oh, because we ran out of money. So building a real-time offline app, it didn't have to be this hard, because we could have used Firebase. So Firebase is a suite of integrated products designed to help you develop your app, grow your user base, and earn money. And today, I'm here to talk to you about the Firebase Real-Time Database. And the Firebase Real-Time Database helps you build real-time and offline apps. And the way it works is that every single time one device sends an update to the server, that update is synchronized across all devices within milliseconds. Today, I'm going to cover how you can store data in real time, or store data, and then how to retrieve that data in real time, and then saving data, and then handling offline conditions. So let's start with storing data. So you saw that when I had my little mangly startup, we had this big, complex backend infrastructure. And we were responsible for building this, maintaining it, and hosting it. Well, if we would have used Firebase, we wouldn't have had this problem. Because the real-time database is cloud hosted. And what that means is that you don't have to build it, you don't have to maintain it, you don't have to host it. All you have to do is build your app, and the real-time database will do the rest. So how is data stored in this database? Well, it's just a tree of lists and objects. So if you understand what lists are and objects are and trees, then you know how to store data. So let's take a little visualization. This right here is the root of a tree. We could create a branch that will be a list of grocery items. And then in this list, we can have a set of items that all have values that are a grocery list. Now, if you stare at this structure really, really hard, you might notice something familiar. And that's that this is just JSON. And that's because the real-time database is just one big JSON object that you can manage in real time. So if you're familiar with JSON, that's exactly how you store data in the real-time database. And we call this a NoSQL JSON database. So a lot of people who are coming from a SQL background or something and they're not familiar with NoSQL, they always ask me a similar question. How do you structure your app's data? Like, how should I take this JSON data and fit it for my app? And there's just one rule of thumb that you can really follow. And that's you can structure your data after your view. So what this means is that if our data structure is a list of grocery items, and our app is a grocery list app, then we can take these values and we just map them onto the view. And when you have it set up like this, it makes it really easy to read your data in real time. So let's see how we can use the real-time database to synchronize our data across multiple devices. So this is the way we did our backend with Kale. It was not really great. We never really mastered real time. So what we would do is we would send a request to our backend, and then we would get a response, and then we could render an item. And while that was just great for one device, the other device has no idea anything has happened at all, because we don't have a connection from the database to this device. So it's always left in the dark to any changes. The real-time database, though, has a persistent connection to every single device. So when data changes, it knows what devices to send that data to. And we can do this using the real-time database SDK. So the SDK works on Android, iOS, and JavaScript. And with this one line of code, you can create a connection to your database. And this is more than just a connection. This database reference class, it gives us a lot of control. Because database references are a handle to an object or a list. So when you create a reference to this piece of data, you have control over it. And it allows you to read this data in real time. So the first reference you usually create is called the root reference, because you're pointing at all the data in your database. And likely, you don't want to read all the data in your database because you're a smart person, and you only want to read just a subset. So let's say we want to get the grocery items. Well, to do that, I can create this child reference, and I can pass in the key of my grocery items. And now, I have access just to that list. And using real-time events, I can stream this data in real time. So the two types of events I'm going to cover today are value events and child events. So the way value events work is you can attach them to this database reference. And so what you're essentially saying is every single time data changes in this location, send me an update. And we can receive this update through a callback. And this callback is fired with a data snapshot, which is our synchronized data set. And it's really important to understand that we are synchronizing application state. We're not just sending back updates. And to understand what that really means, I set up this little debug station. So at the top, we're just assigning a value event listener to our grocery list. And then below, we're going to be logging the results to this console. So the first log from the database is going to be our list of items. So we can take this list, and we can display it on the view. Now, let's say a user comes in and adds the item of coffee. What do you think is going to happen inside on data change? So you might think that, well, we added an item of coffee, we're going to get that new item back in on data change. But that's not exactly what's going to happen. What's actually going to happen is we're going to get the entire list, including the newly added item. And that's because this is our synchronized application state. It's the true state of our list. And you might think, like, that kind of sounds inefficient, that if I just add an item, I download the entire set. Well, the real-time database SDK is a little bit smarter than that. And what it tries to do is it tries to take delta events from the server, and so that only taking the item that was added and then piecing that together with your local state. So it becomes bandwidth conscious. So value events are a way for you to synchronize the entire value of an object or a list when anything changes. But sometimes you want a bit more control. You may not want to get the entire object or list back, and you might just want to get one thing at a time. So I might want to know when only items are added, or if items have been deleted, so I can display a fancy little animation. And so that's where we can use child events. So child events are similar to value events in the sense that we can attach them to a reference, but they provide us with more than one type of callback. We can tell when things have been added to our list, when the item's value has changed, and we can even tell when something has been removed. So to see how this works, I have that same debug screen up. And the very first event that gets fired is the child added event. And this gets fired for every item, one at a time, that's existing in this list. So I'll first see it for each item at a time. So as I go through, we add an item, and then we render it to the view. So this gives us single control, one at a time. And let's say we go and we want to remove an item. So if a user goes and swipes an item off a list, well, this is going to fire off child removed. And what this will do is when this fires off, it fires off on every connected device. So every device knows how to remove this item. So let's say we change one item, and we change from coffee, and we want more coffee. And what that'll do is it'll fire off child changed, and then we, again, get a callback, and we know this is the item that needs to be changed in our list. And so this is a lot of events. And these provide you a lot of control of how you synchronize your data. But sometimes you'll find yourself writing a lot of boilerplate code to get this to work with common components on your platform. So that's why for Android and iOS, we built Firebase UI. And what Firebase UI does is it takes these database references and it pairs them up with a recycler view on Android. So you can take this database reference, pass it to our Firebase recycler adapter class, and then every single time an event fires off, we will serve that change and bind it to your view holder. So it handles all of the eventing for you. And if you are an iOS developer, it does the same thing with UI table views. Every time something changes, it takes that change and binds it to the UI table view cell. And if you're a web fan, we have integrations with pretty much every major JavaScript framework. So whether that's Angular, Polymer, Ember, or React, we have integrations that work with your style of flow. So that's how you retrieve data in real time. But that's only part of the puzzle, because to trigger real-time events, you have to know how to save data. So how would we add an item to our grocery list? Well, we know that the initial reference points to the entire database, and that if you create a child, it points to just a piece of the database, just the list. Well, we can again go and create another child from that list, and that gives us an object that we can save a value to. So in this case, we're creating a child underneath the list, so a new grocery item. And we're giving it a key of saying it's the second item, and we're giving it a value of coffee. And the way this works is that when one item sends this update to the real-time database, it's going to trigger a real-time event for each connected device, and then we're going to render that device, or render that item onto the view. And this is what your data flow looks like with the real-time database. You save items and trigger real-time events. And so we can keep our entire application state in sync just through this pattern. But sometimes there can be an issue. Let's say the other device goes, and they also add an item using that same key of item underscore 2. Well, that's going to trigger a real-time event, but it's going to delete the item of eggs. It's going to add the item of coffee. And that's because we use the same key name. And what this is called is a collision. So we're colliding by using the same key name. And the real-time database SDK has a really simple way of fixing this. So we'll go back and create our grocery list reference. And then rather than creating an explicit child, we're going to call this method called push. And you can think about it like if it was an array, and you're just pushing a new item onto the array. Because what we're doing is we're actually creating a new item onto our list in real time. But this item we create, it has a unique identifier. In this way, when we use this, we know that we will not be colliding with any items that exist in the database. And when you know that you're not going to have collisions, it sets you up to work offline. So when we were building Kale, we had some serious problems with offline. We were a grocery list app, and then people would go to the grocery store, and then turns out grocery stores are known for having pretty bad connections. So they couldn't even use their app in the store. And so when we went to fix this, we ran into an issue by the fact that real-time, or that offline, it really manifests itself in more than one way. So the real-time database handles offline in two ways. The first is intermittent offline. And this works for every single platform, so Android, web, and iOS. And this is like if you go into an elevator or a tunnel for a short period of time and your connection drops. Well, the real-time database SDK puts a local in-memory cache on your device. So if the connection drops, we can serve these changes through this cache. So it'll work offline just as it did online. But sometimes you might be going offline for a bit longer. And you might be getting on an airplane, going through a hike in the wilderness, or you just might be spending a really long time in the grocery store. And in these cases, you're likely going to turn off your phone, you're likely going to restart the app, and when you do this, it's going to clear that in-memory cache. Well, the real-time database has a simple way of fixing this for Android and iOS. And what it allows you to do is just in one line of code, you can enable a persistent cache on your device. And what this does is if the user goes offline and they clear out of the app, their data will still live on the device. But what happens when they go online? And what happens if they were using the app when they went offline and they were writing to the database? Like, what happens then? Well, the device, as we know, stores this data in a persistent cache. And when it goes online, it just sends that data to the real-time database, and that merges the changes on the server and then sends a merged update to every device so everyone can get back onto the same page. So that's how you do real-time and offline. But I wanted to talk a bit about security. Because we're writing all our code on the client. So how do we keep everything secure? Well, the real-time database comes with a set of security rules, which are a declarative way to say who has access to what pieces of data. And this integrates with Firebase authentication. So you can log in users and then secure data against them. And I'm not going to go too much into detail on this because Jacob Wenger, an hour ago, gave a talk all about Firebase and security. And if you want to see it, you should check out our YouTube channel that we just launched the other day, where all of the I/O videos are going to be on, and also a series of screencasts called Firecast, which is going to teach you everything you need to know to get started with the new Firebase. And also tomorrow, you should check out Zero to App, where 4 of my colleagues are going to get on stage and live code the same app on Android, iOS, and web integrating the real-time database with Firebase Auth in Firebase Storage. So in this talk, we covered storing data, retrieving it in real time, saving data, and handling offline conditions. So now you know how you can use the real-time database to build real apps, now you know how to use the real-time database to build real-time apps with Firebase. And if you build something, I would love to know about it. So you can get started and then send me a screenshot, send me anything, a gist or whatever of what you built, and I would love to take a look at it. So that is what we have for today, but for more information on Firebase, you can check out our office hours or head over to our Firebase tents, and we'd love to answer your questions. And just know that when you build with the real-time database is that you're getting the best of both worlds, of both real-time and offline. Thank you guys very much.
Did you know that the average user has 36 apps on their device and doesn't use 3/4 of them most of the time? And of those, about 1/3 of them have only ever been used once. Well, what if that's your app? You've done the research, you've written the code, you've performed the testing, you've perfected the design, you've gotten the installs, and then nothing. So, how do you prevent this? App indexing helps you re-engage with your users through tight integration with Google Search. As well as appearing in search results, it surfaces your app through autocomplete and now on tap. All you have to do is get your app in the index. And when users search for the content that's already in your app, they'll be able to see your app directly in the search results and be able to launch it right from there. It's as easy as that. But how does it work? If your app and site have similar content, you associate them with each other. Then your app can receive incoming links from search. On Android, these are achieved using standard Android app links, and on iOS, using standard iOS universal links. When a user searches for your content, they can then find your app. If you have the app installed, it will allow you to link directly to it. When the app launches, it sees the address of the index content and decides which screen to load to show it. It's really as easy as that. You can also use the App Indexing SDK to submit content to the search engine based on how people use your app content. When people use your app, your search position can be improved. With app indexing, you get into the index, putting your app into Google Search, and allowing you to re-engage your users.
Hello, I'm Timothy Jordan, and this is The Developer Show. I'm standing here with Susan Koger, who is the co-founder and chief creative officer of ModCloth. Susan, welcome.
Thank you.
How are you?
I am wonderful.
Me too. So we're going to talk about entrepreneurship and maybe some advice that you have for startup founders that are happening to be watching. But first, and I know you've told the story like a billion times, I'd like to talk to you about the origins of ModCloth. Is that okay?
Yeah, of course.
Okay, so here's my very specific question. You're sitting there in 2002 with Eric, your then boyfriend, now husband and co-founder, and you're thinking to yourselves, wow, Susan's really good at antiquing. Maybe we should spend all of our free time making this into a business. Like, how do you cross from one idea to another?
Yeah.
How did that happen?
Yeah, I love it. Like, I built ModCloth while I was an undergraduate at Carnegie Mellon. You know, just for me and like my style of leadership and like, you know, what I know about myself, I lead very instinctually. And I think we did a lot of things, you know, just me and my husband being in the business and, you know, kind of almost like having a beginner brain kind of approach to things. So you do have to, so I think it was very instinctual at first. You do have to like codify those things and actually step back and think about them and think about, you know, what's working. These are the things that we've kind of just done. What's working from this list? what can actually scale and what doesn't, what needs to go away, what new things need to be added in. You know, for me, it was starting ModCloth, like deciding to work on it full time once I graduated from CMU, because I did it part time while I was at school. You know, I was at the stage where I was like, man, if I can just like do this and I can support myself and maybe, you know, hire a few people to do the stuff that I don't enjoy doing so much, like packing boxes is really fun, but you don't necessarily want to spend 4 hours a day doing it, which is kind of what I was doing when I hired my first employee. Yeah, you know, like I was like, man, if I can just support myself and like create this job and like, you know, let's see where it goes. And it's just like continued to go and grow. And yeah, I feel really fortunate to be able to do it.
Okay, so here's a question based on kind of what you were saying about having like this job for 14 years. I can't imagine it's the same job. And I have some data to back that up. In 2012, 50% growth to 100 million in sales, and in 2015, 150 million in sales. There's no way that you can get that growth and still be doing the same thing every day. But I'm curious, like, what the rate of innovation is. How often does your job change, and how often do you have to find new strategies to grow even bigger or to deal with that growth?
Yeah, it's a really interesting question, and I think there's been so many phases, and I used to feel like my job was changing almost every quarter. Because honestly, it was just like we were growing so quickly. I want to say in 2010 we hired, we had 100 people at the beginning of the year, and we hired 150 that year. So we went from like 100 to like, I think 225-ish by the time the year was out. But it's so different, and like there's no way that you can hit the level of scale that we've gotten to, or hit any scale at all, without being able to let other people in and, you know, empower them to do the things that they do really well. So part of the process for me has been learning like how to be a leader. As much as we've gone from nothing to where we're at today with like 350 full-time people across 3 locations, you know, the sales numbers that you referenced, we're still a small fish in the big fashion sea. Like it's a huge industry, and one that is ripe for innovation, and we're doing things differently and in a very cool way, I think.
Okay, so clearly you've been at this a long time, and you've used a number of different ways to really help keep the spirit of the company alive. Let me just kind of like tag a few of them that I think I heard. One is that you had to be really innovative, and you approached it with like this beginner's mind. Like that's such a cool idea that it's like, what's the company we want to work at? And you put that into ModCloth from the beginning. And I think the other big thing that I heard is that you built that into the culture, so that throughout it wasn't just like a list of rules, but something people carried with them as part of ModCloth.
Yeah.
Does that sound right?
Yeah.
That's really
definitely.
cool. Okay, I have one more question for you, and this is an advice question. There's somebody out there who was where you were in 2002. They have a passion for something that they think they could make into a successful startup. Where do they start?
I think, you know, the first thing that I would say would be to ask for help and do it all the time and be very concise and know what you're looking for at all times, right? You know, if you're doing something for the first time, if you get better, your taste is going to get better. And you're going to look back on that stuff that you did early and you're going to cringe at it. You know, like I look back at the first logo that I designed for ModCloth at our first website, you know, at our first photo shoots, and I'm just like, oh my God, you know, it looks so bad to me now. And I didn't think that when we launched it, you know, obviously, like I cared very deeply about it. It was the best I could do. So I think that sometimes we get scared to just put something out there because, you know, it's scary, it's vulnerable. You're putting something out there, people might like it, they might not. It's like, oh my God. But here's the thing. You like, if you're gonna succeed, you're gonna get better. So you gotta start somewhere.
Okay, so don't be afraid to ask for help, and you just gotta get out there.
Yep. You gotta get out there and put something out into the world. And you know what? It's probably gonna suck, and that's okay. Or it'll be great, and then you'll look back at it 5 years from now and you'll say, wow, that kind of sucked. I mean, I'm sure, yeah, like, you know, and then you'll look back at it and you'll be like, oh, this is actually kind of cute and retro.
Susan, thanks so much for joining me today.
Yeah, thanks for having me.
For more information about ModCloth and maybe we can put some of your favorite blogs and blog posts in the notes as well.
Amazing.
Check out the show notes below. See you next time.
What's more fun than pair programming? Asynchronous, remote, massive scale pair programming. In 2011, I presented an I/O session, Pro Tips for Building Context-Aware Apps. Those tips went into a sample app that targets Android Honeycomb and supports Cupcake. That's Android 1.6 if you're keeping track. That covered 98% of active devices in 2011. Today, it's less than 3.2%. Clearly, it's time to do an update. I asked if you'd like to watch me go through the process of updating the app, and you said yes. So, despite some skepticism,
You know they're just trolling you, right? Nobody wants to watch you write code on YouTube.
I don't know, there's like the Facebook movie, Silicon Valley, CSI Cyber, Scorpion. These are all really, really popular, and this is a lot like them.
This is nothing like them.
Whoa, wait, you haven't been telling people that this is like them, right? Because this is nothing like them. This would be boring.
strong skepticism, I'm giving it a shot. The result is Pivotal. It's a lot like Serial.
It's not like that either.
Each episode is part of a larger story. Having an app targeting an API that's fallen off the sliding scale of relevancy is a great opportunity to replace tricks, hacks, and deprecated APIs with a robust modern architecture. That means integrating the Android support library, the Fuse location provider, the job scheduler, material design, enhanced notifications, Android Wear, and all the features of Ice Cream Sandwich, Jelly Bean, Kit Kat, Lollipop, and Marshmallow. And everything else I don't yet realize needs to be updated. You won't see much of me, but imagine me here, dressed neatly at a tidy desk, with a warm cup of tea. Definitely do not picture me with my feet up on a messy desk, and absolutely not me at home in my pajamas. Picture me here, in my happy place.
Rado, we're gonna need you to clear out of here. We've got another shoot. Can't you do this at your desk?
I'm Rado Meyer. Join me on the Android Developers YouTube channel as I bring an old app back to the future, here in my office. Welcome to Pivotal.
There's something really satisfying about getting your app to look great on your device. But just because there's over 11,000 other Android devices out there doesn't mean you need to build 11,000 other layouts to make a great-looking app. Not if you're using responsive UI principles. You may have noticed that I'm not Ian or Joanna. My name is Mike Denny, a design advocate on the Google design team. First things first, thinking about specific phones and tablets is only going to get you into trouble. There's a wide spectrum of devices and not that much difference between the largest phone and the smallest tablet. Instead, think more generally about how much space you have to work with. This can come in 3 different flavors: width, height, and smallest width. Width is super important and should be the basis for breakpoints in designing and building your UI. For example, 600 dp in width is the first point where you could consider having a side-by-side summary and detail level view. Any lower and you won't be giving each level the full attention it deserves. Height is less common when designing responsive UI, but keep in mind that something like a vertically scrolling container is going to be difficult to use if you can only see 1 or 2 elements at a time due to a constrained height. Smallest width, unlike height or width, is designed to be rotation insensitive as it's just the smaller of the 2 values. This gives you a better idea of how much space is available and is an easy way to ensure that your app remains consistent as the device is rotated. You don't want to force your user to relearn your navigation structure every time they rotate their device. This is particularly important in the multi-window world. When your app is resized, your width, height, and smallest width are going to be updated. You might be going from full screen on a tablet down to what amounts to a portrait-oriented phone worth of space. Here's where a good responsive UI can make for a smooth transition. There are a number of common patterns you might consider when building that responsive UI, such as revealing previously hidden content as the screen size grows, transforming your navigation pattern or switching from a list to a grid, dividing your screen into multiple sections side by side, reflowing specific elements, expanding the size or margins of individual elements, or even changing the position of specific elements like a floating action button. Check out the blog post for more details on designing responsive UI and specific patterns you can use to build better apps.
Hey gang, did you know you can send notifications to iOS devices using Google Cloud Messaging? Well, you can. Why would you ever want to do that? Maybe that's a better question. Let's find out the answer on this episode of Route 85. So, notifications. They're a great way for you to engage with your users. They let your customers know you have important new information for them, and when used responsibly, they can be a great way to keep users coming back to your app. But they're not super fun to implement. There's a lot of steps required to set up notifications in the first place. You need logic on both the client and the server, and if you're developing a cross-platform mobile app, and most of you are these days, you have to do this for Android and for iOS. And I'm not just talking about two sets of client logic either. It turns out sending notifications to iOS and Android devices requires different logic on the server too. See, if you've done any notifications work in the past, you're probably used to talking to APNS, that's the Apple Push Notification Service, to deliver notifications to iOS devices, and to GCM, that's Google Cloud Messaging, to deliver notifications to Android devices. And while sending notifications through these two services is similar, they each have slightly different features, use different protocols, accept different message payloads, and return different responses, all of which means that you got to keep track of what kind of device each of your users has and use two completely different code paths to send a notification. Or do you? Well, no. No, you don't. You see, one pretty great feature about Google Cloud Messaging that a lot of people don't know about is that GCM can relay to APNS any notifications you want to send to an iOS device. Now granted, you'll need to do some setup work like upload your APNS certificate to GCM and make sure your client sends its device token to the GCM service. But once you've done that, you can use GCM to send all of your notifications, no matter what platform your target device is, and GCM will deliver your notifications to the correct device using the appropriate service. What all this means is that you don't need to care about what device your user has anymore. You just have to write and maintain one code path, and as we all know, less code means less room for mistakes. But it's not just about using less code. By using GCM to handle your messaging for you, you can take advantage of some of the other nice features that GCM offers to developers, like topics. Topics allow your app to subscribe to notifications about any particular topic that you or your users want to. For example, let's say you've got a weather app and I, as a loyal weather fan, want to be notified whenever there's extreme weather happening in my zip code. Well, in the old way of doing this, you'd probably need to set up a database where you keep track of each one of your users and their devices and their zip codes and do this whole select users where blah 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 query, then loop through the results and send notifications to each device that you get back from this database query. But with topics, none of that's necessary. Instead, your app simply tells GCM that you're interested in subscribing to, say, the weather 94043 topic. Then, next time there's rain in California, for us that counts as extreme weather.
Oh my gosh, there's something coming down from the sky. I don't know if it's water or if it's acid. I can't go out. I don't know how to drive anymore.
Yeah, that seems about right. So yeah, with topics, your server simply tells GCM to send notifications to all devices subscribed to the weather 94043 topic, and I will get notified along with all other devices subscribed to that topic. So there's no database required. Go ahead and throw it out. Oh, as long as you weren't using it for anything else, I guess. I probably should have mentioned that earlier. GCM has other useful features too, like upstream messaging, which allows your app to communicate to your server through GCM. This can be helpful in cases where you might want some lightweight communication from your clients to your server, but don't feel like dealing with the hassle of setting up and maintaining a full-blown server open to the entire world. Or read receipts, where in some, but not all situations, you can be notified that a user has received your message, something you can't normally do through APNS alone. Oh, and in case you're wondering, all this is free, as in please send us $0, and it's using much of the same infrastructure that Google uses for its own apps, so it'll probably scale for yours. So there's a lot to learn when it comes to notifications, and I encourage you to get started here with our Google Cloud Messaging documentation for iOS. We also have a couple of sample applications for you to look at. There's Friendly Ping, our cross-platform chat app powered entirely through Google Cloud Messaging, as well as the GCM Playground, which lets you easily experiment with sending calls through the GCM service. And keep watching Route 85. Maybe you'll see another Google Cloud Messaging video pop up in the future. If only we had some way of letting you know when that happened. Well, I'm stumped. Consider the simple URL. A few years ago, these were pretty straightforward. You clicked on one and 9 times out of 10, you went to a web page. Then things changed. People started using their mobile devices for, well, everything. And these devices in turn started supporting the idea of deep links. Click on one of these deep links and it could take you not just anywhere on the web, but anywhere in an app as well. So you could use a deep link to point directly to a specific restaurant inside a reservation app, or give your new customers a personalized welcome based on the link that brought them to your app in the first place. At least, that's how they worked in theory. In practice, deep linking had issues. The same link wouldn't necessarily work on an iOS or Android device, and they behave very differently, or didn't work at all, for users who didn't have your app installed. And for people who did install your app through a deep link, all of that great link info was typically lost during the installation process, leaving your personalized warm welcome out in the cold. So while deep links were great in theory, their uses were a little more limited in practice. Enter Firebase Dynamic Links. Firebase Dynamic Links are deep links that work the way you want them to. So you can create one single link that behaves one way on iOS, another on Android, and even a third on a desktop browser, and it will take you to a place that's appropriate to that platform. You can also set up dynamic links to change their behavior depending on whether or not your user has your app installed. For users who don't have your app installed, maybe you send them to your website, maybe you take them to the Play Store, or maybe you show them an interstitial describing the benefits of your app before you take them to the App Store for a smoother transition. More importantly, these links can survive the App Store installation process. So if your user installs your app when clicking on a dynamic link, all of that information is still available to you when your user opens up your app for the first time. So what does this mean? It means you can use dynamic links the way you've always wanted to use deep links. You can use them in marketing campaigns, from email to social media to banner ads to, heck, even QR codes. And in addition to install attribution tracking, you know, the kind that lets you know which campaigns are getting you the highest quality users, you can also give your users a customized first-time experience based on the campaign that brought them there. So if a user installs your music app because you showed them an ad for classical music, you can make sure your app takes them right to Chopin's latest hits when they first open it up. Dynamic links are great for sharing too. Your users can use them to share recipes, links to their favorite level in your game, or even coupon codes. In fact, dynamic links are the technology that powers Firebase Invites. And because dynamic links are a Firebase product, you can see their stats directly through the Firebase console. Find out how many people clicked on a link, or use Firebase Analytics to find out which of your users first opened your app through a particular link. To find out more about dynamic links, check out the documentation here and give them a try. And deep link away.
Bitcoin represents a way to transfer money anonymously and at almost no cost. And since it's an arbitrary currency with no nationality attached to it, you're free to exchange it with anyone in the world. What is money? Resources are limited, and they hold explicit value to people. Most resources are physical, and such needed to be traded in a physical form: diamonds, gold coins, chickens, or bikes. At some point, it becomes too difficult to physically transact those objects, and it's easier to agree, collectively, on the value of cash instead of gold. As we know today, this has many advantages. Credit cards and the modern banking basically gave us another abstraction layer on top of cash. There is a centralized system which defines who owns what resources. All of these trades are made virtually. This is the backbone of why Bitcoin is a valid idea. What is Bitcoin? Bitcoin is decentralized, anonymous, digital-only currency that recently received public attention. Bitcoin was originally developed in 2008. Like in any good mystery, someone using the alias Satoshi Nakamoto published a paper describing how Bitcoin could work. There's a very interesting story about this guy too. He must be very smart, but he never came forward to claim ownership or any part of the revenue. Just 1 year later, in 2009, Bitcoin started being traded. Where do they come from? Think about gold. You could buy it or mine it, and it's the same concept with Bitcoin. You do this by using your computer to hunt for 64-digit numbers. By having your computer repeatedly solve complex mathematical puzzles, you're competing with other miners to generate the number that the Bitcoin network is looking for. If your computer generates it first, you receive Bitcoins. The Bitcoin system is programmed to generate a fixed number of Bitcoins per unit of computing time. It is also self-sustaining, coded to prevent inflation, and encrypted to prevent anyone from disrupting its code. In the year 2140, the total number of Bitcoins in circulation will be capped at 21 million. So how much is a Bitcoin worth today? You'll need to Google it. Just type Bitcoin in US dollar, for example. You could also check it out at priv.com. Why are they anonymous? Bitcoin are pseudo-anonymous because they are built upon this centralized system. The Bitcoins themselves are anonymous, the wallets are not. Here is why. The base algorithm creates anonymity, but as the recent court cases show, if your Bitcoin wallet is identified and attached to a person, then someone can go through and track every transaction you've made. Bitcoins exist entirely on their own because there's no central infrastructure to shut down. You are identified by nothing more than your Bitcoin wallet address, a string of randomized letters and numbers. There are absolutely no identifying characteristic beyond that. For the paranoid dude, you can simply create a new wallet for each transaction. Here are some interesting startups that push the technology forward. We are still in the initial phase of Bitcoins, and there are many challenges and opportunities ahead. Exchanges, wallets, merchant services, security, and more. But this is something for another episode. Until next time, eat your vegetables and listen to your partners.
One word that's the bane of both the novice and expert programmer alike: threads. I'm Joanna Smith, and threading can be one of the greatest perf improvements you make, but it will also likely drive you crazy. Tom Sawyer illustrated threading perfectly a long time ago when he needed to paint that fence, because when you've got a large chunk of work to do and it's the same work over and over again, you call in some friends to get it done quickly. So for computations that are taking a long time, consider calling in reinforcements with threads. By allowing multiple threads of execution to operate on your dataset in parallel, you reduce the overall time required to complete the task. With Android, threading becomes especially important because the entire app runs on the main thread, which is also called the UI thread because it updates the UI. And when the UI stops responding, users stop using your app. So, when you want to perform some complex action in response to a button being pushed, for example, you'll want to move that off the main thread until it is finished so that the user can continue to interact with your app. Because there are a few things worse than the dreaded application not responding dialog. However, integrating threads into your system is not for the faint of heart. You're going to have to rethink your entire approach to computational complexity and to your memory model in order to properly integrate threads. So, to avoid the rabbit hole, take advantage of the Android framework, which has been built to help you out. Careful thought and planning about your app's structure and flow will enable you to determine whether a thread should affect the UI or be entirely hidden. APIs like Async Task and Thread both help you manage the work and keep your app from hanging, but Async Task will also allow you to affect the UI, like when you want to display a progress dialog. So take a walk through your own app and see if there are places where it stops responding or gets exceptionally slow in response to a user action, and then move all of that extra work off the main thread. But, thoughtfully. Don't just change things willy-nilly. Because while threading may be intimidating, it shouldn't scare you. What is scary, though, is bad performance, which is why you should check out the rest of our Android Performance Patterns content and consider joining our G+ community for tips, tricks, and help. But most importantly, keep calm, profile your code, and always remember, perf matters.
Hello and welcome to Supercharged. Now this is a kind of TLDW. Last week I did a live stream with Surma where we made some swipeable cards. Now you probably recognize swipeable cards from things like Google Now, where you just kind of take a card and you dismiss it. And you can actually see what I've got on screen. This is what we ended up making. There you go, you see? Dismiss it and all that kind of good stuff. Now the idea is, if you've not got an hour to watch that live stream back, although if you can, I would recommend it, and you can find the link to that below. If you can't, that's exactly what this is for. I want to step through the things that we learned, the things that we did, and just so you can get an insight into what actually went into it. So, before we actually get started, what I want to do is I want to step over to Theory Corner. Oh yeah, theory. Love theory. And what we can do in Theory Corner is discuss what we need to do. Join me. Welcome to Theory Corner. You can tell it's Theory Corner because there's some theory in a corner. Now, this is what we have. We've got the cards. You can tell it's a card because it says card. The cards have will change transform on it. The idea I have here is that we want each card to be transformed around the screen. And so we want to give each card its own layer. The compositor then can move those around with the help of the GPU. So long as we stick to transform, opacity, and we set will change, we should be good. So we move the card as you touch and swipe, but as you get across to this side, we have this marker of like 0.35. Now I picked that at random. You could pick a different number. 0.35, if you go past that point, we basically say, well, this card is being dismissed, so we slide it off to the side. The other thing that we're going to do is we're going to change the opacity. So the further you go across, the lower the opacity in both directions. So that works there. Okay, so we're going to put each card on its own layer, and shift it side to side, and fade it out. Let's go back to reality. What we're going to do here is we're going to step into the code so you can actually see bit by bit what we actually did. Here's the cards, and what we do first of all is we basically create an array from the cards that we've got in the document. So we'd have to have some kind of code that adds and removes those cards later on, but don't worry about that. We'll just get on with what we've got here. The next thing to notice is that I've got these named functions on start, on move, on end, and update. Now the first three are our input events, and I choose to do it this way. What I do is I take a copy of it by calling .bind on this, and that takes it from the prototype into the actual instance. But it does another thing for me as well. It means that it's bound to the instance so that in those functions, when I say this dot whatever, is actually applying to the instance and not to the target's event. No, wait, the event's target. Oh, one of those two. So it also does something else for me. It means that I can do add event listener and remove event listener, and I can call it by name. I can say like this dot on start, for example. You can see that down here in the add event listeners. So I do add event listener for touch start, touch move, touch end, mouse down, mouse move, and mouse up. All of them. Yay! And I can just basically say on start, on move, on end, and so on. And if I wanted to do the remove event listeners, I could do that, and that would just work out fine for me. So we've got our event listeners, and we have a bunch of variables here that are just sort of housekeeping, things that we need to keep a track on. The other thing I do is I start a request animation frame where I busily sort of kind of do an update. Now, if you're doing this in production, I would suggest you don't do it quite like this. I would start the request animation frame when the user starts interacting, and then when the animation's finished, I would stop doing the request animation frame loop. But for the case of this, just to keep things simple, I just start it right at the start, and I do a kind of busy loop through. So what do we actually do in the on start, on move, and on end event listeners? Wow, saying event listeners over and over and over and over and over again, that's not confusing for me. No. What do we do in those? Well, first, in the on start, the main thing is this. We basically take a marker for the start position of the interaction. Where does the user put their finger down on the screen? And then we get that with page X. The other thing we do is we take a copy of that for the current position, because as we move our finger, we're going to update the current position so we know where we started and where we currently are, and the difference is how far we want to transform the card. The other things that we do in this is we set the dragging card to say true, but as we discussed in Theory Corner, we set will change to transform. Now we can check that that actually works by going back to the code, bringing up DevTools, and in the rendering settings, we're going to show layer borders. Anything that's got its own layer is going to go orange around its border. You ready? So when I click, you can see that immediately the card gets its own layer, which is really cool. That means that we can transform and move it around cheaply, like we discussed over there in the Theory Corner. Here's what we've got in the on move. It's fairly straightforward. All we do is we take the current position of the input and we basically say that's the current X. Now inside the update, what we can do is we can say if they're dragging the card, the screen X, which is basically the position of the card on the screen, is the current minus the start. That's basically how far they've moved. And we can apply the transform to account for that. Ta-da! Now when the user stops interacting, we actually have to make a decision. If you remember over in Theory Corner, we said if the user is past that 0.35 marker, so it's a sort of a 0 to 1 range, 1 being the full distance of the card, 0 being not at all. If they go past 0.35, which is what I've chosen, but you could choose a different number, what we want to say is they are dismissing the card. And we do this by setting a target X, which we use later on in the update. And here we do screen X plus equals the target minus the current screen X over 4. What this is going to do is it's going to ease the card to that final position, which will either be the center or it'll be off to the side, depending on whether we've decided that they've gone past the point of dismissal or not. Then there's a little bit of tidy up that we do here. We basically normalize the drag distance and we use that to set the opacity so that the further across you get, the more fadey the card is. Ta-da! So far, so good. So the last little bit is what we do when you dismiss the card, because what we want to do is we want to slide all the other cards into place. And we do that with this animate other cards into position function. Let me show you what it looks like without that. I'll switch off the layer borders. Okay, here's what it looks like without that. You see all the other cards just snap into place, which you could do, but doesn't look quite so nice. So what we need to do is we need to transform them down quickly to where they moved from, which will be the height of the card plus the margin. And you can see that here. So we take every card that's after the current one, which is this, and we basically say translate yourself the height of a card plus 20 pixels, which is the margin. And again, this is hard coded, so you'd probably make this more dynamic in production. And then we basically go from that to no transform at all, and we use an easing of this cubic Bezier and a duration of 150 milliseconds. And all we need to do is just say card.animate with those settings, and then when you've finished, we say the animation's complete, at which point we can just reset the target and call it a day, and the animation's done. So with that switched on, you can see we get a nice smooth animation. So the only other thing to notice is when I'm dismissing the cards, you can see that the other ones get their own layer temporarily. This is because we're using element.animate and we're using a transform, and that means that those get temporarily promoted to their own layer. Cool. That means that it's also doing the same thing that we had over in Theory Corner. We're getting its own layer, which means it happens nice and performantly, and then when it's finished, the browser automatically demotes them back, and we're all good. So there you have it, that's swipeable cards. If you've got time, make sure you watch the live stream. There's loads in there. There's us finding and fixing bugs. There's just chatting about the general approach. All sorts of goodies in there. Hopefully you've enjoyed this little TLDW. Don't forget to subscribe to the channel, and I will catch you on the flip side. Welcome to this supercharged TLDW. I'm Paul. If you didn't catch the live stream with me and Surma last week, well, basically we built a side nav. Let me show you what we built. So you've got your standard app bar here. You can click on this sidebar and you can click on the background, or you can dismiss it with a sort of drag gesture like that. Awesome stuff. So let me show you how we built it. But before we do that, as usual, we're going to head over to, yep, you guessed it, Theory Corner. Join me. Hello, welcome back to Theory Corner. So this is what we've got. We've got our page and we've got a container element. The container element is going to be the home for the side nav and the background. What we're going to do, first of all, is we're going to put overflow hidden on this. We're going to make it take up 100% width and height. So it's got overflow hidden because this is going to transform out to the side and we don't want any scroll bars. So we put that in place. The background, we're just going to transition its opacity from 0 up to 1, and we'll set it to have a transparent black color, or semi-transparent black color in the background. The other thing is this side nav. We want this to slide in from the side, so we need to have will change transform on it so that it gets its own layer, very much like we did with the swipeable cards, and then we can transform it in and out. We're also going to need some buttons for bringing it in and out, and we're going to have some touch events so that we can do the dragging stuff. All cool? Let's go back to reality. Welcome back to reality. Oh yes, yes, reality. That's where you'll find us today. Pragmatic to the end. Code. Okay, so the markup and the CSS is pretty much what we discussed in Theory Corner. We've got an aside, we've got a few JS classes here so that we can pick it up in the JavaScript, but mostly it's pretty much what you'd expect. There's a button for closing, there's a button for opening, we've got the title here for side nav, and then we've got the list of the side nav content. In terms of the CSS, here's what we've got for the background. You can see it's actually done with a before pseudo element, and you can see that it's got a background of black with an opacity of 0.4. We switched on will change opacity because we know we're going to be changing the opacity, so we're going to say will change opacity. Didn't say will change pasty. That would be a different thing entirely.
That's our 45 minutes. Starts right after that. All right. Okay.
welcome to this talk. I am Raghavan, a product lead on Firebase.
I'm Todd Kerpelman. I am a developer advocate, also on Firebase.
So,
yeah! Get excited! Woo!
yeah, in this talk.
Now I'm going to sit down.
In this talk, we're going to cover dynamic links. So as you know by now, these are part of Firebase. And Firebase is a suite of products that help you develop your app, grow your user base, and earn money. And in this talk, we're going to help you use dynamic links to make your marketing URLs much more effective. So dynamic links are mobile deep links that work like you always want them to. So once upon a time, URLs used to be really easy, right? You click on them, and you go to a web page. But then, people began using deep links, which link directly into an app. And they actually enabled some very nice experiences. You could click on a link on a mobile web page, and it could take you directly into an app where, for example, you could make a reservation right there from the app without losing any context. This was really nice. But here's the problem. If you want to provide the best experience when a link is clicked, well, that depended on quite a few things. For example, if the link was clicked, was the app installed? And if the app was installed, how the app gets opened depends on which platform and which OS version it is. If it is iOS 9, if it's Android M, you could open it using HTTP deep links. But if it happened to be clicked on an older platform, well, you got to use a custom scheme or something else. And if even if it was a newer platform, like on iOS 9, if the link was clicked in a web view, well, web views don't obey universal links. It depends on the containing app that contains it. And if the app was not installed, well, you have to make a choice. Do I install the app, or do I take them to a mobile web view? And even that depends on where the user is coming from and what they're doing. So this can get a little complicated. Even worse, sometimes you create a link, and that takes the user to the App Store to install the app. And when they install the app and open it, the app, you have lost all context. The app does not know where you came from or why you're here. So we created dynamic links to solve some of these issues. So let's have Todd come on up and explain how to build smarter links for your apps.
All right. Thanks, Raghavan, for delivering all the sad, depressing news. Now I get to deliver all the happy news, which is that we have dynamic links. And these are basically links that behave the way you want them to by intelligently changing their behavior based on what's going on your user's device. So including things like what platform they're on and whether they have the app installed or not. And most importantly, they can retain that link information through the App Store installation process so that when users open your app for the first time, you can still get information about the link that brought the user to your app in the first place. And to demonstrate why that's important, let's show you a little example here. This is John and Mary, and they have a recipe app, Recipe Wrangler. It makes cooking kind of sort of fun. And they've decided that they're excited about their app, and they want to promote it to some of the users of their current apps through an email campaign. So they decide they're going to run a little email campaign. It looks like this. They got some lovely pictures. And then they want to add some try out our app buttons. And so they add a couple right in their email for, hey, check it out on Android and check it out on iOS. So great idea. They have a few issues/concerns. For starters, we need these two buttons, one to get people to the App Store, one to get people to the Play Store. It's sort of twice the ugliness, and you also have the issue of what happens if your iOS user accidentally clicks that green button and goes to the Play Store. What's going to happen? They're going to get confused and probably not follow through on that email. There's issues around analytics and measuring, like how many people are actually clicking on these links, and are the people that are getting into your app through this email campaign, are they actually valuable users? Are they more valuable than perhaps people who found the app organically? Are the vegetarian users more or less valuable than the dessert people? How could you measure this? Sort of all of the typical analytics stuff that you want to know for these types of things. And then issue number 3, the welcome process for the app right now is, it's going to be the same for all users, whether they went to the app either through the Vegetarian Vittles email blast or whether they got there through the Cakey Concoctions, that's what we called it, that email. And it'd be kind of a crappy experience for your vegetarian user who says, oh, this looks like a fun app, and they go into Recipe Wrangler and they open it up, and the very first thing they get are like recipes for steak dinners and pork chops and stuff, and they might just say, well, I guess this app isn't for me, and close it and never come back to it. So luckily for our presentation, this is the kind of thing dynamic links are good for. So let's look at how we would construct one of these if we feel like building our URL by hand. For starters, all dynamic links are going to start off with this kind of domain. You've got a little subdomain. You notice that ABCDE is a unique code that will be associated with your app. That gets created for you when you create a project in Firebase. Then you've got app.goo.gl. After that, this is the link parameter. And this is essentially the URL that contains the information that your app will read in when it's first opened. And we'll talk a little more later about how you actually get this information. But it's important to know that this is sort of the important information that your app is going to read in. It also kind of plays double duty. If a user opens this dynamic link on an unsupported platform, such as a desktop web browser or perhaps a non-Android or iOS phone, they will also go to this link. Next up, we're going to add the package name. This is basically so that we can direct your Android users to the entry for your app on the Play Store. Similarly, we will add in the App Store ID so that we know where to send your iOS users who do not have the app installed. And then we're going to add in all our campaign tracking using UTM tags. Now, if you've done any kind of Play Store tracking or Google Analytics tracking, maybe this looks familiar to you. If you don't know what this is, essentially you can think of it as like a hierarchical way of representing your marketing campaign. So you sort of have like this Uber campaign, and then within that you'll have mediums that sort of represent different places where these campaigns exist, like in an email or in a QR code or what have you. And then sort of you can drill down from there. So that ends up with an awfully large link. Luckily, we do have a URL shortener that can shorten this for you, although both of these, I suppose, are fine if you just are putting them in the href tag of an email. And we also have a place on the Firebase console where you can create these links yourself if there are non-technical members of your team who aren't super excited about URL escaping and stuff. So you can always kind of add this in yourself, select your apps from the drop-down list, and it will generate the large dynamic link or the shortened version for you. But you can always use that expanded format if you want to create these links dynamically. For instance, you might want to create links, create these links dynamically on your client, and you can do that just by sort of building up these URLs like we showed earlier. So what happens when a user clicks on this link? Well, if they have the app installed, they'll be taken right into the app, right? And then at that point, the dynamic link will be passed into your app. Firebase Analytics will automatically read in all of those UTM tracking codes and make sure it gets recorded properly. And then that link parameter will get passed into your app for it to kind of process and do whatever it wants to with it. If the user does not have the app installed, then we will take your user to either the Play Store or the App Store, depending on what platform they're on when they click on that link. And then when the first time your user opens up the app, Firebase Dynamic Links will go out and it will look and see if there are any pending deep links for this user for this application. If it finds any, it will then deliver it to your app. At this point, again, Firebase Analytics will automatically process any UTM tracking tags you had associated with it. And then that link parameter will once again get passed into your client app that it can deal with however it sees fit. So what does this get us after creating this giant link? Well, for starters, we only need one button. So that kind of deals with issue number one. We don't have to worry about our user clicking on the wrong version or anything like that, and it looks a little nicer, in spite of my crappy art skills. But what about tracking where our users are coming from? So Firebase Dynamic Links will automatically let you know how many users clicked on any individual link. So we can certainly see, the number of times all of our various email campaign links got clicked. But is this getting us quality users? Is this getting us users that actually are going to do things like sign up for our newsletter from within the app, or buy and make an in-app purchase, or subscribe to the premium version, or whatever it is that we want them to do, probably to make some money? And that's what you can find out with these attribution tags. So basically, Firebase Analytics lets you define certain important events in your app, like making an in-app purchase or signing up for a newsletter or sharing the app with their friends, as these sort of important conversion events. And then you can look at any of these conversion events and break it out by all of the UTM parameters that get passed in: campaign, medium, type, and so on. This is all done automatically for you. So you can see, are these email campaigns, are they more or less effective, not just in getting us users, but say users that then share the app with their friends? And how does this compare versus users who find your app organically or through other means? You can find all of that out using Firebase Analytics. Similarly, if you want to find out, gosh, are our dessert fans spending more or less money in our app than our vegetarians? That's also something you can break out using Firebase Analytics, and then you can decide which group of your users maybe is a little more important for your app, and you can kind of focus your attention on them. So that really helps us deal with issue number 2. And so how do we customize that warm welcome? So that's with that link parameter that we pass in through these dynamic links. And you'll notice here, we have this URL that basically kind of looks like it's saying, hey, let's show the user a welcome, and maybe we want to feature cakes or feature vegetarian recipes. Assuming that we have logic on our app to read that in and customize that initial set of recipes that we show to our user, we can then make sure that users who went into our app by clicking on that link in our vegetarian vittles email now get vegetarian recipes. I know in the screenshot there it looks like a hamburger on the bottom left, but it's a veggie burger, trust me. And so this is the sort of thing that can really increase retention for your app users. When they open up your app and they immediately get content that is important and relevant to them, right? You know that whatever app they clicked on was probably important. It was enough to drive them to install your app in the first place, so you can kind of double down on that information and make sure that you present your users with content that they care about right away, so that they don't have to go digging through your app to actually find whatever content is relevant to them. And so that's the sort of thing that can really kind of increase retention and get people coming back to your app. So how does that link parameter get actually passed into your code? How can you kind of deal with it? We'll go into a few implementation details. On iOS, you'll be reading in a dynamic link through one of 2 different ways, depending on your situation. You'll either get this through a custom URL scheme, and if you've never implemented custom URL schemes before, it's not too bad. Basically, what you do is over in your info section, you're going to create a new URL type, and you're going to have your URL type set to your bundle ID. If you've added Google Sign-In in an iOS app before, this should probably look familiar to you. And then within your application open URL options method, you're going to get passed in that full dynamic link. You're going to pass that off to the Firebase Dynamic Links library and basically ask it, hey, can you take this URL and turn it into a dynamic link object? You'll either get back nil, in which case maybe it's a URL that's intended for Google Sign-In or Facebook Sign-In or so on, or you'll get back an actual dynamic link object, at which point you can get that link parameter by looking at the URL property, and then your app can actually process it in whatever way makes sense for your app. The other way you'll get it is through universal links. To get that working, you're going to need to turn on the associated domains capability within your Xcode project and make sure that the app.goo.gl domain is listed as an associated domain. That's your way of saying it's OK to send universal links to me through these dynamic links. And then once again, you're basically going to take that URL that comes in, pass it off to the dynamic links library. The only difference here is you'll actually get back that final object in a completion handler, just in case we have to make that one network call to expand the short link into a long link. And then, once we have that, we have our link parameter, and we can pass it into our app and do whatever we want to, analyze it and figure out what content we should be displaying to our users. By the way, don't freak out about universal links. If you're like, I haven't set this up for my site yet, it's on my to-do list somewhere, but I haven't done it yet. You don't need to set up universal links for your own website to get Firebase Dynamic Links working. Basically, you just have to set it up on the client because we're sending you universal links from our own little website that we've created that just serves your dynamic link. And if you want more information about this, I am doing a whole presentation on Firebase for iOS developers at 1 o'clock today, so you can go and check that out for more information. It's a shameless plug. On the Android side of things, there are a few ways you can implement this. This is one strategy which takes advantage of app links. And now I'm going to preface this section by saying I'm the iOS guy. Probably most of you in this audience will understand this part better than me. But you know what? Here we go. I'm going to try it anyway. So first off, you're going to set up app links, or if you're on earlier versions of Android, intent filters for the URLs that your app can handle. And this is basically your way of telling Android that to automatically redirect certain URLs to certain activities within your app. It says, you know what, these various web URLs, my app can handle those. When you do this, Google Play Services is smart enough to look at any of these incoming Firebase dynamic links, and it'll realize that if that link parameter equals an app link for which your app is already registered, well, it'll sort of do the work for you. It'll open up your app to the appropriate activity based on this link parameter. You do still need to do a little bit of work on your client. First off, you're going to need to call get invitation in the onCreate part of your app. This basically looks for any pending dynamic links that might not have been passed into your app, possibly because your app wasn't installed. So if your user installs your app because of a dynamic link, then they open it up, then you would call get invitation to then read in the dynamic link. That third argument of true that's highlighted there basically says, go ahead and automatically go to whatever part of my app, whatever activity that link parameter would have normally sent me to. And so basically in this callback, you don't actually need to do anything. We're just kind of bringing out some debug information. On the other hand, if your app is running and Google Play Services has already directed them to the appropriate activity in your app, that's great. But you are going to want to call get invitation in that deep link activity to essentially kind of consume that invitation from Google Play Services and just make sure it doesn't get called again in the future. And by the way, don't freak out about app links either. If you don't have app links set up for your app, that is totally fine as well. You'll just need to do the work yourself to kind of take in that link parameter and parse it and not leave it up to Google Play Services to figure it out for you. So Android people, did that make sense? Did that sound like, all right, I'm getting a thumbs up, good. So thank you. So my only question is, what's a manifest file? I'm just kidding. I know that much. So this is going great, right? We got some successful email campaigns going. In fact, now one of our favorite bloggers, Grillin' with Jill, has decided that she wants to include links to Recipe Wrangler from right within her blog. And well, gosh, that seems like a great idea for dynamic links too, right? Imagine you kind of click on the link for recipe, and Firebase Dynamic Link sends you directly to that recipe within the app. Well, that is awesome. And gosh, if they don't have the recipe, or they don't have the app installed, then we can also send them to the Play Store or the App Store. And isn't this fantastic? This is going to send us all these new users, and this could be the beginning of a beautiful referral program. So they send all these dynamic links off to Grillin' with Jill. She adds them in some of her various posts. And imagine everyone's shocked when the next day people aren't quite happy with the experience, right? So here's the deal. If you have some kind of obvious, why not try this in our app sort of button, it's fine for that to take people directly to the App Store or the Play Store, right? That is a perfectly fine experience. People are generally expecting that to happen when they click on a button like that. But people are probably not expecting this kind of experience if they're clicking on something that looks like it should just be taking them to another website. You've probably surprised them in a bad way, and you get the not quite happy emoji guy. So one way you can address this is by adding fallback parameters to your dynamic links. And this basically tells the device that instead of going to the Play Store or the App Store, why not take the user to another web page that you have specified? So it basically looks like this when you're constructing the giant dynamic link. You can add one fallback URL for Android, another one for iOS devices. Note that these right now are the same, but they don't have to be, right? We can direct them to different fallback pages that might have different marketing material with different screenshots and different device shots, which is always nice. Maybe in the future, if Recipe Wrangler has instant app support on Android, which still looks like magic to me, maybe we only have the fallback page for iOS. It kind of depends. So for users who, by using these fallback pages, users who still have Recipe Wrangler installed will directly go there, which is great. But for those that don't, well, it can go to whatever fallback page they specify. And maybe if all of their material is also available on their website, then great, we can kind of show the web page directly within the device. But we could also maybe send them to a marketing page that tells them a little bit more about Recipe Wrangler and how awesome it is, and you should go and install it, and that sort of thing. And then, of course, within this button, which now definitely looks like it should be taking you to the App Store or the Play Store, we can add in another Firebase Dynamic Link where we don't have those fallback pages specified, and this will definitely take our users to the App Store or the Play Store so they can go ahead and install the app. We give these to our Grillin' with Jill blogger, and we're back in action. We still get the benefit, by the way, of using dynamic links by seeing how many people are clicking on these various links in the Firebase console. We still get sort of different behavior based on the platform that people are using. But we also now have a much better experience because now we're doing what our users are probably expecting when they click on a link that looks like a web page or one that looks like it takes them to the app. So now, this might shock you, but Recipe Wrangler, not an actual app. But we have a few situations where dynamic links are being used in the real world by some actual companies that really exist. And I'm going to ask Raghavan to come back on up and walk you through some of those.
Hey, thank you, Todd.
Sure. Oh.
So that was great. So let's see how people are actually using dynamic links in the real world. So these links are great if you want to provide a great experience, as Todd explained. And one of the big use cases is to actually take people through an app install and coming out on the other side, make sure the context is propagated. And so we'll see how some apps are doing that. So this is Chudae. This is a Korean app for couples. And you can see there is the sender has shared something on their anniversary. And the developer wants this particular shared item to be opened in the app, because this app does not actually have a website. They only have an app. So you have to always take them through an app install if they want to see it. So dynamic links are great for that. That particular link is actually a dynamic link. And if the app is not installed, it takes them through the app install flow. And when the app opens for the first time, it actually shows the item. In this case, the item was a photograph. That's also great to be used as a background. So this is a case where dynamic links are being used to set up a pair relationship in your app. And it's also great for similar use cases to set up group relationships. So if one person in that group or the pair has the app and you want to onboard the others in that group, dynamic links are great to be used for invites. The first person can invite the others, and all the others get personalized, warm welcomes to invite them to get into the app. This is a second use case where before dynamic links, this particular flow starts off with an email saying, hey, check this thing out in the app, and the user has to actually go through the app install process. And the app doesn't know they came for this particular content, so it takes them through its default onboarding screen, and at the end of that, the user has to go back and find the search option in the app and then search for the content. And they might have forgotten what it was, so they've got to go back to the email, get the content, and come back and search for it. So it takes them more than a dozen clicks to actually get to their content. So with dynamic links, this makes it very, very nice and clean. The app, when it opens, knows what they came here for, and they see the content right away. So it goes down to just 4 clicks in this case. So what is the benefit of doing something like this? So one of our partners actually has been using this in exactly this scenario. And what they found is that dynamic links increase their retention after 4 weeks by 92% for users who came in from these links. Right? So this has a big impact on retention. This is a third use case, which is if your product actually has a desktop service. This is Google Maps, right? And you can use dynamic links to effectively convert desktop users to app users if you think the app can provide them with a better experience. So here, once the user has searched for some content, something they actually care about, you can give them the option, and in this case, to email it to yourself. And so this email comes to their phone, or email it or text it to themselves. And the email or the message, it comes to their phone. When they click on it, if the app is present, directly opens the app. Not present, go through the install flow. And when they come on the other side, they have the content right there. And if the link or the message is opened on a platform where there is no app for the service, that's totally fine, because you can configure the link to be opened in that case too. This use case converts mobile web users to app users. This is actually Shazam. And they are doing a promotion with a very unique marketing campaign where you can actually scan a particular logo on Coke bottles, and that will lead you to a very unique lip sync experience where you can record a lip sync video and share it on social media. And here it's been shared on Facebook. And so when somebody actually clicks on their friend's shared lip sync video, it takes you to a mobile web page where they can play it. And on this page, this is an opportunity for them to actually convert this user to an app user. There is a call to action that says, make your own lip sync video and share it on social media. And here, if you did not have dynamic links, they would need to have 2 buttons there. One that says, if you have the app, click here. If you don't have it, download it, and then hopefully you can figure out in the app how you can come back to this place, right? So dynamic links is perfect here. It's one button that works in both cases, and in both cases leads you to the right place. So we looked at a few cases where apps were using this dynamic links for onboarding users, converting mobile to web, mobile to app, and desktop to app. One of the most common cases is actually sharing. So let's see how these can be used for sharing. Okay. So going back to Todd's example, it turns out our food blogger isn't the only one who wants to share recipes. Our users for that app also want to share recipes too. And this is very easy. All you have to do is, in Recipe Wrangler, for each recipe, allow them to make a dynamic link for that particular recipe, which they can now post and share on social media, by email. And so everybody can pass the recipes around. And as the recipes gets passed around, well, Recipe Wrangler, our food app, gets more users. So that's great. And all you got to, and since they use dynamic links, they get all the benefits that we have talked about. It works on both app install, non-install cases, on both iOS and Android, in all these scenarios. All they have to do is to add some boilerplate code. Just create the deep link, and then find the email contact, and then find the SMS contact. And maybe if you want to be really good, have a recommendation engine that can suggest who you should share this with, because they may not want to scroll through 200 people in their contact list to find the people they want to share with. And then have a pretty email that's pre-formatted, which they can modify so that they can customize it, and then ideally send the emails from the app itself without having to go into an email client. So it does take a little bit of work, but dynamic links are great in this kind of flow. Now, if only this could be a little easier, that would be really great, but this shows you how dynamic links can be used. Okay? So thank you very much for coming. And looks like
wait, we're not done yet.
We're not?
No, we got one more feature.
Oh, yeah, you forgot about that. Thank you,
Firebase
Todd.
invites.
Okay.
My gosh. Don't end yet. See, we recognize that the whole process of kind of creating all these, links and sending them off through email and SMS is kind of valuable, also kind of a pain to do. And so we decided to standardize the process for you in one nice little package. Now, you're still more than welcome to go ahead and generate your own dynamic links and serve them however you want. You can still do that. But for SMS and email, which tends to be two of the most common situations, we have a solution that you can use right away. So generally, this is how it would work. On iOS, you're basically going to create an invite builder, and you're going to give it a bunch of parameters that sort of change its initial behavior. What the deep link info is going to be for people that receive this invite, that's the important one, as well as maybe what you want the default outbound message to be from that user, and if you want to kind of customize the call to action button or that sort of thing. Once you do that, you're going to open up the dialog, and it will appear sort of as a view controller right on top of your current app. On Android, almost the same process. You're going to kind of create an intent. You're going to set all the various parameters around what you want the default message to be for your user, what you want the deep link info to be, and so on. And then you're going to launch it to get the UI. And what you get, on iOS anyway, is something that looks a little like this. A few notes about this invite dialog. You'll note that we are mixing in SMS and email. And that's fine. In fact, that's good. It turns out a lot of users, they only have either the email address or the phone number of their recipients, right? They don't have both. And sort of having them in one convenient location is awfully nice. Also, you'll notice that we have some suggestions from Google folks, or from Google, based on folks that we think you might want to talk to, based on sort of who who we think your best friends are, or at least who you want to communicate with. And so that can be very useful if your best friends happen to be, William and Zena, and you don't want to scroll through, 300 contacts to get to those people. So it's kind of nice. What your recipients will see by default is a message that looks a little something like this. So you'll notice the subject line is the customized user message that your user has sent to people. And then the actual content of the email is what we have automatically grabbed from the App Store or the Play Store for you. So you kind of can see the description, which is directly from the App Store, and the screenshots and so on. And this is pretty good for delivering a nice looking email with 8 lines of code. But if you do want to do a little more and have a little more control on what this invitation looks like, you can add in an email content parameter. And so this is a parameter where you would generate a whole bunch of HTML, or you would supply in a whole bunch of HTML, and that would control what the email invitation looks like to those recipients. So this not only lets you design your invitation exactly the way you'd like, but it also means, because it's happening right there in your app, you can customize that invitation as you're sending it. So you can really kind of have custom invites based on the content that your user wants to share. For example, this is what Yummly did. They decided, instead of just kind of sharing if you want to share a recipe, instead of the email just kind of containing some generic info about the Yummly app, they said, well, gosh, we have all this recipe info right here. Let's put that into the email. And so what you get is a little bit more about the recipe. You get to see, the picture of the chocolate peppermint cookies, which look delicious. maybe because it's lunchtime. And a little bit of a snippet of the recipe to get you interested, and then you're a little more inspired to click on that link that says, why yes, I would like to install the Yummly app. Oh man, these guys really have a good recipe app already. Looks like it's back to the drawing board for John and Mary. So, all right, that's good. They got a backup plan. So the process for receiving invites, it's almost the same as for receiving a deep link. On iOS, instead of passing the URL you get into the Firebase Dynamic Links library, you're going to pass it into the Firebase Invites library. And then you'll get back an object that looks like an invite, and you can then sort of parse it as you need. On Android, you actually don't need to do anything. If you've already implemented Firebase Dynamic Links, the code is exactly the same for dealing with incoming Firebase invites. So that's kind of nice. So now let's move on to the one bit of bummer news. So on Android, you don't need to be signed in at all to send or receive an invite. Anybody is free to send any invitations they want. Anybody's free to accept any invitations, and that's all great. On iOS, you also don't need to be signed in to receive an invite. You get an invite coming in, go ahead and you can kind of click on that in your email, and it'll take you to your app, and so on. And so maybe you can see where we're going here. You do, however, have to be signed in with Google to send invitations on iOS. Now, maybe for some of you, that's not a problem, right? Your app already uses sign-in, and Google is one of your preferred sign-in providers, and you're like, oh, this is fine. Most of my users are signing in with Google anyway. But maybe it is a problem, right? Maybe your app doesn't have sign-in at all, or maybe you're not adding Google sign-in to your app. And so you say, well, OK, that's still not a big deal. I'm just going to put Firebase invites in my Android app. So my Android users can still share with each other, and that's fine. And my iOS users, they won't be sharing, but I'll still kind of get some viral effects from sending off all these invites. So here's the one problem with that. It turns out that Android users and iOS users sometimes still talk to each other. In fact, frequently, they're often friends. That's whole Montagues and Capulets thing. And so the problem is that your Android users are going to send these invitations not only to other Android users, but also to iOS users as well. The iOS users are going to click on that invitation. They will at least go through the process of installing your app. But then if you haven't implemented any kind of Firebase invites logic on the app, it's not going to know what to do with that invitation. And it's just going to kind of give your users the generic home screen instead of that great recipe that your users are trying to share. And they're going to be kind of sad and confused. So what I recommend is, at the very least, if you're adding Firebase invites on Android, make sure that you add the ability to receive invites on iOS. Like you saw, the code is very nearly identical to the deep link parsing we did earlier. And this will make sure that your Android users can still send invites to whoever they want, and they will get accepted, and your iOS users won't be confused. And then, again, totally up to you whether you want to add in sending invitations on iOS. So there you go. That is Firebase invites in a nutshell. Raghavan, you want to take us home?
Thank you, Todd. That was great. So let's recap. So in this talk, we covered dynamic links. And so now you know how to use them to make great marketing URLs for your app and your product. And we also looked at invites, which is an out-of-the-box invite flow for very effective sharing and invites on SMS and email. So for more information, please head over to our docs and support. And we also have a playground set up for you to create dynamic links and play with it, and that's at fdl-links.appspot.com. Just go there, and it's valid during I/O, and you can go and create some dynamic links and play with them and see and try all the parameters out. This is all the remaining talks going on. So we'll be around here after this talk, and happy to answer any questions off the stage. Thank you.
Thank you.
The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left. Otherwise, go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here, I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now, I could do that in theory by adjusting the multiplier on the center view's width constraint, but it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now, there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now, Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. OK, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned, simply by adding and removing two different groups of constraints, and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, and otherwise, I'll see you on Route 85. Bye.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android, to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that. Welcome to Coffee with a Googler. I'm Lawrence Moroney and I'm here in New York City to meet with Roman Nurik. And Roman Nurik is one of our material design gurus here at Google. So material design, tell me, what's it all about?
Oh, Lawrence, what is material design? Yeah, it's kind of hard to explain. There's actually a video with a bunch of the original designers that created material design, and they get asked the same question, and they don't know how to answer it. It is a complex kind of thing. There's a lot of things going on. I guess at the most basic level, it's a design language. It's a design system. It covers visual, interaction, and motion design. I feel like most design systems, design languages are treated as just visual languages, like here are the colors you should use and so on. But material is much more than that. It really kind of covers the model, the underlying physical model of a UI.
Okay.
So it basically tries to establish this physical environment within which your apps should live, on a phone, on a tablet, on a computer, basically any sort of screen. And then it basically establishes this physical environment in a set of basic rules and principles. And I like to think of it along these kind of 4 basic axes or 4 basic principles. And that's tangible surfaces, or kind of the material metaphor. We could talk about what material is at some point. Also, bold graphic design, this idea that we should take some of the best design ideas from the print world and see how that can help us make really great apps on digital devices.
Right.
And the third is meaningful motion, basically how all these things, how the surfaces and the ink on that surface, the graphic design stuff, how that all kind of moves in a consistent way to help communicate what's going on. And the fourth thing, which is to me one of the most important things, is adaptive design, which is how can we take all these first 3 things and make sure that they work consistently and coherently across different devices, phones, tablets, and everything else.
Now, you have a video, right, of some really good examples of material design being used. So shall we roll that?
Let's roll it.
So some pretty excellent examples there, but it's like, how does somebody reach that level? And for someone like me, I'm a developer and my design skills are non-existent. So if I want to become somebody who can build apps with those kind of design, how do I get started?
Well,
how do I learn this stuff?
It's a great question. I think first of all, I just want to, I guess, recognize some of those apps they're doing amazing jobs, and they have large teams. Some of them actually have very small teams. Some of those apps are created by one person. So you can absolutely reach that level of quality from these amazing showcase apps, regardless of your team size.
Okay.
But I'd say for the developers and designers out there that are just getting started, there are a lot of great resources out there. There's a great Udacity course that me, Nick Butcher, also from Google team here, and James Williams from Udacity put together. And that's available at udacity.com/Google.
Right.
And there's also a bunch of amazing resources on design.google.com, which will kind of tell you about how to come to Android if you're doing iOS stuff, for example, or how to kind of get started understanding what material design is. There's obviously the entire material design guidelines are there.
Okay.
So I'd say that the first thing, the Udacity course is probably the best kind of first step in getting started. But there's a whole lot of resources out there, and we link to others from the Udacity course.
And Udacity courses, if you're not familiar with them, they are very Socratic in how they teach, right? It's short videos and then challenging you to do something, and then a short video and then getting you to do something. And it's a good way that someone can incrementally learn rather than be thrown into like a huge design doc or something like that, right? So
yeah, it's definitely, there's a very clear progression. We specifically designed that course so that you can kind of start with some of the basics, the most elementary basic things about a screen, like what is a pixel, what is a density independent pixel, and then you kind of ramp all the way up to how do I make everything work on phones, tablets, and so on.
Right, and I have to assume that a design course is well designed, right?
We have some very nice color choices in our slides or our tablet drawings. So
cool.
Hopefully.
So back to material design again. It's like why material? What is it that?
So material goes back to that first principle. Right. So this idea of tangible surfaces, this idea that everything on a on your screen and your device exists on a surface. We like to think of them as pieces of paper. So basically, you can think of basically a sheet of material, or the word material representing one of those pieces of paper. And the reason we don't just call it paper is because it actually is, it's a lot more than just paper. In the real world, paper, once you rip it up, you can't really just, put it back together, and paper can't go from being, a circle to a square or to a rectangle. And so we like to think of our digital pieces of material or sheets of material as kind of a smarter paper, a more kind of, still a constrained paper. You can't just do anything. It can't just do all sorts of crazy things, but it is a physical thing that exists inside of this kind of environment, this kind of like faux environment, but it is something that has a lot of thought put into it. And so the word material, to me really means the sheets of paper that everything in this world exists on. But for me, the main thing to think about, the reason that motion is so important in material design is that motion should always have meaning. Try not to, just do like a flip of a button or like a double rotation or something just to kind of draw attention. Every time something moves, it attracts our attention. And so it needs to be really thoughtful and really kind of carefully planned out. And so in material, we use motion, or we kind of use just enough motion to convey the change in some object's state, or try to get a little bit of attention, but just enough motion, not too little, not too much.
I understand Android Studio has some templates to allow developers to at least get started with building material design into
Absolutely. Apps. So one of my philosophies for a long time has been, we can write about, material design. We can write about a thing. We can make suggestions about that thing, and we can try to teach people about that thing. But one of the best ways to get the thing into people's hands, in this case material design, is to actually just build it into the tools. Just make sure that as a developer that's just getting started, even just on Android, if I just go to File, New Project, or New App, right, I should be able to get the latest and greatest. And so in Android Studio now, we're actually seeing new templates for material design. So you could do file a new project, and then your default activity templates are going to come with material design in them.
Okay.
So it's going to use the material theme. It's going to use some of the latest support libraries from material design. So things like the Android Design Support Library, things like AppCompat.
Cool.
And so you're just going to get a lot of great stuff for free right off the bat.
Nice. So for someone like me, I'm a coder, not a designer, and so I can use Android Studio, get the effectively the scaffolding done for me in these templates, and then learn from something like the Udacity course.
Exactly. I definitely suggest, even before you do the Udacity course, file new project, right? Just look around the code, see what you get. I think that's a great way to get started. I always valued, as a kid and growing up learning programming and stuff, I always valued experimentation. So definitely experiment with that. But as soon as you kind of hit some sort of if you hit an obstacle or something, obviously take a look at the guide and the reference and all that. But the Udacity course is a great way to say, you know what, let me just kind of see what Google thinks is the right way to kind of approach understanding this system.
Awesome. Well, thanks, Roman. This has been a whole lot of fun, and I've learned more about material design in the last 5 minutes than I'd had in a year beforehand. So
this is fun. I could always talk about this stuff. So
they've told me that about you.
This is my favorite thing to talk about.
It's cool.
It's been awesome.
And I'm going to check out that Udacity course, and I recommend that you do so too. And if you're an Android developer, take a look at those templates. If you have any questions for me about this, or if you have any questions for Roman about material design or other aspects of building for material design, just please drop us a line in the comments below. Thank you for watching this episode of Coffee with a Googler. For more great episodes of Coffee with a Googler and for more great videos on developer topics, please tune to the Google Developers channel on YouTube. Thank you.
You just finished your app and it looks great. So let's call it a day because you're ready to rest, right? Wrong. I'm David East, and I'm here to convince you that you aren't done yet, because you need to build a widget. But first, what exactly is a widget? Well, a widget just consists of a single view that is passed to other apps, such as the home screen app, and this view gets displayed as a portion of their layout. And that single view has now become a window to your app from the home screen or even the lock screen. And this is where the magic comes in. Because you can use that widget to display information that your users will care about and to trigger actions that will bring them back into your app. This means that you have an opportunity to become the core part of your user's mobile experience. And how cool is that? Consider a simple non-interactive widget, like for a weather app. It can display the current temperature overlaid on a sunny sky to show the weather outside in a single glance on the home screen. Now you just gained a grateful user because they don't actually have to open up the app just to check the weather. But widgets are about doing things, not just showing off. So give that informative view a job to do. A click on the view should trigger a deep link into your app, but don't just open up your main activity. Instead, consider, is there a better point of entry, such as the view for this week's forecast? Another use for a widget could be a control toggle. Perhaps you want to show how strong the Wi-Fi signal is right now. That's your view. And a click on that view could toggle the Wi-Fi on and off without ever directing the user into the Settings app, which is super useful. But these are still only scraping the surface of what widgets can do for you and for users. Think about a calendar widget. The view can adjust to fill whatever size the user gives it, listing out all the events for today. Clicking on an event can open up its detail view, and scrolling through the list can show you everything that doesn't fit in the view. And just because you're showing a list doesn't mean you can't provide space for a quick add action to easily create a new event in a single click. Widgets are great because they empower you to make your app useful to users even when they haven't specifically opened it. And then you can easily get users back into your app because you're enticing them with completing an action. So check out the documentation on widgets to learn how you can get started and what widgets can do for you. But most importantly, just continue to build better apps.
I got to do it, man.
Why in-app payments are important? Well, as you all know, users like free applications. However, you need to make a living out of your work. Life is not as easy as it seems, right? For that, we got you covered with in-app payments. You can see it in many examples: Clash of the Clans, Netflix, Spotify, and many more. In this episode, you'll learn how to perform common in-app billing operations for your Android applications. In-app billing is a service hosted on Google Play that lets you charge for digital content or for upgrades in your app. You can request product details from Google Play, issue orders for in-app products, and retrieve ownership information based on your user's purchase history. Google Play provides a checkout interface that makes user interaction with the in-app billing service seamless. It provides a more intuitive experience to your users. So now you need to set up. Before you can start using the in-app billing service, you'll need to follow these 3 steps. Add the library that contains the in-app billing API to your Android project. Why? Well, it's the definition of the interface that in-app billing exposes. This will enable us to call its methods. Then, set the permissions for your application to communicate with Google Play. Last but not least, establish a connection between your application and Google Play. Now, you can place products for sale. Before publishing your application, you'll need to define the product list of digital goods available for purchase in Google Play Developer Console. Once your application is connected to Google Play, you can initiate purchase requests for in-app products. Google Play provides a checkout interface for users to enter their payment method, so your application does not need to handle payment transactions directly. When an item is purchased, Google Play recognizes that the user has an ownership of the item and prevents the users from purchasing another item with the same product ID until it is consumed. You could also query Google Play to quickly retrieve the list of purchases that were made by the user. To ensure that in-app billing is functioning correctly, you should test the application before you publish it on Google Play. Early testing also helps to ensure that the user flow for purchasing in-app items is not confusing or slow, and that users can see their newly purchased item in a timely way. Want to know more? Follow the links below. Until next time, eat your vegetables, use in-app payments, and listen to your partner.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint. Module bundling, accessibility. Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th. So subscribe to the YouTube channel, check out Season 1 and 2 before Season 3 starts, which will be happening soon.
We promise that Season 3 is going to be equally as mediocre as Seasons 1 and 2.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now I could do that in theory by adjusting the multiplier on the center view's width constraint. But it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create 2 completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now there are 2 ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. Okay, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide overview on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned, simply by adding and removing two different groups of constraints, and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, and otherwise, I'll see you on Route 85. Bye.
Bitcoin represents a way to transfer money anonymously and at almost no cost. And since it's an arbitrary currency with no nationality attached to it, you're free to exchange it with anyone in the world. What is money? Resources are limited, and they hold explicit value to people. Most resources are physical, and such needed to be traded in a physical form: diamonds, gold coins, chickens, or bikes. At some point, it becomes too difficult to physically transact those objects, and it's easier to agree, collectively, on the value of cash instead of gold. As we know today, this has many advantages. Credit cards and the modern banking basically gave us another abstraction layer on top of cash. There is a centralized system which defines who owns what resources. All of these trades are made virtually. This is the backbone of why Bitcoin is a valid idea. What is Bitcoin? Bitcoin is decentralized, anonymous, digital-only currency that recently received public attention. Bitcoin was originally developed in 2008. Like in any good mystery, someone using the alias Satoshi Nakamoto published a paper describing how Bitcoin could work. There's a very interesting story about this guy too. He must be very smart, but he never came forward to claim ownership or any part of the revenue. Just 1 year later, in 2009, Bitcoin started being traded. Where do they come from? Think about gold. You could buy it or mine it, and it's the same concept with Bitcoin. You do this by using your computer to hunt for 64-digit numbers. By having your computer repeatedly solve complex mathematical puzzles, you're competing with other miners to generate the number that the Bitcoin network is looking for. If your computer generates it first, you receive Bitcoins. The Bitcoin system is programmed to generate a fixed number of Bitcoins per unit of computing time. It is also self-sustaining, coded to prevent inflation, and encrypted to prevent anyone from disrupting its code. In the year 2140, the total number of Bitcoins in circulation will be capped at 21 million. So how much is a Bitcoin worth today? You'll need to Google it. Just type Bitcoin in US dollar, for example. You could also check it out at priv.com. Why are they anonymous? Bitcoin are pseudo-anonymous because they are built upon this centralized system. The Bitcoins themselves are anonymous. The wallets are not. Here is why. The base algorithm creates anonymity, but as the recent court cases show, if your Bitcoin wallet is identified and attached to a person, then someone can go through and track every transaction you've made. Bitcoins exist entirely on their own because there's no central infrastructure to shut down. You are identified by nothing more than your Bitcoin wallet address, a string of randomized letters and numbers. There are absolutely no identifying characteristic beyond that. For the paranoid dude, you can simply create a new wallet for each transaction. Here are some interesting startups that push the technology forward. We are still in the initial phase of Bitcoins, and there are many challenges and opportunities ahead: exchanges, wallets, merchant services, security, and more. But this is something for another episode. Until next time, Eat your vegetables and listen to your partners.
Hey there, Polycasters, Rob here. So before coming into the studio, we tweeted out a question to see what folks wanted to see in the next episode of Polycast, and a lot of folks wrote in and said they wanted to know how to lazy load Polymer elements to improve the performance of their apps. So that's exactly what we're going to cover today. Now to do that, we're going to start off over here at the Polymer docs, and we're going to go down to the API reference. And some folks might not even realize that we have an API reference, but it's kind of hidden down here in the sidebar for the documentation. You can go click on that, and that's going to take you to this sort of kind of classic Polymer doc layout if you've seen this before on other elements. And this is where you can find all of the properties and methods of the Polymer object itself. So a lot of really cool stuff inside of here. This is also where, for instance, like the Polymer templatizer documentation is. So if you wanted to create your own version of DOM-if or DOM-repeat, you could use templatizer to do that. Just a helpful tidbit there. But what we're interested in here is this Polymer base object. And Polymer base is sort of the base prototype for all Polymer elements, and it's where we hide interesting like methods and properties and stuff like that. The one I'm into is called import href down here. We can hit the embiggen button to make it larger. And so what import href is going to do, it's going to give us the ability to dynamically load an HTML import at runtime. It's got a few arguments that it takes. The first argument is we're going to give it an href, so basically just a path to some component or some HTML import that you want to pull in at runtime. And then it wants callbacks for on success, on error. And lastly, it takes an option which specifies whether or not you want the link tag to have an async attribute on it. So what I'm going to do is I'm going to use import href, and I'm going to build sort of a sample application. This is the app that I have thrown together. It is called Polymeal. It's a social network for foodies, and I guess people that like stir fry, because there's a lot of pictures of stir fry. And you can either go to the sort of the browse section, and you see here that I've got all sorts of yummy photos. Or you could go to the activity feed, and you could see maybe like I'd be posting status updates from all the cool, awesome restaurants that I am eating at, right? Now, the main thing to take away from this is that these two sections have very, very different content, right? This one is a whole bunch of cards with some paper buttons on it, right? And this activity feed is instead just sort of these like little status blurb things. So there's no reason to load all of this, all these card elements if the user is just starting off in the activity feed, right? It would just make more sense to load that at runtime to kind of like reduce the bandwidth for our total application. So to do that, we're going to use import href over here in our code editor. So this is my XApp element that I have started off with. And what I'm going to do is I'm going to have an XApp element inside of XApp. I will chuck in a little iron pages here. And inside of iron pages, we'll have sections for the different bits of our app that we are interested in. So I've got a browse section and an activity section. And we've also got the Page.js router loaded into XApp as well. So if we go down to the JavaScript definition, we can see that I've got kind of a basic route stubbed out. And what I want to do is when the route changes to either the browse section or the activity section, I'm going to call Polymer's import href method, load in my element definition. Once that's loaded in, I will then tell Iron Pages to switch over to that section. Now, the first thing I want to do, though, since we're starting off just at like slash, right now what we're doing is we're actually just loading a shell that looks kind of like this, right? We don't have, we're not hitting either the browse or the activity section, so the user's kind of got, nothing to look at. So we'll start off by redirecting them, page.redirect, over to the browse section. So this way we just have kind of like a nice starting point. I'm going to write another handler for browse, so page/browse. And you'll notice here that I'm using ES6 fat arrow functions. That just makes it a little bit easier to deal with the scoping of the this value inside of these handlers. So I'll say page.browse. And what I first want to do is see if the element has already been loaded. Has this page been loaded before? Because if it has, there's no reason to import it again. So we'll call Polymer's isInstance method. And this is something that I don't even think it's well documented. It might seriously not even exist anywhere in our docs, but I spoke with our tech writer. This is a thing. You can use it to sort of check to see if an element is an upgraded Polymer element. So because both our browse element and our activity element have IDs, We can reference them using automatic node finding. And we could say this.$.browse. So if this is already a Polymer element, let's just go ahead and return. No reason to do anything. No importing or anything like that is needed. But we will set the selected value to browse. And then what that's going to do is that's going to tell our iron pages up here to switch to that section. So you can see we're binding its selected attribute to that property. OK? Now, if the element has not been loaded, if it hasn't been upgraded yet, now we're going to import its definition. So we'll call polymer.base.importhref. And we're going to pass it a path to the HTML import for the browse section that we want to load. So elements/xbrowse/xbrowse.html. And then we'll give it a success handler to run. So we're going to say, all right, cool, the element loaded in. Let's now set this selected state to browse. That'll tell iron pages to update. And now we can return, exit our route here. We should be good to go. If we go back and we look at our application now and we refresh the page, it should redirect to the browse section, and it should start loading in all of those cards. Awesome, right? Now we need to do the same thing for the activity section. So I can just grab this entire route right here and do some dangerous copy and paste work here. We're just going to go through, and any place where it says browse, we'll just flip it out for activity. Activity. Thank you, spell check. So when we go to /activity, we're going to check to see if the activity element is upgraded. If it is, return. If it's not, import it. Let's go give that a look. So refresh the page, and we see our browse section looking good. We go to the activity section, and boom, we got our status feed showing up right there. Now, there's still a lot of unanswered questions to this. I kind of showed you the quick and dirty version of using import href, but what we didn't talk about was, do we need to vulcanize these things into different bundles? And if so, how do we exclude common dependencies? Or can we just use HTTP2 to maybe like server push all the things or multiplex stream all of our dependencies? So there's still a lot of things that remain to be worked out. And what we're going to do is we're going to talk about those in an upcoming episode of Polymer. But today, for what we've done here, if you have any questions, please leave them for me down in the comments. Otherwise, you can always ping me on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time. Otherwise, you can ping me on a social network at Take 2. I'll keep all the fun stuff up here, top 2/3 of the screen.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real data set we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The data set includes 3 different types of flowers. They're all species of iris: Setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this data set to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing data set is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at Scikit provided a bunch of sample data sets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The data set includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left, otherwise go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now I could do that in theory by adjusting the multiplier on the center view's width constraint. But it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. Okay, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned, simply by adding and removing two different groups of constraints, and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, and otherwise, I'll see you on Route 85. Bye.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that. Welcome to Coffee with a Googler. I'm Lawrence Moroney, and I'm here in New York City to meet with Roman Nurik. And Roman Nurik is one of our material design gurus here at Google. So, material design, tell me, what's it all about?
Oh, Lawrence, what is material design? Yeah, it's kind of hard to explain. There's actually a video with a bunch of the original designers that created material design, and they get asked the same question, and they don't know how to answer it. It is a complex kind of thing. There's a lot of things going on. I guess at the most basic level, it's a design language. It's a design system. It covers visual, interaction, and motion design. I feel like most design systems, design languages are treated as just visual languages, like here are the colors you should use and so on. But material is much more than that. It really kind of covers the model, the underlying physical model of a UI.
Okay.
So it basically tries to establish this physical environment within which your apps should live, on a phone, on a tablet, on a computer, basically any sort of screen. And then it basically establishes this physical environment in a set of basic rules and principles. And I like to think of it along these kind of four basic axes or four basic principles. And that's tangible surfaces, or kind of the material metaphor. We could talk about what material is at some point. Also, bold graphic design, this idea that we should take some of the best design ideas from the print world and see how that can help us make really great apps on digital devices.
Right.
And the third is meaningful motion, basically how all these things, how the surfaces and the ink on that surface, the graphic design stuff, how that all kind of moves in a consistent way to help communicate what's going on. And the fourth thing, which is to me one of the most important things, is adaptive design, which is how can we take all these first three things and make sure that they work consistently and coherently across different devices, phones, tablets, and everything else.
Now, you have a video, right, of some really good examples of material design
do.
being used. So shall we roll that?
Let's roll it.
So some pretty excellent examples there, but it's like, you know, how does somebody reach that level? And for someone like me, I'm a developer and my design skills are non-existent. So if I want to become somebody who can build apps with those kind of design, how do I get started? And
well,
how do I learn this stuff?
It's a great question. I think first of all, I just want to, I guess, recognize some of those apps they're doing amazing jobs, and they have large teams. Some of them actually have very small teams. Some of those apps are created by one person. So you can absolutely reach that level of quality from these amazing showcase apps, regardless of your team size.
Okay.
But I'd say for the developers and designers out there that are just getting started, there are a lot of great resources out there. There's a great Udacity course that me, Nick Butcher, also from Google team here, and James Williams from Udacity put together. And that's available at udacity.com/Google.
Right.
And there's also a bunch of amazing resources on design.google.com, which will kind of tell you about how to come to Android if you're doing iOS stuff, for example, or how to kind of get started understanding what material design is. There's obviously the entire material design guidelines are there.
Okay.
So I'd say that the first thing, the Udacity course is probably the best kind of first step in getting started. But there's a whole lot of resources out there, and we link to others from the Udacity course.
And Udacity courses, if you're not familiar with them, they are very Socratic in how they teach, right? It's short videos and then challenging you to do something, and then a short video and then getting you to do something. And it's a good way that someone can incrementally learn rather than be thrown into like a huge design doc or something like that, right? So
yeah, it's definitely, there's a very clear progression. We specifically designed that course so that you can kind of start with some of the basics, the most elementary basic things about a screen, like what is a pixel, what is a density independent pixel, and then you kind of ramp all the way up to how do I make everything work on phones, tablets, and so on.
Right, and I have to assume that a design course is well designed, right?
We have some very nice color choices in our slides or our tablet drawings, so hopefully.
So back to material design again. It's like why material? What is it that?
So material goes back to that first principle. Right. So this idea of tangible surfaces, this idea that everything on a on your screen and your device exists on a surface. We like to think of them as pieces of paper. So basically, you can think of basically a sheet of material, or the word material representing one of those pieces of paper. And the reason we don't just call it paper is because it's a lot more than just paper. In the real world, paper, once you rip it up, you can't really just, put it back together, and paper can't go from being, a circle to a square or to a rectangle. And so we like to think of our digital pieces of material or sheets of material as kind of a smarter paper, a more kind of, still a constrained paper. You can't just do anything. It can't just do all sorts of crazy things, but it is a physical thing that exists inside of this kind of environment, this kind of like faux environment, but it is something that has a lot of thought put into it. And so the word material, to me really means the sheets of paper that everything in this world exists on. But for me, the main thing to think about, the reason that motion is so important in material design is that motion should always have meaning. Try not to just do like a flip of a button or like a double rotation or something, just to kind of draw attention. Every time something moves, it attracts our attention. And so it needs to be really thoughtful and really kind of carefully planned out. And so in Material, we use motion, or we kind of use just enough motion to convey the change in some object's state, or try to get a little bit of attention, but just enough motion, not too little, not too much.
I understand Android Studio has some templates to allow developers to at least get started with building material design into their
Absolutely.
apps.
So one of my philosophies for a long time has been, we can write about material design. We can write about a thing. We can make suggestions about that thing, and we can try to teach people about that thing. But one of the best ways to get the thing into people's hands, in this case material design, is to actually just build it into the tools. Just make sure that as a developer that's just getting started, even just on Android, if I just go to File, New Project, or New App, right, I should be able to get the latest and greatest. And so in Android Studio now, we're actually seeing new templates for material design. So you could do File, New Project, and then your default activity templates are going to come with material design in them.
Okay.
So it's going to use the material theme. It's going to use some of the latest support libraries from material design. So things like the Android Design Support Library, things like AppCompat.
Cool.
And so you're just going to get a lot of great stuff for free right off the bat.
Nice. So for someone like me, I'm a coder, not a designer, and so I can use Android Studio, get effectively the scaffolding done for me in these templates, and then learn from something like the Udacity course.
Exactly. I definitely suggest, even before you do the Udacity course, File, New Project, right? Just look around the code, see what you get. I think that's a great way to get started. I always valued, as a kid and growing up learning programming and stuff, I always valued experimentation. So definitely experiment with that. But as soon as you kind of hit some sort of if you hit an obstacle or something, obviously take a look at the guide and the reference and all that. But the Udacity course is a great way to say, you know what, let me just kind of see what Google thinks is the right way to kind of approach understanding this system.
Awesome. Well, thanks, Roman. This has been a whole lot of fun, and I've learned more about material design in the last 5 minutes than I'd had in a year beforehand. So
this is fun. I could always talk about this stuff. So
they've told me that about you.
This is my favorite thing to talk about.
It's cool.
It's been awesome.
And I'm going to check out that Udacity course, and I recommend that you do so too. And if you're an Android developer, take a look at those templates. If you have any questions for me about this, or if you have any questions for Roman about material design or other aspects of building for material design, just please drop us a line in the comments below. Thank you for watching this episode of Coffee with a Googler. For more great episodes of Coffee with a Googler and for more great videos on developer topics, please tune to the Google Developers channel on YouTube. Thank you.
You just finished your app and it looks great. So let's call it a day because you're ready to rest, right? Wrong. I'm David East, and I'm here to convince you that you aren't done yet, because you need to build a widget. But first, what exactly is a widget? Well, a widget just consists of a single view that is passed to other apps, such as the home screen app, and this view gets displayed as a portion of their layout. And that single view has now become a window to your app from the home screen or even the lock screen. And this is where the magic comes in. Because you can use that widget to display information that your users will care about and to trigger actions that will bring them back into your app. This means that you have an opportunity to become the core part of your user's mobile experience. And how cool is that? Consider a simple non-interactive widget, like for a weather app. It can display the current temperature overlaid on a sunny sky to show the weather outside in a single glance on the home screen. Now you just gained a grateful user because they don't actually have to open up the app just to check the weather. But widgets are about doing things, not just showing off. So give that informative view a job to do. A click on the view should trigger a deep link into your app, but don't just open up your main activity. Instead, consider, is there a better point of entry, such as the view for this week's forecast? Another use for a widget could be a control toggle. Perhaps you want to show how strong the Wi-Fi signal is right now. That's your view. And a click on that view could toggle the Wi-Fi on and off without ever directing the user into the Settings app, which is super useful. But these are still only scraping the surface of what widgets can do for you and for users. Think about a calendar widget. The view can adjust to fill whatever size the user gives it, listing out all the events for today. Clicking on an event can open up its detail view, and scrolling through the list can show you everything that doesn't fit in the view. And just because you're showing a list doesn't mean you can't provide space for a quick add action to easily create a new event in a single click. Widgets are great because they empower you to make your app useful to users even when they haven't specifically opened it. And then you can easily get users back into your app because you're enticing them with completing an action. So check out the documentation on widgets to learn how you can get started and what widgets can do for you. But most importantly, just continue to build better apps.
I got to do it, man. Why in-app payments are important? Well, as you all know, users like free applications. However, you need to make a living out of your work. Life is not as easy as it seems, right? For that, we got you covered with in-app payments. You could see it in many examples: Clash of the Clans, Netflix, Spotify, and many more. In this episode, you'll learn how to perform common in-app billing operations for your Android applications. In-app billing is a service hosted on Google Play that lets you charge for digital content or for upgrades in your app. You can request product details from Google Play, issue orders for in-app products, and retrieve ownership information based on your user's purchase history. Google Play provides a checkout interface that makes user interaction with the in-app billing service seamless. It provides a more intuitive experience to your users. So now you need to set up. Before you can start using the in-app billing service, you'll need to follow these 3 steps. Add the library that contains the in-app billing API to your Android project. Why? Well, it's the definition of the interface that in-app billing exposes. This will enable us to call its methods. Then, set the permissions for your application to communicate with Google Play. Last but not least, establish a connection between your application and Google Play. Now, you can place products for sale. Before publishing your application, you'll need to define the product list of digital goods available for purchase in Google Play Developer Console. Once your application is connected to Google Play, you can initiate purchase requests for in-app products. Google Play provides a checkout interface for users to enter the payment method, so your application does not need to handle payment transactions directly. When an item is purchased, Google Play recognizes that the user has an ownership of the item and prevents the users from purchasing another item with the same product ID until it is consumed. You could also query Google Play to quickly retrieve the list of purchases that were made by the user. To ensure that in-app billing is functioning correctly, you should test the application before you publish it on Google Play. Early testing also helps to ensure that the user flow for purchasing in-app items is not confusing or slow, and that users can see their newly purchased item in a timely way. Want to know more? Follow the links below. Until next time, eat your vegetables, use in-app payments, and listen to your partner.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint. Module bundling, accessibility. Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th. So subscribe to the YouTube channel, check out Season 1 and 2 before Season 3 starts, which will be happening soon.
We promise that Season 3 is going to be equally as mediocre as Seasons 1 and 2.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at
I've heard a lot of people I respect who really like it, and I haven't been able to really successfully apply it, you know.
You really don't need to. If you work out really hard, sometimes you don't need to. You get the benefits of...
I think it's like when I try to meditate, it's just too often there's just everything running through my head, you know.
I think it takes practice to really be able to sort of fully disconnect. And
it depends how cluttered your head is. If you're really relaxed, if you're like just got loads of thoughts in your head, it's nice to meditate, just clear it out. Headspace is a great app actually. Teaches you the principles of it really well.
Yeah, maybe I'll try it out.
It's really good. How you doing?
A lot of friendly faces.
Should we start sprinting?
Go.
Oh yeah, we're going? Okay.
Hi, everyone. Thank you. Thanks for coming. My name is Dan Amanzadi. I'm a software engineer at Google, and I'm also a dedicated triathlete. So on a good week, I'll run 50 miles, I'll bike 100 miles, and I'll maybe write 3,000 lines of code. So maybe it's no surprise that I work on the Google Fit app for Android Wear, which makes really extensive use of the Google Fit platform APIs that we're going to be highlighting for you today.
Hi, everyone. I'm Muzz Mustafi. I'm product manager on the Google Fit platform, and I'm a keen quantified selfer. I enjoy weightlifting, running, yoga, and occasionally experimenting with different diets. Today, we're going to talk about building rich experiences with the Google Fit platform and Android Wear. I'll start out by talking about why we created the Fit platform, what problems we set out to solve, and then Dan will go over its APIs and its data types. Next, we'll look at some specific examples of what you can build with the Fit platform, first basic fitness tracking, and then a more advanced real-time fitness use case. Finally, we'll finish up with some really cool demos coming soon. Need the clicker. Let's start out by introducing the Fit platform. We'll explain why we created Fit, what problems we set out to solve, and why we believe fitness is such a great use case for wearables. Before the Google Fit platform existed, life for a fitness application developer was not easy. It was integration hell. First issue was that of siloed data. Users' health and fitness-related sensor data was siloed across multiple apps and companion devices. Second, there was no easy access and storage of sensor data. No easy way for developers to read, interpret, and record data from health and fitness-related devices, sensors on connected companion devices such as Android Wear devices. The third problem was poor interoperability. There was no simple, standard way for fitness devices to interoperate, so in order to integrate with the existing app device ecosystem, app developers would have to build their own platform and provide an API. Some of these would be poorly implemented, leading to user frustration. With the Google Fit platform, we solve that problem by giving apps one single set of APIs to access, record, and store phone sensor data, wearable data, and other app data. So by using my phone or my Wear device as my fitness hub, I can connect my fitness wearable to my favorite nutrition app and my sleep tracking app to my favorite meditation app. We don't just consolidate data, though. With user consent, we provide low-level sensor recording, and we perform hard computations for things like distance and calories, whether it's resting heart rate from heart rate timestamps, distances fused from your height, steps, and GPS, or calories from heart rate. The Fit platform makes it easier for health and fitness application developers. And fitness and wearables truly go hand in hand. This is for a few reasons. First, the sensors. Your app can get access to all of these ways of measuring fitness activities. Many watches have a GPS sensor, a heart rate monitor, and potentially even a barometer. And because the watch is worn on the wrist, it allows us to detect activities that we couldn't do with a phone being in a pocket or a purse. So that's the first reason, sensors. Second, you can leave the phone. I love my Nexus 6P, but running with the device is a bit cumbersome. I have to rely on infrequent audio cues to find out my current pace, because I can't see the screen when it's in an armband or in my pocket. Third is faster input. When you're on the go, you can have quick interactions with the watch to control music or activity recording that would take much longer if you had to rely on pulling out your phone and opening up the right app. Now, let's talk about what the Google Fit platform provides that enables you to build rich experiences in line with what we just discussed. First, let's talk about the Google Fit app. So here we have the Google Fit app on both phone and on Android Wear. If you're not familiar with the app, you can see that it tracks walking, running, and biking using the Google Fit platform's APIs that detect activity, associated steps, calories, and distances. The app also shows data from connected third-party devices and apps, such as exercise sessions, weight, heart rate, nutrition data, and sleep. Our platform automatically synchronizes between your Android phone, your Android Wear device, and the web. The Fit platform exists in all three of these. So you can write in data via our REST APIs on the web, via our Android SDKs on the phone, or the Android SDK on Wear. The platform handles merging and deduplication of this data intelligently, and we even support takeout integration if the user wants to export their data.
Thanks, Muzz. So now that you've gotten an overview of the Google Fit platform and maybe some motivation for why it might be a good fit for your fitness app, let me go into a little more detail about the different APIs that it provides. So basically, it breaks down into 4 APIs. First, there's the Sensors API, which gives you access to raw sensor data streams from Android devices and wearable devices sensors, so things like heart rate. Then there's the Recording API. The Recording API does automated storage of fitness data for you using subscriptions. You can subscribe to a data type, and Google Fit will store fitness data for that data type in the background, and it'll persist to the subscription for you. Next, there's the History API, which gives you access to the fitness history and lets you perform bulk operations like reading and inserting and deleting data from the fitness history. And then finally, there's the Sessions API. Sessions are basically a metadata layer on top of raw fitness data that let you store whole fitness activities. So a session is a time interval during which the user was doing, say, a bike ride or a run or a weightlifting session. As far as what you can record, we support really all the standard data types for diet, nutrition, body, activity, sleep. We're also adding this new hydration data type. I think this is a pretty exhaustive list of fitness metrics, but if there's one that's not in here that you'd like to log in your app, you should let us know. So let's start by talking just about basic fitness tracking. You can't measure what you don't track, so tracking and measuring is really, I think, the first step toward motivating people towards better fitness. I actually first started tracking my workouts 10 years ago, back in 2006, when I was training for my first marathon, and I bought my very first wrist-mounted GPS, and it was this massive, ugly, uncomfortable thing, like the size of a chinchilla on my wrist. But it did the job. I could plug it into the serial port on my PC, and I could download XML data of my run. And back then, there weren't any nice portals or kind of fitness platforms. So to visualize my runs, I built this website with Google Maps API 1.0, and I could put my runs up there. And there's something really thrilling for a data geek like me to come back from a workout and analyze all my stats on pace and heart rate and elevation, and I could really track my progress from week to week and workout to workout. So these days, obviously, there are much more elegant and full-featured alternatives where I can analyze my workouts and share them with friends and track my progress toward fitness goals. And also, I don't have to wear a big, giant, ugly thing on my wrist. I can wear this really, these beautiful timepieces from TAG Heuer or Michael Kors, and I can still track and visualize my progress right on my wrist throughout the day with the watch face. Now, this is actually my favorite watch face here, the FitCat. Yeah, big ups for FitCat. It tries to encourage you to be more active. So basically, if you haven't seen this before, the more active that you are, the more steps you take, the more active the cute little cat becomes. I love how he's wearing the I/O badge and he has the backpack there, and wearing an Android Wear watch also. But actually, so this seems kind of like a simple concept, right? The more steps you take, the more active the cat becomes. But actually trying to build something like this on your own is not easy. There's a lot of stuff you'd have to do if you wanted to do it on your own. You'd have to build a data store that tracks steps. You'd have to turn on sensors, get permission from the user to do that. Then you'd have to be able to record step counts in kind of a way that won't kill the watch battery. If you get that part working, then when the user first installs your watch face, it'll record 0. It'll show 0 because you haven't been recording yet. And then there's all these edge cases, like the user takes off their watch and goes for a walk with just their phone in their pocket. Then you have to write the logic for merging in that data. And then even if you solve all these problems, your step count still is probably not going to be consistent with other watch faces and other apps. So fortunately, we solve all these problems for you with the Google Fit platform. We store steps in the background in a nice low-power, battery-friendly way, and they're ready to be read anytime you like. And you can get consistent step counts on Android Wear with just one method call. So let me just show you how to do that. Typically, when you want to connect to the Google Fit platform, you create a Google API client, right? And normally you create an authenticated one where you specify the account that you want to read data for. So here's how I'd build the client. I say that I'm interested in reading fitness history data, so I add the fitness history API. I add scopes for the particular types of data I want to read. So in this case, activity type, location, and body sensor data like heart rate. And then next I add an account. So this is the account I want to read the data from. And then finally I add my callbacks, and now I have this authenticated client that I can use to make queries to the fitness platform. But wait, you're saying, Android Wear watches don't have accounts. And this is true. Android Wear 2.0 will actually add account support, but for now, we don't have accounts on watches. Fortunately, there's a solution. Now, you could sync account information from the phone, but this would require your watch face to have a companion phone app, which is a lot more complicated. So here's an easier way to do it without a phone app. You can create a no-account client. So you create a Google API client. As before, we're going to add the history API. And now we just call set default account. We don't specify an account. Finish building it. And now we have a no-account client that we can still use to query step counts. And the way you do that is with the read daily totals method. So you're going to call the history API's read daily total method. And this is basically going to give you a simple way to get step counts for watch face that's going to be consistent with other apps and other watch faces. You can set a callback so that when the result returns, you can process it. So here in the on result, I'm basically just extracting out the step count, putting it into a steps total variable. And there you go. It's a pretty simple way to track steps with your watch face. And it's not just steps that you can get from the Google Fit platform, right? You can also read and write other data like calories consumed. So here's an example of how the LifeSum app displays that data. Here I'm looking at the amount of calories I have left in my budget for the day, 911. So I guess I could eat like 2 avocados and drink 2 glasses of wine tonight. Android Wear 2.0 is going to have a new way to show data on watch faces using complications. Maybe you've seen some of this earlier in the keynote. But basically, on the right, there's a watch face that has 3 complications. And the watch face lets you select which complications you want. And then any app can provide data for those complications. So here's an example where LifeSum is exporting data on calories burned as a complication so that the Ranger watch face, which is on the right, can display it in one of those 3 user configurable slots. And if you want more information on building complications in Android Wear 2.0, highly recommend you check out the talk. There's a dedicated talk at 4 p.m. on this topic.
Another challenge that fitness developers face is how to perform difficult computations. For example, to derive distance traveled from multiple sensor inputs. The user's height, stride length, GPS data, activity type, active time, and step counts all have to be fused in together, potentially across multiple sensor inputs. The Fit platform makes this easy for third-party developers through its advanced transformations for both distance and calories. The Basis app takes advantage of this. Instead of computing distance themselves, they write in steps and activity data into the Google Fit platform and read back our computed values for distance.
Cool, so let's take a look at how we might do something like this with the Google Fit platform. So there are 2 ways of writing data to the platform. You can use the recording API to do live recording, and then you can use the history API to insert activity history. So let's actually start by looking at live recording. All we have to do to start live recording is to subscribe to the data type we care about. So here I'm calling subscribe, and I'm saying I'm interested in activity samples, activity type. And then actually, at that point, I am essentially done. Google Fit will start storing that data that I care about in the background. And so I don't need my own database or my backend to store it. There's no listener needed here. Basically, the Google Fit platform is going to start recording data and syncing it to the cloud in the background. And when I want it later, I can just read it with the history API. So once I subscribe, I'm done. All I really need to do is just check the status code in the on result. And that's just to make sure that the subscription succeeded. Now, let's look at another way of getting data into the fitness history. Suppose I've gotten my data from some external source, like another device. So in the example of Basis, right, they wanted to write in some steps that they had gotten from another device. So first, you create this data source object. And you create a data set from the data source, and you add one or more data points to the data set. Each of these points has a start and an end time. So here I'm adding 950 steps with a start and an end time. And then finally, you just call insert data to put the data into the fitness history, and that's about it. All you really have to do after that is just basically verify that the operation succeeded before you start querying the data with the history API. And one nice thing is that the Fit platform will actually validate the data points that you insert. So, for example, if I put in an invalid time range, or I put in a really unrealistically high calorie burn or cadence or something like that, I'll get an error back in the client instead of the user's fitness history getting all messed up. So here's how this actually looks in the Basis app. They put in steps, and then you can see they are able to derive from that, or through the Google Fit platform, they get this accurate distance traveled.
We've been working hard over the past year to improve the quality of these transformations. The first area with which we've improved them is in relation to distance. Distance computed from steps now has been improved with stride length calibration, from actively tracked walks and runs to improve the quality of passively tracked walks and runs. Secondly, for calories, we will soon be leveraging gender, age, and heart rate as part of our computations to improve the accuracy. Thirdly, for merging, previously leaving your phone at your desk and going for a walk with your Android Wear device would result in your step counts dipping back down and then rubber banding back up. That will no longer be the case through bidirectional syncing. We've also made merging of our GPS data better by prioritizing the highest fidelity GPS sources. Finally, with regards to activities, this is our most complex task, to infer the activity being performed by analyzing multiple sensor inputs in real time. It's really important as users get frustrated when their fitness data has false positive and false negative activities, and they don't get their proper calories and step counts as a result. Fortunately, Google is good and trusted at collecting and understanding complex data through our advanced machine learning capabilities. We've added dynamic sampling of sensor inputs to improve quality, and have made improvements to our algorithms by fusing steps, position, speed, and user corrections together. The result of this hard work over the past year is a reduction in our biking precision error rates from 11% error in early 2015 down to 4% error as of now. And these changes will be rolling out now. Finally, we've added stride length calibration to the Fit platform, which we hope will greatly benefit non-GPS Android Wear devices. So now, if a user goes running, initially with their phone and their watch, which has the phone which has GPS and the watch which doesn't, the two will calibrate together and generate a stride model, and then they'll get accurate distance and pace estimates running without their phone, just with their non-GPS Android Wear device. Now that we've looked at some basic fitness tracking examples, I want to talk about our push this year into real-time fitness tracking. But why is real-time so important when building a motivating fitness experience? Well, when I look at fitness apps out there, and I look at a lot of fitness apps out there, I see that they adopt this framework. They start with the goal of the user. For example, I'd like to lose 10 pounds. I'd like to sleep better. Or I'd like to finish a half marathon. They recognize that in order to accomplish this goal, they need to encourage a pattern of motivating actions so that the user achieves the result that they desire. Let's drill into these motivating actions. There are 3 pillars of wellness: exercise, nutrition, and recovery. Recovery, we mean sleep and meditation. But these pillars do not operate independently, and behavior in one needs to be balanced against the other. By getting a holistic view of what's going on in each of these areas, your app can more intelligently and insightfully present suggestions and nudges based on a changing fitness context in real time. For example, a sleep app might observe that you sleep better when you exercise, or when you eat less sugar in the evening. An exercise app may suggest exercise based on your log nutrition data so that you meet your weight loss goals. Note that in all these cases, timeliness is important. the best time to coach and motivate a user is immediately in response to an action that they have taken in relation to their fitness. So good apps have an inbuilt awareness of the user's overall fitness context. One of our partners, LifeSum, makes heavy use of these principles through in their application, and they integrate deeply with the Fit Platform APIs, and as a result, they've seen double the retention rate for their users connected to Fit versus their users who aren't connected to Fit. And here are the APIs that we've added to let you respond in real time to a changing fitness context for your user. First, is real-time data update notifications. It allows you to be notified for certain data types in the fitness store when they change. The second is real-time session notifications. It's actually been in the Fit platform for a while, but we'd like to talk about it today. It allows you to be notified that the user has started or finished a workout tracked in a third-party application. And finally, there's real-time activity recognition, coming soon to Android Wear devices to detect the onset of activity to launch into your active tracking experience. Let's dive into the first API, real-time data update notifications. This allows us to build the following experience. Say I just had an impromptu pizza, and I've exceeded my calorie intake goal for the day. I can get a notification from my weight scale app telling me, listen, more exercise is needed to keep you on track to meet your weight loss goal.
I do admit I have a weakness for pizza, and that one looked pretty delicious. So let's see how we could build something like that example that Muzz just described. What we want to do is subscribe to updates to the nutrition data type. So first thing we do is create a pending intent. This is typically a pending intent for an intent service that's going to call into your app whenever an update to one of these data types occurs. What you then do is you create a data update listener registration request, which is a lot of camel case, but it is a pretty descriptive name. And we're going to pass in the type of data that we'd like to subscribe to updates for. So in this case, nutrition, we're interested in meals that are being logged. And then we pass in that pending intent we created. And then finally, we just call this register data update listener method, and we pass in our client and our request. And then voila, we'll get an update with the next logged meal. And of course, you can register for updates to all different kinds of data types. For example, if I want to be notified every time the user steps on their scale and logs a new weight, I can do that with type weight. And here are actually all of the data types that support real-time updates. Pretty much anything that isn't updated super frequently.
The second API, real-time session update notifications, allows, for example, a nutrition app to be notified that a user just finished a workout session. So say you just finished a weightlifting session, your nutrition app can tell you it's time to get a high-protein meal in to maximize your muscle growth. Or say a hydration logging app. It can suggest rehydrating immediately after finishing a 21-minute run outdoors.
Yeah, it's been so hot here. I think we can all use hydration reminders, even if we haven't been running, just walking around outside. So let's build that one. Similar API to the one that we just looked at with the history API. But here we're going to use the sessions API because we're interested in registering for updates when a session starts or ends. So again, we create a pending intent that we'd like to fire when a new session begins or ends. And then we call this register for sessions method in the sessions API. And now whenever the user starts or ends a workout, the pending intent will fire and an intent will be delivered to our app. And if you want to get more information on that session, you can actually extract it from out of the intent. So here I'm pulling out the start and end time, and then also the type of workout, so whether it was a run or a bike ride or a weightlifting session, and I could put that into the notification like the one that Muzz just showed. One exciting new development that's coming to the Google Fit platform this year is that we're actually going to allow your app to register not only for these explicit sessions that the user initiates, but also for implicit sessions. These are ones that are automatically detected by our platform. So what it means is that your app can respond in real time to a user's fitness activity. So if I just lace up my shoes and I start running, my favorite run tracking app can just start up automatically on my watch. So I'm going to try to show you a demo of how that works. I'm not really properly dressed for running, but I'm going to do a little run around here. OK, I just felt my wrist vibrate, which means that Strava should have started up on my watch. So let's go over here and take a look. And there we go. So you can see that Strava is now recording my run. And I'll post that on Strava later, so I hope you can give me some kudos. Here you go, Muzz.
Awesome. So we've got a couple of really exciting, well, three actually, really exciting new features coming on Android Wear towards the end of the year. We've added a beat-to-beat API in Android N. What this allows you to do is get the heart rate timestamps in addition to the BPMs, and compute heart rate variability, which is a proxy for stress levels for the user. Second, we're adding a profile API. This allows you to easily onboard your new users by reading age, gender, height, and weight from the Fit platform. And finally, Goals API, allowing you not only to show, for example, just the step count, but also the progress against that step goal, but also active time, distance, and calorie goals as well from Google Fit. There's another exciting feature that some of you guys might have seen at the sandbox already. So when I go to the gym, I notice that a lot of people are still using an old school pen and paper to log their exercise, their reps, their weight. Seems a bit crazy in 2016. Well, Google Fit on Android Wear did count reps for you for 3 specific exercises, push-ups, sit-ups, and squats, but only if you told the app in advance what you were doing. This is still somewhat limited and cumbersome. Now we've got something better, so I'm going to show you a demo.
Oh, come on, Muzz. Here.
All right, okay, maybe, all right.
Give me a break.
Okay, so I'm going to the Google Fit strength training section, and I haven't told it the exercise I'm about to do.
Come on. Woo! He's working hard for you guys.
As you can see, it detected bicep curls with 100%. And counted the reps. It was 15 pounds, so I'll just lock that. Let's do another exercise, one which involves the legs. Note that I can take some time just kind of setting up.
Very good form.
It's not. Okay, put these down. And you can see it got deadlift.
Yay!
If a rep is missed or an exercise isn't correct, for whatever reason, we will learn from that mistake and become trained to the user's exercise motion. We aim to seamlessly track a whole workout with minimal user input. We're planning an API towards the end of this year, and we're looking for partners.
All right, so that's our overview of the Google Fit platform. Before we wrap up, we just want to thank all of our partners who are already using the Google Fit platform to inspire and motivate people around the world to lead more healthy and active lifestyles. You know, at the end of the day, this talk isn't really about pending intents and broadcast receivers. It's about improving lives and extending lifespans. And so we really hope that you'll be inspired to get out there and build the next generation of awesome, amazing fitness experiences on Android. So thanks so much for your time and attention. Feel free to contact us with any questions. Thank you.
Hi, I'm Timothy Jordan, and this is The Developer Show. I'm standing here with Purnima Kochikar, Director for Google Play Apps and Games. Purnima, welcome to the show.
Thank you, Timothy. Thanks for having me.
Hey, it's great to have you here. First, I'd like to learn a little bit about your history and what brought you to Google Play. I know that you used to be VP at Nokia for developer communities. What is it that you learned about developers there that brought you to this role?
What I loved about working with developers is that they are always optimistic. I don't think there's any job in the world that you're working with more optimistic people who are trying to solve amazing problems. Every day I talk to people who are saying, this is a new way of doing taxis, or a new way of doing education, or a new way of supplying food. So there's always a new way, and that's exciting. The second thing, what I love about developers, is that they'll take the technology or a platform that you have built and completely use it in ways that you have never imagined would happen. And so the two aspects of it, the surprises and the solutions, is what makes me excited about working with developers.
That's one of my favorite things too, is that working with platforms, we always kind of have an idea of how developers are going to use it, and then they always find a way to surprise us, especially with Google Play, because the landscape is so huge. There's always something every week where you're like, that's amazing, and I never would have thought of that.
Yeah, exactly. And so it's amazing to be able to do this. Plus, you realize that you're actually making a difference in people's lives, both for the developer as well as for the user.
Yeah.
And so that helps too.
It's interesting to talk about Google Play because developers building Android already know about Google Play. But sometimes I wonder if they know all of the kind of nooks and crannies and some of the best features. Do you have like maybe some of your favorite lesser-known features of Google Play that are great for app developers and publishers?
Well, I don't know whether it's about lesser-known features, but maybe we should talk about the things that people may not think about. Number one thing I believe that people should really think about is that your users really want your app to get better. And you should tap into them. I think a lot of times we think, I hear developers say, there's a really bad review, can you make it go away? And I'm like, no, harness it. Your user really cares. So what can you do about it? But they're also telling you positive things. So on Google Play, one of the things we've really focused on is to how to get developers harness all the intelligence of the users to make better products. So everything from alpha beta testing to stage rollouts, and now we just introduced A/B testing, which we call store listing experiments. So harnessing the intelligence of your users, who are your biggest advocates, and your users to make apps better, I think is something people don't use enough.
Well, and we just mentioned an article on the show about ratings and reviews in the Google Play Developer Console. And I think we've done a lot of work there to bring that intelligence into a format that's actionable and really intelligible at the same time.
Absolutely. One of the big things developers told us is that we love the fact that we can reply to reviews and that we can have a direct channel of communication to our users. However, there are so many reviews. How do I find the themes? How do I know areas that I should focus on? And what I find interesting is that there are folks who view it as something as a problem to fix, but a lot of people are now looking at as strengths that they need to leverage. So they're looking at it as a way to measure community sentiment management. So what we did is to say, how do we measure sentiment? And the tools that you're talking about allow developers to, use Google Smarts to understand all the hidden gems in your ratings and reviews.
That's cool. Developers often ask me, and I'm sure they ask you as well, what's the secret? And coolest thing is you actually recently published the second version of the Secrets to App Success on Google Play, which you should check out and will be linked in the show notes. However, maybe you could give us a highlight. What's one of your favorite kind of insights from that book?
The first thing we did was actually put it out linearly. So the nice thing about the book is that you can always just jump in where you are at the stage of what matters to you. So if you're in design, there is a section for design. If you're in a place where you're building growth, there's a section for growth. If you're thinking about, should I use ads for monetizing, there's a section for that. It goes not just about Android and Play, but also looks at other Google technologies, like ads, for example. So that's a huge plus. So the big insight I would like to point there is to really think about this, what it means to be not constrained by the market that you're in. Android is huge. It's around the world.
Okay.
And you could be a global business no matter where you are. This book gives you interesting ways to tie from everything from how do you design for various markets, how do you localize, but also how you price. So that I think is...
It's really inspiring.
Yes. I mean, think about it. 20 years ago, they would have needed a new management team to figure out how to take a business global.
Yeah.
Now you could do it from your living room.
And sales offices in multiple markets, whereas, again...
Now you can.
That's great. Thanks for joining me today.
Thanks for having me, Timothy. This was fun.
For more information about everything that we talked about, check the show notes for links. And of course, subscribe to this channel for more interviews like this. I'm Timothy Jordan, and I'll see you next time.
Polycast 43, take one.
Hey there, Polycasters. Rob here. Welcome back to the show. Last week, we were doing this thing called Ask Polymer, where we take questions from you and then we try and answer them here on the YouTube channel. And as we were collecting those questions, I noticed a lot of folks were asking, when's the Polymer team going to create a data table? Or what is the roadmap for this particular element and stuff like that. And as we were going through that process, I really started to think that, if web components are going to be successful, we're going to have to scale beyond the Polymer team. Really, it's going to be up to all of us out here in the community to start making cool stuff, sharing it with one another, and also promoting it, right? So one of the things that I wanted to do was, here on this show, I want to start a new segment called Built with Polymer, where I take all the cool stuff that you're building and we just show it off so other folks can get involved with the projects and start using it in their own applications. Now, to do this, we're going to start off by looking at a website called customelements.io. I'm curious, show of hands, how many of you have seen customelements.io before? Okay, I noticed that you did not raise your hand, sir. So for you and for other folks like you, I want to just walk you through how this website works and some of the cool stuff that's on there. So if you haven't seen it before, customelements.io is pretty badass. You can think of it kind of like NPM for web components. It's sort of a registry. It collects all the things that are actually in the Bower registry, and then it displays little bits of info about it. So you can search and you can find the different components that are out there. You go to the website, and the first thing that you're going to see up here are these three sort of main sections. You've got the stuff that is recently created. It's brand new. You got the things that have been recently updated, which I always like to see. That's supposed to be a clock. And then you've also got the stuff that's the most popular elements out there. So the things with the most GitHub stars. All three of these very useful categories to kind of keep tabs on. And one of the things that I also really like is you've got this really huge search field up at the top. Anything that you could kind of imagine needing a component for, you can just go type. So I might say, oh, I want something like a table. So go type in table, and now I've got all of these cool results popping up here for various kinds of tables. Another thing that customelements.io gives you, which is pretty awesome, is at any point if you want, you can click on someone's profile photo. And this will show you not only their profile page, but also all the cool elements that they've produced in addition to that one that you were looking at. So if you think someone's making some really high quality stuff, you can kind of stalk them on customelements.io and see what else they're making. Going back to where we were last week, a lot of folks were asking, when is the Polymer team going to create a date picker in the material design style? Now this is something that is not currently on the Polymer team's to-do list. We have a lot of elements that we've created, and right now what we really want to focus on is sort of polishing those, closing bugs, and making sure that they work really well. So at the moment, no one is actively working on a paper date picker, and that, for a lot of folks, is sort of a dilemma. But if we go to customelements.io, we go to the search field, we can just type in date picker, or just date, whatever, and we can see right here, right away, we've got this paper date picker that shows up by this guy named Ben Davis. So let's scope that out. And looking at the component page on customelements.io, we get a lot of information really quick right here. So I can see, for instance, how many stars this component has. I can see how many people have forked it and how many people are watching the issues on it. I also get the one-liner to install this on Bower. And what I think is maybe one of the most important aspects of the site, I get this activity panel here. And on the activity panel, I can see that the component was created a year ago. And most importantly, I can see that it was last updated 11 days ago, which tells me that this is still being actively developed. People are, contributing to this thing. They're patching it. They're fixing bugs. And it's getting a lot of love right now, which is important for anything that I'm going to add to my application. Also, we've got the list of Bower dependencies down here on the right-hand side. And again, it's really valuable because I want to know that, hey, is this thing depending on the latest version of Polymer, or at least Polymer 1.0 and some version above that? I don't want an element that is Polymer 0.5 or Polymer 0.3 or anything. That's just not going to work in my app. So having all of this information just kind of at your disposal every time you go check out one of these elements is a huge, huge benefit, and one of the main reasons why I think everyone should be using customelements.io. Now, the other thing that it does is it slurps in the README for this element. So you can see here on the left, I've got kind of the GitHub README that's just been pulled into the website. And if you want, you can go down here and click on the component page. And this is going to give you sort of the classic Polymer docs style, right? You've probably seen these before, where you can see properties that an element supports. You can see the methods that it supports as well. One of the things that I noticed was not showing up here. Usually up in the top right corner, there's a little demo button. It's not showing up on this page, but we can just add that by typing demo into the URL bar. And now, ta-da, we've got our paper date picker showing up. And you can see this thing looks pretty nice, right? I can go click around different dates. Changing the month gives me these sort of cool material design ripple effects. Close it, and then I can click this button again to show you how it reopens. Lastly, one of the things that's really important is making sure that the date picker is responsive. So I go grab the corner of my browser, start shrinking the page, and then boom, you can see that it has changed its layout, which is really, really good for mobile devices. So that is just one element that Ben Davis has produced. If you go back to his profile on customelements.io, you can see that he's got a few other items here. Paper chip, paper time picker, slightly different from a date picker, paper full screen dialog. A lot of really interesting looking stuff there that hopefully we can show off in a future episode. So go find some elements on customelements.io. Go find the authors, stalk them on GitHub, stalk them. Don't stalk them in real life, but stalk them on GitHub and on this website, right? So you can keep tabs on all the cool stuff that they're building. Another thing that happened last week was a lot of folks were asking, when's the Polymer team going to create a data table? Something that is really sophisticated that I can filter, where I can rearrange columns and do all sorts of stuff like that. Honestly, again, this is one of those things that it's such a big undertaking. No one on the Polymer team currently has it on their to-do list. Because building a complex data table, you could seriously just found a company just on making a killer data table. And in fact, there's a group of folks who have done just that. So recently, a team called Vaadin released a set of elements, which they're calling Vaadin elements. And very similar to the product lines that the Polymer team vends, things like iron elements and paper elements, they put out this set. And the bottom elements are split into kind of two categories. You've got these business-oriented elements for things like data tables and combo boxes. They've even created an icon set of kind of businessy icons. And then they've also got a bunch of sort of data visualization components, Vaadin charts. Now, the core elements, as they call them, these sort of business layout ones, these are all free and open source. They are Apache licensed, so you can use them in your project today. And then the chart elements, those are a commercial license, which you have to pay for. But since a lot of you were asking about data tables, I thought this would be a really good one to highlight because it's available on GitHub and you can mess around with it and use it today in your project for free. So if you go to their website, which is at vaadin.com/elements, they've got this little demo button. And if we click that, it's going to show us this cool expense manager application. So I'm going to scope out the live demo for this puppy. And we've got a really, really nice looking experience here. So kind of classic table layout, columns and headers. What I really like about this is there's these filters up at the top. So I can just go and check some of these values. And for instance, checking in progress and reimbursed, you can see over here the amount of items in the table is changing as I'm changing these values, right? You can sort of see them changing over here as well on the left. We can also look for different merchants. So I could say, oh, I just want to see stuff from the taxi merchant, for instance, and we'll just get only the expenses related to that category. Likewise, we can search by min and max values. A lot of cool things you can do here. They've even got this little floating action button down here at the bottom. So you can use that to open a dialog and actually add a new expense to this table. Really, really cool example. Really, really cool, powerful element. It's one of those things that, again, it's not on the Polymer team's agenda at the moment to build, but here you've got this awesome community-built project, which we can all start using in our own work. So yeah, that about covers it for today. I know I've only shown a couple elements, but there's actually a big, long list of elements that I want to start featuring on this show. But before I get into that, if you out there, if you've got some stuff that you've built which you would like for us to show off, it can be elements, it could just be cool projects that you've built, please leave me a comment down there in the YouTube comments, or you can ping me on Twitter at #BuiltWithPolymer. That about covers it for today. So as always, thank you so much for watching, and I'll see you next time. Ready? Yeah.
43, take 2, second sticks.
Hey there, Polycasters, Rob here. I'm gonna pause for a second. Oh, Twitter notifications.
If a tree falls in the forest and nobody's there to hear it, does it make a sound? More importantly, if your app gets published to the world and nobody's there to download it, was all that work for nothing? These aren't just philosophical questions. Discovery is a major issue for everybody. It doesn't matter if you're a two-person shop or a big corporation. And while there are many avenues for potential customers to discover your app, one of the most common is through recommendations from friends and family. Developers know this, which is why you see referral codes like this in a lot of apps. It's a good way of enticing users to share the app with their friends. But while these kinds of referral codes can be effective, they're also kind of a pain to use. Is your user really going to take the time and effort to copy and paste a referral code into an email, send it off to their friends, hope those friends then find and install the app, dig up whatever code redemption screen they need to redeem this offer, and copy and paste this code back into your app? Well, maybe, but maybe not. And while you could build your own UI to help this process along with, all those spare engineering cycles you've just got lying around, this is also where Firebase Invites can help. Firebase Invites makes it easy for your users to share all aspects of your app, be it a referral code or an interesting piece of content, across both Android and iOS. It looks something like this. Let's say that your app has a referral code that you'd like your users to share with their friends, and you decide to use Firebase Invites to make it happen. When your user clicks that share button, they'll see a dialog listing all their friends and colleagues with some smart recommendations at the top. They choose which friends to share with, click send, and these invitations are sent, along with a personal message, over SMS or email, depending on the contact. Their friends receive a customized, richly formatted invitation, either one you've designed yourself or one you've let Firebase Invites build automatically from your app's store listing. All this recipient needs to do is click on the call to action button, and Firebase Invites will take them directly to the app if they already have it, or the appropriate app store for their device if they don't. Once they're done installing your app, Firebase Invites can then send the referral code to your app through a deep link. And you can send your new customer the discount that they so richly deserve. And yes, this really does work even if that friend had to install the app first. Traditionally, deep links tend to get lost during app installs, but Invites uses Firebase Dynamic Links, which are able to survive the App Store installation process. As an added bonus, many developers have found that not only are these kind of invites more successful at driving installs, but that users who join through this kind of personalized onboarding flow are more likely to come back to your app in the future. And Firebase Invites isn't just for referral codes. You can use it to share any content you want from your app. Have a recipe app? Firebase Invites can make sure that killer lemon meringue pie recipe gets the visibility that it deserves. And because Invites is a Firebase product, it works with Firebase Analytics to let you know when a user has opened or installed an app through an invite. So be sure to check out the documentation and give Firebase Invites a try. We can't wait to see what you build.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real dataset we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The dataset includes 3 different types of flowers. They're all species of iris: Setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at Scikit provided a bunch of sample datasets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials, and because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left. Otherwise, go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now I could do that in theory by adjusting the multiplier on the center view's width constraint. But it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. Okay, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned simply by adding and removing two different groups of constraints and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, and otherwise, I'll see you on Route 85. Bye.
people love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer, so you'll want to make sure they each
We didn't do a mic check, did we?
Whoops.
You good?
Yes.
Yes. All right.
All right. Hi, everyone. Welcome to our session. If you're here to learn about the Daydream controller and how to design and develop for it, then, well, you're in the right place. We're going to be doing this session in 3 main chapters: how, why, and what. We'll dive briefly into the design of the controller itself. We'll then walk through the technical concepts on how to implement the controller support in Unity and C++. And then we're going to bring Ryan and Francisco on from Shell Games to share what they've learned and showcase over a dozen mini-games that they've built in the past few weeks that really help show what this new input device can do. So let's get started. Hi, I'm Bashir. I'm a hardware interface designer here on the Google VR team and the design lead for the Daydream controller. I'll be walking you through the first part. One of the most important things that we've learned from Cardboard, as you might have heard in our other sessions, is that while VR is great for gaming, and we've had so much fun with a lot of the games that we've played so far, we really believe that VR is going to be great for so many other things as well, and has a ton of potential as a computing platform. And that is what makes it such a compelling experience to a huge breadth of people. And for many of these people, the applications that you're building right now are going to be some of their first experiences in VR. And so the more we thought about that, the more we realized that we needed to build a better, more immersive, longer form way for people to interact in VR that didn't involve them keeping their hand up here on their head on one singular button like they do with the more snackable experiences of Cardboard. So we made the Daydream controller. While it doesn't literally float in the air like it does on this slide, it is something that you can hold in your hand that we've been creating for our new Daydream platform to help connect people to their environment in mobile VR. It enables you to explore and manipulate things naturally in a 3D VR environment by letting you directly point at and click on objects, hold a tool in the virtual world, and navigate menus. We've spent a lot of time and energy in order to create something that is accessible and simple enough for new users and people of all kinds of interests that enables everyone to express themselves creatively, directly, precisely, intricately, and that doesn't force them to lug around something huge and unwieldy. The ultimate goal was a powerful, simple tool that fits right in your pocket. So let's start from the top. The Daydream controller has a curved, clickable touchpad that allows people to make both fine-grained manipulations and quick swipes for scrolling while still enabling them to make click selections without lifting their thumb. How does that work? Well, if you look closely at the side of the controller, we've achieved this by embedding a tactile, clickable switch directly beneath the touchpad that allows the top housing to elegantly flex when you apply pressure with your finger. And that's something that shouldn't be too unfamiliar for laptop touchpad users. Then, reachable just below the touchpad are 2 buttons, the Home button and the App button. The recessed Home button is reserved entirely for the system. Pressing it takes people immediately back to the home world, while holding it down for just a little bit longer lets them reorient their view. The App button, as you can guess from the name, has its functionality reserved entirely for app developers. For example, you could use it to enable switching from a hammer to a saw, more often than not to open up a menu, or in some cases, undoing a failed pancake flip. And since your phone is inside the viewer and audio is such an important part of VR, we've put hardware volume buttons directly in your hand to make it so that people can reach them conveniently and quickly. However, the most important and foundational aspect of the controller is its ability to directly point in 3D space around you. We use a highly calibrated 9-axis IMU that combines and fuses data from an accelerometer, gyroscope, and magnetometer to output an absolute rotation value in VR space. This means that instead of relying entirely on a touchpad to scroll through lists locked to your viewport, or turning your head in every direction to click on something, instead you just point directly at it with your hand and click. And because it's done on a chip, you can do that anywhere around you, be it straight ahead, to your right, or behind you. And all of that without having any need to lug around and set up an external camera or tracking system. And because this took both leaps in design as well as in hardware and software, we've been developing both in parallel as a team together. Here is one of our hacky early prototypes that we had been using in development, which, because of its similarity in its size, we lovingly call the garage door opener. And we and our various teams around Google had been using these to test and prototype a lot of our software and hardware stack. But as we got deeper into the project, we realized we couldn't just mail one of these to everyone out there. And we'd really love for both everyone here in person as well as every other developer out there to be able to intimately incorporate this input into your development process while creating your new VR apps. So Bruno, Zhao, and I, and a handful of others, found a scrappier, cheaper, and more accessible way. It's in your pocket. Most modern mobile phones today contain almost all the hardware you need to replicate the controller, minus the click. So we created an app, which you'll be able to download soon, called, shockingly, the controller emulator. And although the orientation sensors might not be as precise or as calibrated as in our final hardware spec, it should be a great alternative to get off to prototyping fast. So with a second phone, you'll be able to start up the app, which creates a hotspot, and connects to your viewer to broadcast its input in real time. And that said, because we're working in a VR world that's only tracked via rotation, you're essentially blindfolded while you're in there, and you're likely holding a phone that's way bigger than the hardware controller spec. So we've created a sticker overlay to help guide your fingers. It's capacitive, comes off cleanly, but still gives you just the right amount of tactile feedback to find the now real-size touchpad and buttons on screen. We've got printable PDFs for scissors and paper, as well as laser-cuttable vector files, and a link to the sticker material. And all of that will be in the SDK download itself, as well as online on our developer site. I've also got a batch of them pre-made with me, so after this talk, I'll be standing outside the tent if you want to come grab one or ask questions. And Bruno, in the next chapter, will show you how to implement the SDK and how to enable you to use both this emulator and the final hardware in your apps, and switching between the two should actually be pretty seamless and require almost no code change. But before I go, I wanted to leave you with a pretty simple question. With the Daydream controller, we're incredibly excited about the possibilities that you'll come up with. You could be holding a tennis racket, a whisk, a frisbee, a steering wheel, and so much more right in your pocket. So what do you make in VR? Thanks.
All right. In my section of the talk, we're going to be speaking a lot about code. But what exactly is code? Well, the way I like to think about it is that if on the left side you have the user, and say on the right side you have some abstract concept, say happiness, then the only thing that's standing between those two is the code that we write. So that's why code is such a big deal. But before we talk about code, let's go briefly into the things that you'll need to write code for the controller. So if you have the controller on one side and you have your phone on the other, how do these two things communicate? Does anybody have a guess? Bluetooth? Yeah, that's a great guess. Yeah, more specifically, it is Bluetooth Low Energy. So the phone talks to the controller via Bluetooth Low Energy, and your app is there sitting on the phone. Now, if you're not exactly the type of developer who wakes up every morning thinking, yay, let's write some low-level Bluetooth code, don't worry, you won't actually have to. You actually, because the Google VR Services is a layer on the system that talks Bluetooth directly to the controller so that your app doesn't have to. Instead, your app interacts directly with the Google VR SDK. And the Google VR SDK does all the hard work of actually communicating to Google VR Services and ultimately to the controller. The controllers are going to be available later on in the year. But if you want to start developing right now, you can. All you have to do is assemble your own dev kit. And your dev kit consists of a viewer. You'll also need a Nexus 6P, as the phone, and you'll need to install the Android N Developer Preview 3 on that phone. Instead of a real controller, you can use a secondary phone as a controller emulator. So you need one viewer, and you need two phones. From the perspective of development, not much changes. You might be worried, oh, do I have to write code especially for the emulator, and then will I have to change everything? No, because the Google VR Services deals with the code that actually speaks to the controller. So in terms of SDK, it's the same thing. You don't have to worry about whether or not you're using the emulator or a real controller. Our SDK comes in several flavors. And you can go today to developers.google.com/VR if you want to get started developing right away. So you don't need to wait for the real controller. You can start right away today. Now let's talk a little bit about the features of the controller, which are common regardless of the SDK that you're using. The controller has 5 main features: orientation, gyroscope, accelerometer, and it also has a touchpad and several buttons. So let's go into a little bit of detail about each of those features. Starting with orientation, which is perhaps the most intuitive one. Orientation just means it's where the controller is pointing in space, in 3D space. We'd like to call it a 3-DOF controller, not only because DOF is kind of a cool word, but also because it means 3 degrees of freedom. And which 3 degrees of freedom are those? That is the yaw, so where you're pointing the controller, the pitch, also called elevation, and the roll, which is also called twist or bank. So those 3 angles are the 3 degrees of freedom of the controller. We represent those using a quaternion. And quaternions are interesting mathematical entities. In most cases, if you're using a math library or a game engine, you can treat them as a black box, or more specifically a blue box in this case, because they essentially encode a rotation that you can apply to a vector. But if you want to look inside a quaternion, it's not actually that hard. It has a vector component made up of x, y, and z. It also has a scalar component, and it has a 5th component. Does anybody know what the 5th component of a quaternion is? No? It's magic. Because that's the only way I can believe in how they work. Well, actually, at least that's what I thought in the beginning. But then as I studied them, I realized that the scientific truth is that they're only about 60% magic. The rest of it is not. We represent all of our coordinates in the right-handed coordinate system. So you have the x-axis pointing towards the right. You have the y-axis pointing up, and you have the z-axis pointing back. So this is just a standard textbook coordinate system. Next, we have the gyroscope. The gyroscope doesn't have anything to do with where the controller is pointing. It has to do with how it's moving. In particular, it encodes the angular velocity of the controller about each of its local axes. So just to give an example, suppose that you have the controller sitting flat on your table, and it's rotating counterclockwise slowly at 1 revolution every 2 seconds. So what would you read from the gyroscope in this case? Well, the x and z would be 0, because it's not rotating there. But about the y-axis, what would be the rotational speed in radians per second? If you guess pi, that is correct. Now, did I choose these numbers just to make this terrible pun? No, not in any way. That's a coincidence. The accelerometer, of course, measures the force of acceleration on the controller about each of its local axes. It is combined with gravity, just as on a smartphone. So normally, if the controller is sitting on your desktop, you're probably going to be reading something like 0, 9.8, 0, because the force of gravity is 9.8 along the y-axis. If you ever read 0, 0, 0, you should be concerned, because it means that the user is in outer space, where there's no gravity, or worse, that the user tossed the controller out the window and it's in free fall towards the ground. In which case, you might say, rage quit detected, would you like to play an easier level? Also, order me a new controller. Well, and lastly, we have the touchpad. The touchpad is that circular area at the top of the controller. It is a 2-dimensional surface, so we chose to use x and y very creatively to represent the position of the finger on that surface. In order to represent coordinates, we think of it as a square, and we map 0, 0 to the top left and 1, 1 to the bottom right. It's important to notice that the touchpad also has a clicker, so the user can both touch the touchpad and also apply some pressure on it to make it click. And those 2 things are different. And the buttons on the controller are the click button, which is precisely this button that the user presses when they apply pressure on the touchpad. And you also have the app button. The app button can be used by your app to do anything you want, like a menu or switching tools or anything else you want. We also have the home button on the controller, which is reserved for the system use. For example, that's how the user goes back to the home screen. that little thing on the side are the volume buttons, which is also reserved to the system. So the click and the app buttons are available to your app, and you can implement anything you want with them. Typically, clicker will be the primary action in your app, like painting, drawing, shooting, selecting, grabbing, or anything like that. And the app button will be some secondary action or to bring up a menu. So once again, touch is different from click, and this is a very important point. And on the emulator, since there's no such thing as clicking a touchpad screen, a smartphone screen, you actually double tap to emulate the click. And later on, we're going to give you like these little stickers that you can put on the controller emulator to get more of a tactile feel of how it works. Let's briefly go into the C++ SDK. Well, C++ is a great language. It's my favorite language. But the thing is, it's a powerful language that has some responsibilities that come with it. How does this sentence end? With great power comes great stack traces that you sometimes have to debug. But that's C++, and I like C++. Hopefully that won't happen to you. When your app is talking to our C++ API, it is actually talking to our C API that lives in libgvr.so. And the reason why we do a C API instead of a C++ API is because it's difficult to get two compilers to agree on how to compile C++. So instead, the C++ API lives entirely on your space, and it's just a wrapper around the C API. So you can use it without worrying about compiler ABI incompatibilities, which is good. Now let's look at code. If you have experience in C++, you're thinking, oh, that's a funny dialect of C++. But no, it's Java. It's because in Android, everything begins in Java. So on your onCreate function, first thing you're going to do is set the VR mode enabled, because that's going to enable all the nice VR optimizations for your app. Next, you have your GVR layout, what used to be called cardboard layout. You set the presentation view as you are used to doing. And next, and this is the important part, you get the GVR native context. So the GVR native context is just an opaque pointer to a GVR context, which is something that you'll need to initialize the controller API. When you're down into the C++ land, all you have to do is get that pointer and then store it somewhere, because you'll need it while initializing the API. Speaking of which, after you set the default options, that's where you pass in the pointer on the init function. You pass the options and that pointer. And then you can forget about that pointer, because it's only really used to synchronize the controller and the headset. After that, it's a very low-maintenance API. You just have to do some oil changes once in a while. And by oil changes, I mean just call pause and resume when your application gets paused or resumed. And next, you can read the controller state. Now, controller state is probably the most complicated part, because it encodes all of the state of the controller at any given time. So we put together a team of very creative engineers and told them to come up with a way to represent a structure that would encode the controller state. And what we came up with is struct controller state. It's just a struct, and it has data in it. Also, we made the creatively named readState method that reads the state. And it's that simple because it doesn't need to be more complicated. On your drawFrame method, on your rendering logic, you're going to call readState, and that gives you the latest known state of the controller. And then you can process that state in render. How do you do that? Well, the state has fields such as orientation, gyro, accel, and those just mean the current readings of the various sensors in the controller. For a touchpad, we have an is-touching Boolean that tells you if the user is currently touching the touchpad or not. And we also have what we call the event Booleans, or the transient Booleans. And those are the Booleans that tell you that a certain event just happened. And those are true for only one frame. So when you render your frame, that's going to be true. Next time you render your frame, it's going to be false, because it just represents something that just happened, like the user has just started to touch the touchpad or just stopped touching the touchpad. And of course, you also have the touch position in X and Y, as we explained before. Button states work in a very similar way. So you have the click button and the app button. You also have the state, and you also have the events. Recentering is what the user does when they notice that the headset and the controller are drifting apart, so they're no longer centered, or when they have just picked up the headset and it's facing the wrong way. So there's a gesture that they can do to make both of them recenter, and that's holding the home button, pointing forward for about 1 second, and then releasing. And then both the headset and the controller will be recentered to the same coordinate system. So before and after. Basically, if before the coordinate system had diverged, after they're both going to be pointing forward. And you can know that the user is recentering by looking at the recentering or recenter variable. You don't actually need to do anything because the coordinate systems are handled by the SDK. But if you want to, you can have access to those variables. You might want to pause the game, for example, when the user is recentering. Next, we have API status. The API status just tells you about the general health of the API. So we have kcontroller API OK, means everything's going well. There's API unavailable if the service is unavailable. Client obsolete if the client is obsolete. Service obsolete if the service is obsolete. And zombie apocalypse if there's a zombie apocalypse and the undead are taking over the planet. Just kidding, that one doesn't exist. The controller will continue to work in case of a zombie apocalypse. Connection state is just whether or not the controller is connected to the phone right now. So there's disconnected, there's scanning, connecting and connected. The best state is connected. And I'll tell you how later, but this has to do with saving the world. More on that later. And you can download the demo app and look at code that actually does all of those things. Let's quickly look at the Unity SDK. In Unity, just as you did before with the Cardboard SDK, you import the Unity package into your Unity project. Once you do that, you'll notice that there's a prefab under Assets Prefabs controller called GVR controller main. And all you have to do is drag that prefab into your scene, and then you have access to the controller API. In Unity, you normally edit things in the editor, and then only after you're happy with it do you actually deploy to the device. And we support that use case because you can plug in the controller emulator directly to your computer via a USB cable and have it work during the edit mode. And then once you're happy, you can deploy it to your phone, and then it's going to work via Wi-Fi. Let's take a look at an example code. Let's suppose that I have an object, and I want that object to match the pose of the controller. All I need to do is set the object's local rotation to the controller's rotation by calling GVR controller.rotation. It's that simple. Suppose now that you want to have a vector that represents where the controller is pointing at. Again, we just have to multiply something by vector3.forward, and that something is just GVR controller.orientation. That's what you multiply, and then you get a vector that points in the same direction that the controller is currently pointing at. Now let's do some raycasting. Suppose you have a game where the user is trying to select an object in 3D space using the controller as if it was a laser pointer. Again, you just get a vector from the controller and then do the usual Unity raycast to figure out which object was hit. So the API is very straightforward. Lastly, we also have gyro and accelerometer, and those are they're just reported in that format that we described before. And you have the touch, which works just like the C++ SDK. It's touching is whether or not the user is touching currently, and then there's touch down, and then there's touch up. Same thing for buttons, all the same logic. Click button down, click button up. Yes, click is the name of the button. So app button down, and up. And then we have, of course, the GVR controller.state. Same thing, disconnected, scanning, connecting, and connected. Oh yeah, and I had promised to tell you why that has anything to do with saving the world. Okay, imagine that you have a game where you're trying to save that nice little planet there that is just exactly like Earth. And suppose that there is this evil enemy. Let's say you're trying to defend it from the moon. That makes no sense. Let's say it's something that's definitely not a moon. So you're trying to save it from that enemy. And just as you are in the final boss battle, the player is about to deal that final blow and save the planet. Then what happens? Of course, the controller disconnects. And then they are sitting there, and they're not able to do anything, and that's the end of humanity as we know it. And because we like humanity, and we should, this is how you save it. Anytime the GVR controller.state is anything other than GVR connection state.connected, that's when you should, for example, pause the game and let the user reconnect the controller instead of continuing to play. So we talked a whole bunch about all the features of the controller. We talked about our SDKs. And again, you can go to developers.google.com/VR right now, and you can download the SDKs and the emulator app if you want, so you can get started developing today. In the beginning, I showed you this, but I actually lied a little bit. That's not 100% true. The only thing that's standing between user and happiness, it's not just code. There's more to happiness than code, surprisingly. You actually need design. And if you're asking what's the difference between code and design, the way I like to think about it is that code is when you're doing the thing right. And design is when you're doing the right thing. So in order to talk to you a little bit more about how to do the right thing, I would like to welcome Ryan and Francisco from Shell Games.
Hello, everyone. My name is Francisco Suki. I'm a game designer at Shell Games in Pittsburgh, Pennsylvania.
And I'm Ryan Hipple. I'm a programmer at Shell Games.
And we spent a little over a month just making cool stuff for the controller, right? We made 17 demos, and our goal was to just play around with the controller, see what feels right, and we were using the same tools that would be available to you today if you were to develop, right? A Nexus 6P and the headset, and an emulated controller and a Nexus 5, and using Unity to make all our games. So we're going to take you through some of the demos that we made that we learned a lot from, and tell you a little bit about the design on my side and the code on Ryan's side. And to start, I will say that, like you heard these guys say, this controller has a lot of sensors, it has a lot of data, it gives you a lot of power, and me as a designer, when I saw this, I was like, this looks cool, I guess. Ryan, you know how to interpret all this stuff, so my vision for this is, I have a controller in my hand. Can we just make something that feels to the player like they're holding something, like they're holding the controller?
Of course. How about a game of tennis or a brick-breaking game? Or what if we just combined those two and made a tennis brick-breaking game? So our tennis demo, we're using the orientation quaternion from the controller to control the rotation of a tennis racket that pivots around the body of the player. And we have a very natural range of the tennis racket that way, where you can do your forehands and backhands, and it's always rotated around the right spot. On the more game design side of this, we are focusing on leveraging the very accurate orientation we get from the SDK and using that to make sure that when you hit the balls, you're either directing them upward if you're tilting your wrist up, or down if you're tilting your wrist down, and you can make them go to the left or the right. So in order to do that, we're actually cheating the collisions in this game a lot to make the game easy to hit, and we're actually putting the game challenge in there by forcing the player to use that accurate aim in order to twist their wrist to get the ball exactly at the panel that they want to smash.
Yeah, so like Ryan said, in this game, it's all in the wrist, right? We do a little bit of timing so that if you swing early, it'll go that way. If you swing late, it'll go that way. But you don't have to worry about the position of the ball and how to hit the ball. It's more about your aiming with the wrist. It was very fun. The playtesters loved it, or shall I say, the playtesters that love skill games loved it. The playtesters who maybe aren't fond of tennis or don't like skill games, they weren't so hot on it. So my immediate thought there was, well, why don't we try some more traditional motion, kind of like gesture detection, and see how they feel about that.
Of course. So in our more traditional motion control game, we have our warrior game, which you can see in this video here. Players try to slash at objects before they hit a warrior avatar. And we're using this by actually just detecting a few simple gestures with the controller, and we're using the gyroscope readings here. The gyroscope readings are the perfect thing for this because they're going to tell us how fast the player's moving the controller. So once their movement speed is exceeding some threshold that we need to use, we'll figure out exactly what direction that's going, and we'll quantize that into a left, right, up, or down slash, and use that to power an avatar that has a sword and gets to break stuff.
Yeah, so this works. But you do get a little bit of that kind of like, I'm standing here, swiping effect, right? Which is how every other sword game before has been made in a gesture-based motion control. And our players who had tried the tennis first were like, I want that one-to-one. Why are you giving me gestures? So Ryan, is there anything we can do to this game to get some of that one-to-one back but not compromise the core mechanic?
Yes, there is. This is where we can one-up traditional motion control games because we have that accurate orientation quaternion. So by maintaining the gameplay that we already have with the slash gestures, we can use the orientation to power the animation on this character and the scene. And we use that to blend between several animations or several poses. And the sword on this warrior character should always be reflecting the orientation that a player is holding the controller. Additionally, one issue with our first approach was if you would swipe to the left, you would do a sword slash to the left. But if you're twisting your controller, that's now an upward swipe. So you can get around that by multiplying or by transforming your gyroscope readings by the orientation. Which will give you something that's more of a world space slash detection. So no matter how they're twisting the controller, it's always going to slash according to the movement of the player.
Yeah, so you can definitely take those gesture controls to the next level. But I wanted to go back to that one-to-one, to that holding an object in my hand and examining it and trying it out. And I was hoping maybe instead of aiming far away, we could give them, the players, something that's a little more close range to play with.
So, in our xylophone demo, we let players play a massive xylophone with a massive hammer. Why not? Here we're actually taking the orientation and splitting it up into different components and treating each of those axes differently. So, swinging the hammer up and down, we're using the pitch axis or the x-axis, and that's powering the position or the rotation of the hammer. And we keep a little bit of a constraint on that so it doesn't clip through the keys and it doesn't break immersion. We're using the ability to point, so this would be the heading or the yaw of the controller, in order to aim at what keys the player is going to hit to play what notes they want to play. On top of that, we're using a little bit of the camera's rotation. So you'll notice in the video here that the field of play is much broader than what you can see with just one screen. So turning your head, you can look to the left or to the right. And we're using that to cheat a little bit and make sure that the player is going to hit the thing that they're focusing on, so that when they're moving their hand quickly, they don't end up throwing off the direction of the hammer. So we're doing a little bit of aim assist in this game.
Yeah, and in this demo, you can tell the players are starting to feel things start to gel, right? They love manipulating a closely held object, and you can usually, as a game designer watching them play, watch them go through 3 stages. The first stage is they jump in the world, they see they're holding a hammer, and they do the wrist thing. And the hammer does the wrist thing for them, so that's great. The controller is working perfectly there. Then they realize the keys are in a curved shape, so they look around, right? So they're using that sort of VR space, looking all around, and then they identify any key they want to play, and they go for the boop, and it works, right? So it's a combination of where you're looking and how you're swinging, and when that feels right, and when the world holds up to what they want to do as players, it feels great for them, and then that's where the platform really shines. So that combination of head orientation and controller action helped improve their perceived accuracy, and so I'm thinking, well, can we use that combination of that aiming and that closely held object to maybe let them do something that they wish they could do, but they can't do in real life?
If anybody's here actually tried to throw a boomerang, has anybody ever tried to throw a boomerang? It's incredibly disappointing. There's a very, very, I guess, powerful technique that is only mastered by a few. It's really sad. You throw it, it doesn't come back, it doesn't go where you want it to go, it just kind of wobbles around. But there's this expectation of what a boomerang does. You see that shape and you feel like I should be able to throw this, it should be able to go exactly where I want it to and have it snap right back to me. So this is where we take the orientation that we get from the headset, again, and we use this as an aim assist. So where the player's looking in this demo is going to drive where the curve of this boomerang goes. And the goal here is to break as many of these floating targets at once with a single throw to kind of get that ideal path. So since we're using the head for aiming, we now have the controller free to do our throwing. And we're using the similar thing we did for the sword slashes here, where we're using the gyroscope readings, and if it's above a certain threshold, it's going to trigger the throw. So just looking where you want to throw and doing your throw gesture is going to get that boomerang out there. Additionally, to maintain a little bit of immersion here, we're using the orientation to make sure the boomerang rotates to reflect the rotation of the controller, at least when it's in your hands. And you can see that in the videos here, just that little bit of ambient movement just is keeping it, grounding the player between the 2 worlds.
Yeah, so like Ryan said, this video is about empowering the player and about letting them experience their boomerang fantasy, how they feel it throwing a boomerang should feel like, right? So it's all about like, boom, I want to put it in that exit sign, bam, it's going there, right? So less about very precise one-to-one matching of the thing they're pointing at or the exact hand movement, and more about the precise matching in the boomerang in their hand combined with the aim assist that the gaze is providing us. So it's all about kind of interpreting all of those, all that data that we get, and letting the player sort of fulfill what they think it should play like. What we realized at this point, though, is we hadn't touched the touchpad at all. It was all about the swinging and all about the pointing and the head. And touchpads are just the #1 thing usually used in games, right? Whether it's a joystick, a virtual touchpad. So we're like, we use touchpads all the time for all of our games. Can we just put something we would normally make in a normal platform, a different platform, a non-VR platform in this special place with this touchpad? Does it hold up?
Of course we can. Using the touchpad that we have on the controller, we can use that as a traditional D-pad controls. And this is something that players are going to be immediately familiar with because it's the type of games that have existed since, well, almost the beginning of games. So in our adventure game demo, the player controls a little character walking around using that D-pad. And the nice thing about this is it frees up the headset now functions as your camera control, which is generally a little bit of a problematic control scheme in adventure games. So you can look around the world, and it adds this sense of exploration that you can see more than you would be able to if you had to have this automatic follow camera. Those controls then also, we have them a little bit specialized for the layout here. We were able to have this character and an environment, it circles the player and their perspective. So when you want to move the character along that path, we have it so that it's almost a circular-based path. You hold to the right on the D-pad, and this player is going to trace a circle, or the character will trace a circle around the player, making it much easier to navigate, making it easier to make the player move forward through the world. And of course, in this demo, we have it end up with the player meeting the character they've been controlling this entire time.
Yeah.
We also use a little bit of the gesture controls that we talked about before and the click pad in order to use abilities that can trigger things in this environment and have some light puzzles and some collection mechanics, as you can see.
Yeah, so boy does it hold up, right? Like when you're making your own adventure games, you will realize that you can use a touchpad for movement, no problem. It's going to feel great. And that's going to free up all the other stuff in the controller for you to explore that space. So this is the extent of the demo that we made, right? Everything you're seeing here is the totality of the spaces we explored. So what that leaves is a lot of open space for you guys to sort of take it to the next level however you feel like you want to. So in this case, the click, the gestures, the pointing, all that is still freed up. It's not something that you need to use, and the touchpad feels familiar to the players. It's recognizable, so you truly can use all of those interactions because the player doesn't need to think twice about how to use a touchpad to move a character. Ryan, where did we take it after we figured out that the touchpad was good for one character?
Well, if it's good for one player, let's see if we can use it to control multiple characters. So in our real-time strategy style demo, we're using the orientation quaternion that we get from the controller, from the SDK, and using that to raycast into the world. And you can use this to point to select a character and then point to direct them somewhere. And you can also drag select to select multiple characters in the world and give them instructions at the same time. You can also use gyroscope gestures again, like we did for the sword slash and like we've been doing for a lot of the games, to trigger multiple actions that these characters can do. And in this, we have a few simple puzzle mechanics that lets the player explore this world. And again, you're using the orientation from the headset and taking control of the camera very naturally with just the player's look vector.
Yeah, and boy, does point and click feel good in this platform. We love this demo. Playtesters love this demo. People couldn't put it down until they figured out the full puzzle that we had. And the interaction was just empowering them to control the characters how they wanted to control the characters. We also draw a line from the assumed controller position to the target, and that keeps players aware of the orientation of their controller at every time. And that interface does make it really easy for you to control one character or several characters. And similar to the adventure game that you saw before, the touchpad game, it frees up a lot of the controller, especially because you can also use the whole world, the whole 360 around the player to sort of pace out your level and to control where the player is going to be looking at any given time, so that camera movement doesn't need to be tied to the controller in every way. So if your mind right now is going like, man, how can I use a mechanic to make an RTS or to make a strategy game, a tactics game, any sort of multi-character control game with that drag to select and all that, that's exactly where it should be going because the platform is really good for it. What we thought, though, was, well, we figure out how to sort of get the most of those orientation controls, how to get the most of the character control. Can we marry those two together?
Of course we can. In our Skyship demo, the players control a gliding airship through an environment where they're dodging obstacles and trying to pick up coins along the way. This is actually pretty simple on the input side where we're just using the orientation that we get. This lets us essentially just point and click, or I'm sorry, no clicking, point to guide this glider around the environment and using the yaw, the pitch, and the roll just like you would with an actual aircraft to get it to move around this environment. Having the roll or the twist as well is really nice for this because should the mood strike you, you can do a barrel roll.
Yep, and Ryan said no clicking because, again, the clicking is freed up here for you to do whatever you might want to do on a flying ship. When you play this, it really feels like you're kind of handling a toy airplane, right? You're kind of like threading it through space, all through these rings. The hand shakiness is not a big problem here because you control how wide the gaps are with the rings or the spaces that you're trying to fit the spaceship through or the ship through. So that kind of counters a lot of the imprecision that your own hand translates into the world. And it does allow you to orient the ship sort of however you want as you're flying with it, right? This is another one that playtesters couldn't put down. We just keep the rings coming, and they will keep playing And so like unless you give them a goal of like collect 10 coins and then please pass it along, they will just like stay in there doing it all the time, right? It feels good. The pillars are there so that you don't get that motion sickness from moving forward. You're stationary, the world's moving in front of you, so you're fine. You don't get that motion sickness. And at that point, we're feeling pretty confident, and we're like, all right, we seem to have this flying thing figured out. It's constrained to a plane, but maybe we can break out of that plane. Maybe we could go a little bigger. What I want to do is I want to feel like, not like I'm flying a kite, but like I'm controlling this giant creature that I just summoned.
Here be the dragons. In our dragon demo, the player controls a massive dragon using, again, the controller orientation, and they're pointing the controller in the direction that they want the dragon to go. To give a little bit of an immediate feedback, we have a little doll or a statue of the dragon positioned in front of the camera so the player can see what the goal orientation is. And this is another thing that we've learned in the other demos where we want to maintain a relationship between the controller and some physical object in the environment. Then in order to make the dragon feel like it's this massive entity, we have that point towards that vector that you're guiding it towards and have it sort of lumber along in this long twisting path, collecting and destroying those floating objects.
Yeah, but this one feels really good. When you get the source to play with all of these, just fire up this dragon demo, point the controller at yourself, and watch a dragon come at you. And we've added a bunch of things in there that sort of like take advantage of that VR, right? There's a slight camera shake, which sounds kind of like, what, you're shaking the player's camera? But don't let anyone ever tell you what you can't do in VR. Try it and see if it works or not, because it works here, right? It's a slight shake. It's combined with the positional audio of the dragon, so that you really feel like you're sharing a space with this big creature. And you're kind of doing this dance with it. It's big and it's heavy, and it handles like a big, heavy creature. So you're kind of like dancing with it through space, right? And you're trying to eat up all these big structures, and then you point it at yourself, and it's coming at you, and there's this thing next to you, and it tries to eat it, and you're like, oh my god. It's great. It feels really good, right? This is really, I think, showcasing what the Daydream can do, which is a lot, but especially when you combine the headset with the controller, and you get those epic flyovers with the dragon. It feels great. So at this point, we're like, all right, I mean, we did the dragon thing, the boomerang thing, the xylophone to play the music, a bunch of other stuff. We have 17 in total. I mean, what's left for us to do? Should we really give the people what they've been asking for all along?
You've seen it already. You've seen it plenty. Here be the pancakes. In this demo, we're actually using the orientation to flip these pancakes, and then we have a very advanced pancake physics engine that we're running to make sure the pancakes are moving around as they should. Well, in reality, it's actually just using the basic game physics system here, and having a pan that has the lip on it as the collision structure, it actually works really, really well. This orientation gives you that really nice flip gesture that you can do, and we're not really doing a gesture detection. When I say gesture, it's just sort of natural how the physics simulation pairs up with having this raw orientation input. And it turns out to be a very, very fun thing to do. We did do a little bit of active pancake assist here to make sure the pancakes don't get out of reach, but overall, it's just a very natural, fun demo.
Yeah, and I do think the pancakes sort of fit what is awesome about Daydream, which is you see the pancakes demo, you've been reading, like people are tweeting about it from the keynote and all. It's like, oh my god, I want to flip pancakes in VR. And you get in there and you flip pancakes in VR, and it plays how it looks. You're flipping pancakes in VR, and you're like, yes, got it. So when the platform allows you to do exactly what it looks like, and it feels like what it looks like and what it should feel like, that's when you know it's a big win. So over to Ryan for some final thoughts on developing all these awesome demos.
What if we could eat pancakes in VR?
That's the next step.
Francisco mentioned at the beginning of our section that we built 17 demos, so 17 demos like these, and we did that in a little over a month. All of the tools that we had to do this were the SDK that Bruno and Bashir talked about, and using the controller emulator, where you're actually using a phone as your input device, and a Nexus 6P we were using a cardboard to develop with. So all of these things are out there, and they're available now, and the source code for all of the demos that we've built should be available soon for people to play around with and use as a starting point to jump in and start making great games with this platform. We really feel like the things that we put together only really scratch the surface of what we can do with Daydream and what we can do with this amazing controller. So what will you build? Thank you.
Thanks.
I want to just walk you through how this website works and some of the cool stuff that's on there. So if you haven't seen it before, customelements.io is pretty badass. You can think of it kind of like NPM for web components. It's sort of a registry. It collects all the things that are actually in the Bower registry, and then it displays little bits of info about it. So you can search and you can find the different components that are out there. You go to the website, and the first thing that you're going to see up here are these three sort of main sections. You've got the stuff that is recently created. It's brand new. You got the things that have been recently updated, which I always like to see. That's supposed to be a clock. And then you've also got the stuff that's the most popular elements out there. So the things with the most GitHub stars. All three of these very useful categories to kind of keep tabs on. And one of the things that I also really like is you've got this really huge search field up at the top. Now, anything that you could kind of imagine needing a component for, you can just go type. So I might say, oh, I want something like a table. So go type in table, and now I've got all of these cool results popping up here for various kinds of tables. Another thing that customelements.io gives you, which is pretty awesome, is at any point if you want, you can click on someone's profile photo. And this will show you not only their profile page, but also all the cool elements that they've produced in addition to that one that you were looking at. So if you think someone's making some really high quality stuff, you can kind of stalk them on customelements.io and see what else they're making. Going back to where we were last week, a lot of folks were asking, when is the Polymer team going to create a date picker in the material design style? Now, this is something that is not currently on the Polymer team's to-do list. We have a lot of elements that we've created, and right now what we really want to focus on is sort of polishing those, closing bugs, and making sure that they work really well. So at the moment, no one is actively working on a paper date picker, and that, for a lot of folks, is sort of a dilemma. But if we go to customelements.io, we go to the search field, we can just type in date picker, or just date, whatever, and we can see right here, right away, we've got this paper date picker that shows up by this guy named Ben Davis. So let's scope that out. And looking at the component page on customelements.io, we get a lot of information really quick right here. So I can see, for instance, how many stars this component has. I can see how many people have forked it and how many people are watching the issues on it. I also get the one-liner to install this on Bower. And what I think is maybe one of the most important aspects of the site, I get this activity panel here. And on the activity panel, I can see that the component was created a year ago. And most importantly, I can see that it was last updated 11 days ago, which tells me that this is still being actively developed. People are, contributing to this thing. They're patching it. They're fixing bugs. And it's getting a lot of love right now, which is important for anything that I'm going to add to my application. Also, we've got the list of Bower dependencies down here on the right-hand side. And again, it's really valuable because I want to know that, hey, is this thing depending on the latest version of Polymer, or at least Polymer 1.0 and some version above that? I don't want an element that is Polymer 0.5 or Polymer 0.3 or anything. That's just not going to work in my app. So having all of this information just kind of at your disposal every time you go check out one of these elements is a huge, huge benefit, and one of the main reasons why I think everyone should be using customelements.io. Now, the other thing that it does is it slurps in the README for this element. So you can see here on the left, I've got kind of the GitHub README that's just been pulled into the website. And if you want, you can go down here and click on the component page. And this is going to give you sort of the classic Polymer docs style, right? You've probably seen these before. We can see properties that an element supports. You can see the methods that it supports as well. One of the things that I noticed was not showing up here, usually up in the top right corner, there's a little demo button. It's not showing up on this page, but we can just add that by typing demo into the URL bar. And now, ta-da, we've got our paper date picker showing up. And you can see this thing looks pretty nice, right? I can go click around different dates. Changing the month gives me these sort of cool material design ripple effects. Close it, and then I can click this button again to show you how it reopens. Lastly, one of the things that's really important is making sure that the date picker is responsive. So I go grab the corner of my browser, start shrinking the page, and then boom, you can see that it has changed its layout, which is really, really good for mobile devices. So that is just one element that Ben Davis has produced. If you go back to his profile on customelements.io, you can see that he's got a few other items here. Paper chip, paper time picker, slightly different from a date picker, paper full screen dialog, a lot of really interesting looking stuff there that hopefully we can show off in a future episode. So go find some elements on customelements.io. Go find the authors, stalk them on GitHub, don't stalk them in real life, but stalk them on GitHub and on this website, right? So you can keep tabs on all the cool stuff that they're building. Another thing that happened last week was a lot of folks were asking, when's the Polymer team going to create a data table? Something that is really sophisticated that I can filter, where I can rearrange columns and do all sorts of stuff like that. Honestly, again, this is one of those things that it's such a big undertaking. No one on the Polymer team currently has it on their to-do list, because building a complex data table, you could seriously just found a company just on making a killer data table. And in fact, there's a group of folks who have done just that. So recently, a team called Vaadin released a set of elements, which they're calling Vaadin elements. And very similar to the product lines that the Polymer team vends, things like iron elements and paper elements, they put out this set. And the Vaadin elements are split into kind of two categories. You've got these business-oriented elements for things like data tables and combo boxes. They've even created an icon set of kind of businessy icons. And then they've also got a bunch of sort of data visualization components, Vaadin charts. Now, the core elements, as they call them, these sort of business layout ones, these are all free and open source. They are Apache licensed, so you can use them in your project today. And then the chart elements, those are a commercial license, which you have to pay for. But since a lot of you were asking about data tables, I thought this would be a really good one to highlight because it's available on GitHub and you can mess around with it and use it today in your project for free. So if you go to their website, which is at vaadin.com/elements, they've got this little demo button. And if we click that, it's going to show us this cool expense manager application. So I'm going to scope out the live demo for this puppy. And we've got a really, really nice looking experience here. So kind of classic table layout, columns and headers. What I really like about this is there's these filters up at the top. So I can just go and check some of these values. And for instance, checking in progress and reimbursed, you can see over here the amount of items in the table is changing as I'm changing these values, right? You can sort of see them changing over here as well on the left. We can also look for different merchants. So I could say, oh, I just want to see stuff from the taxi merchant, for instance, and we'll just get only the expenses related to that category. Likewise, we can search by min and max values. A lot of cool things you can do here. They've even got this little floating action button down here at the bottom. So you can use that to open a dialog and actually add a new expense to this table. Really, really cool example, really, really cool, powerful element. It's one of those things that, again, it's not on the Polymer team's agenda at the moment to build, but here you've got this awesome community-built project, which we can all start using in our own work. So yeah, that about covers it for today. I know I've only shown a couple elements, but there's actually a big, long list of elements that I want to start featuring on this show. But before I get into that, if you out there, if you've got some stuff that you've built which you would like for us to show off, it can be elements, it could just be cool projects that you've built, please leave me a comment down there in the YouTube comments, or you can ping me on Twitter at #BuiltWithPolymer. That about covers it for today. So as always, thank you so much for watching, and I'll see you next time. Ready? Yeah.
43, take 2, second sticks.
Hey there, Polycasters, Rob here. I'm gonna pause for a second. Oh, Twitter notifications.
Actually, okay, glad you asked, because I did think a little bit further than you, since you've started driving and you've no idea where you're going. I thought since we went to the Boozer in England, we could this time continue the trend, but go to a vineyard.
Ooh,
yes.
That's...
Keep it classy. See now, look at this, right? I kind of feel like, yeah, all right, like we did the pub before back in England, but I do think this is a slightly better view.
How qualified do you feel?
Not at all.
Yeah,
I know you're going to this. I know it's red or it's clearish kind of colour.
It's nice and it's not nice. It's one of those very binary with my wine tasting.
And I have an upper limit of about £5 or $8, and if it's more than that, it's probably not worth it.
Anyway,
right. So I want to, since we're here,
yes,
we tend to talk about the web, and today I think is no different. I want to talk about libraries and frameworks.
Ah, yes, because you're not big on the frameworks, are you?
No, and neither are you.
And on the other hand, I am not big on the frameworks.
Yes, I don't think there's going to be much of an argument, but I do want to talk about it because it bothers me that I perceive that the default state of developers is, I've got a blank page here, how am I going to fill it out? I need a framework. Which one do I use?
That is a problem I have with frameworks, that they have a way of starting projects. Like there's a kind of expectation to use them from the offset. And I think if you're thinking, what combination of frameworks should I use to render this blank page, then I think something has sort of gone wrong. Yeah. For me, it's entirely from a performance point of view. Well, no, it's not actually. But okay, step one, performance. If your page has to load a ton of JavaScript in order to make a request for the actual data it's going to display, you've lost performance. Yes. And you can sort of say, oh, but next time it's going to be cached. It might not be. You might have changed the code, busted the cache.
And it's an assumption that somebody's going to come back again. Right?
Well, it's your goal, I would say.
It's your goal, but you don't know that somebody's going to. It's like paying a big, fat, hefty tax on the assumption you're going to get a repeat view. And
That's
you
true.
might not.
That is
you
true.
might not.
Yep. And stuff falls out the cache all the time.
Yeah, exactly. So
not the service worker cache, though.
Oh, you and service worker. Here we go again.
Service worker!
Da, da, da. One trick pony, Jake Archibald.
Come on, but it's got a cache, you can rely on it.
All right. Okay, performance that notwithstanding, I think for me, it's about code ownership somehow. It's about a level of trust that I don't necessarily feel. And what I want to do is I want to be able to feel like my application code is the thing that's running, that I'm not running through something else that I don't necessarily understand.
Running through something else is fine, because that's what a library is, right? Like you've got you've got hold both ends, and you're running through bits of library that you don't understand.
Yeah.
But that's fine, because if one of them starts misbehaving, rip it out, either code it yourself or find a replacement library.
But when you're going through something else,
you're in something else, I think, with a framework. And the framework will vend you little bits of, it'll give you scraps, and then you do something.
Can I have some more? I'd like to work with this application.
Can you please send this data over
more? Get out.
But then the frameworks, you're sat in a tiny bubble of the overall application with a framework. And I feel like to get the most out of a framework, you need to understand how the framework is built. And these frameworks are huge, so it's
They
really
are.
difficult to do
I actually feel maybe this is wrong, but it feels to me like it's a kind of, the decision is an ergonomics one. Like a developer's saying, my ergonomics trumps the user's requirements. I want to feel like, my job is easy, and what the user gets is what the user gets. And my whole approach is very much the other way. I'd rather go the extra mile, and all my users benefit, than my life is a bit easier, and I'll take some of the bad performance or the tax of using that framework. So I don't think that frameworks are inherently evil and to be avoided, but I think you want to be able to transition to one and say, yeah, now it feels like we're getting to the point where we're going to reinvent that. And I think you can only do that when you've got to a certain point with the build.
So for you, it's start light, start with libraries as when you need them, and then make the jump to frameworks only if you have to.
Agreed.
Dion, how you doing?
How's it going, Timothy?
I'm screaming to the I/O gods. You want to try it with me?
Okay, let's do it.
Ah! We're here at the ground floor of Google I/O 2016. I'm here with Dion Almer. Dion, how are you doing?
I'm doing really well. Yourself?
I'm doing fantastic.
It's go time.
We are T-minus 2 days.
Yes.
As you can tell from the forklifts and the array of things yet to be put in their place.
We're going to make it, right?
I think we're going to make it.
Okay,
I'm
good.
told we're going to make it.
Good.
We're going to sneak around and take a look at the I/O grounds right before it gets done, so you get a behind-the-scenes look at how I/O 2016 came together.
Let's do it.
Oh, now this is a completely different microenvironment. It's cool. It's very nice, and it's huge too. I think there's going to be a lot of Android and some Firebase talks in here.
Yeah, even some improv comedy.
Is that in here too? Okay, let's go find some people. Okay, so Chet Haas is here to tell us about the cool stuff that's getting set up. Have you had a chance to walk around at all?
I walked into the tent where I was supposed to be.
And did you get set up?
I did for 3 different sessions that I'm involved in this week.
Excellent. Is there anything that you're going to announce that you don't want to tell our audience right now?
Yeah, we're going to need to bleep out the following phrase and this next one too.
Android.
Not yet.
Okay. What do you hope for this I/O outside of your sessions?
Hello, everyone. How are you all? Great. Such a wonderful crowd. Thank you so much for all coming to my talk today. So my name is Jenny Gove, and I'm a user experience researcher here at Google. I've been at Google now this month for 10 years, and I heard that that coincides. Thank you. I heard that that coincides with the number of years we've been having I/O conferences, so double anniversary. That's really fun. So this afternoon, we're going to be talking about developing great apps and creating principles of mobile app design that I want to share with you so that you can create great experiences for your users. And why is this important? Well, it's important because there are over 1.5 million apps in each of the app stores, as we know, so there's a lot of competition out there, and you don't want your app to suffer from usability flaws. I think usability flaws and user experience issues can contribute to the lack of engagement that some apps have. So, for example, we've learned that things like 25% of apps sometimes don't get used more than once, and that 34% of apps aren't open more than 11 times. So there's these statistics that are around with regard to app engagement and re-engagement. We're doing a lot of work on that issue itself at Google with certain products that we're bringing out. But I think it's also on us to really work on our user experience and our usability issues in our apps. So I'm going to tell you about 3 things in the rest of my talk. I'm going to tell you a story about an experience I had with an app recently. I'm going to tell you about a study that we ran to understand what makes a really great app experience. And I'm going to go through some of the principles that we have published online so that you can understand some key things that you can do to make your app experience better. And within those principles, I've got a number of resources for you as well that can help you along the way. So my story, well, I was on vacation with my family. Here we are. We're having a wonderful time in Florida. That's me and my partner and my kids. And before we went on vacation, I set up a series of hotels for us to stay at. It was a self-driving tour, and I pre-booked these. I did that on my laptop. When I got to Florida, I found that a lot of hotels had started making great use of new technologies, apps specifically, in order to give me some really seamless experiences on my trip. They do things now like enabling me to check in before I get there, so just like I can for an airplane, and enabling me to go straight up to my room in order to open the door just with the app. That's pretty cool. I was pretty blown away by these new things that they were able to do. But what happened when I was on vacation was the notification to check in came while I was standing in line at something like this, the roller coaster at the theme park. It asked me, did I want to check in? And it also asked me, did I want to choose my own room, or did I want to let them choose for me? Well, back when I booked, I remember there was a text field, and it had asked me if I'd got any requests, and I put in that I wanted to have a sea view, because I knew at the next hotel there was this beautiful, pristine beach. I'd ordered a room with a balcony, and I really wanted this wonderful experience looking out over the sea. But I didn't know whether that experience on the laptop would translate into this app experience that I was now faced with. I was a bit concerned about that. And I thought that I might have a better opportunity of choosing my own room rather than letting them choose for me. Kind of always better to take it into your own hands, right? So I decided to choose my own room, and the experience that they gave me was pretty good on a mobile device. It actually worked. I know this looks like it would be quite challenging in terms of real estate, but it worked quite well. They clearly laid out the different rooms, and they clearly labeled whether the rooms were taken or open. There was only one problem, though, and that was I had no idea which way the sea was facing, which way the hotel was facing in front of the sea. So I was in line and trying to figure out how I could solve this. Now, there were some workarounds that I didn't actually think of at the time. Things like going to look on Google Maps, maybe I could figure it out, or looking on Google Images. In this case, the hotel's rather symmetrical, so it would be quite tricky. I decided to use a kind of rule of thumb or heuristic, and I decided to think that the side with the most taken rooms was probably the side that was facing the sea. So I decided to choose room 730 over here. So we got to the hotel, took up all the bags. You know what's going to happen, don't you? I got a view that looked a little bit like this. Big disappointment, So what did I have to do then? Well, I had to then go all the way down again to reception, which I thought I'd bypassed by using the app. Talked to the receptionist. They were extremely helpful, lovely hotel, fixed it for me, and in the end, we went back up a different floor, went in the hotel, and I got a view that was much more like this. Beautiful, huh? This is actually Florida. It looks like the Bahamas or something. It was really, really nice. So the in-person guest service was required. Human intervention was required because the app hadn't really delivered the service I'd hoped it would. It had done so well. I was really taken with this new technology I could use, but it fell short because it hadn't delivered this critical piece of information for me, which was, I just needed some information on the map. In this case, I just needed a view of the ocean, perhaps a few waves. I just needed some orientation. So for me, it was pretty critical that my view was of this beautiful beach rather than this car park. And, it could have been even more critical than my, very dear to me vacation. It could have been an event manager booking for a client. Perhaps it could have been people booking for guests for a wedding or something. One lesson is clear, and that's how we as developers and designers really need to understand the whole flow that our users are going through and where that breaks down. This had been really cool new technology, but I'd had to sort of backtrack through the whole thing and do those things that the app was supposedly saving me from doing. So really understanding that experience from beginning to end. And I think on mobile, it's really those little things that we don't realize we need to cover. And so that's why we really need to understand the user's perspective and the user's experience with that. So my talk is going to be about things like that and how we can fix them. Let me give you a little history. A couple of years ago, we found that a lot of experiences on the mobile web were particularly problematic for people. And so we conducted a large study and tried to understand where things weren't being implemented right for the mobile web and where we could do better. And we released a set of 25 principles for the mobile web. Those have done really well. People have used them as a kind of initial step in making a good foray into providing a better user experience on the mobile web. But as well as those have done, we've had people come back to us and said, this is great for the mobile web, but my app, what about my app? Can you tell me about my app? So I've had lots of calls to do another study and a study on apps. So that's what we've done. More recently, we've looked at native apps in a study. And so the principles I'm going to present to you today are the result of that work. So in this study, we've been able to understand patterns that lead to poor user experiences, and then luckily and happily, we were able to see where some companies have implemented things in a better way and understand why those patterns work better and bring those to you as well. And it's important for us to really understand this well so that we can be confident in the principles that we're telling you about, and you can be confident in implementing them in your own products. So in order to do the study, we partnered with a company called Answer Lab. They're a user experience consultancy based in San Francisco. And we partnered with them because they could help us scale, because we wanted the study to be pretty large scale. We studied interaction on 100 different apps on mobile. So these ranged from large retailers through to smaller service providers. We looked at news apps. We looked at many different sorts of services, like grocery services, travel services, retail, small and big companies. We didn't look at games as part of this, and that was on purpose, because we felt that would weaken or dilute the principles. We think games probably have a whole different set of principles. So aside from that, we looked across a wide range of verticals. And we conducted these studies in San Francisco, in Chicago, and New York City. Now, there were 103 participants that took part in this study. So for a usability study, that's really big. They came into the lab individually, each for 90 minutes. So that makes 155 hours of usability studies. So if you stayed up all night and all day, that would be almost a week with no breaks. Or, you know, in reality, it's more like almost 4 weeks of working weeks. So a large study indeed, and that's so that we could cover these different verticals. And what did we do in the study? Well, people came into the study, and during the 90 minutes, they were able to use around 6 apps for, you know, really getting into some good tasks for each of those. They brought in their own phones with them, and that was because we wanted them to be really familiar with the phone. We didn't want any problems because it was a different device, or they weren't used to the back button, or anything like that. So we had about 50% on Android and 50% on iOS. And then what did we do when they were in the study? So we had different tasks and different scenarios set up for them. And we did our best to make that task kind of mean something to them as well, so that they couldn't do what we call satisficing, which is just kind of doing the task as soon as they can, in as quick a way as they can. We wanted them to care about the task. So we often talk to them about things that they cared about. In this example, we might talk to them about their favorite food and understand what it is from them first, before then going to ask them to see if they could order it for dinner that evening. And we had them speak out loud using what's called in usability terminology, think aloud protocol. And we did that so that we could understand the pain points that they hit as they were going through the different tasks that they were doing, and we could understand where things flowed really smoothly for them. So having done that, we took the data. There was a lot of data, as you can imagine, from that much usability material, and we've collated it down to 25 principles so that this is something that you can take and understand and apply to your own apps. We've categorized the principles into 6 chapters, but before I go into them, I want to explain how we actually got to these 25. So in order to make it into the 25 principles, we had to see that this was a problem across a wide range of verticals, and we had to see that it was a fairly common problem. We did encounter more things than 25 things that were problematic in apps, but we wanted to make sure that we were hitting the biggest problems and that we also saw better ways that these could be implemented. Okay? So the different chapters that we have are around app navigation and exploration, in-app search, commerce and conversions, registration, form entry, and usability and comprehension. Now, we've got 25 of these different principles, but here in this talk, I'm just going to go into 2 principles from each of the chapters, and the rest of the principles are available to you online. I've also pulled together some resources for you that can help with implementation of some of the things you see here. That might be a good time to take a picture of the screen, as it's a resource that you can look into in your own time in more detail. OK, so let's start off with app navigation and exploration. So this chapter is really about guiding users to the content that they're looking for quickly. So we brought together a set of key principles to help you create effective and delightful app navigation. So let's take a look at 2 of these now. So a feature that can be really of great help to users is auto-detection of location. But don't assume that the location-based task is necessarily based in their current location without exception. I think we saw this too often. So it's a really great thing to be able to implement and help, create a seamless experience for users when they want something that's located where they are. But basically, we saw it over-applied without a way of enabling people to change that location. So in this example, if somebody's looking for a hotel tonight and they're looking for a hotel near where they are. And unfortunately, while they can change location, the only way to do it is probably go through settings. We saw this problem in not only travel apps, but we saw it also in retail apps. We saw use cases of people wanting to find something in a store, but that perhaps was located near where their parents live, and they wanted to figure out, if it was in the store near them so that they could tell their parents about that. So just only providing this, we were seeing too many use cases that were outside of this scenario. In travel, we saw it where people would turn up for their transportation, and the hotel that they wanted to book was at the other end of the train line, and they had time now to book the hotel, but they're not in the place where they're needing the hotel at the time. So a much better scenario is to still enable people to use their current location, but to provide the resource for them to change that well. So basically, great technology here that you definitely encourage you to use, but it's kind of over-applied without using some of the screen real estate to enable them to change location. If you do want to use that auto-detecting location, then Google Places API enables you to discover that currently supported location, and we've got a short link for you there to get to that material. So another aspect of app navigation and exploration that we saw a fair bit with apps is moving people from the app to the mobile web. And you can see in the way I've written this principle that there are issues with doing this. It says where app to web transitions are needed. So where they are needed, make them frictionless. So I think the idea here is, are they really needed in each case we're doing it? We're trying here at Google to make technologies to make this a lot smoother, this transition where you need to do it. But at the moment, we still see at least some sort of performance hit. So really consider whether you have to push people out to the mobile web when they're in their app experience right now. And then make them frictionless. So in this example, we've got somebody who's checking in for a flight. This can be a quite usual situation where people are moved out to the mobile web. But what we often saw, and not just in travel apps, in other scenarios as well, we saw the experience change fundamentally. So we saw something like this, okay? And it can sometimes happen, I think, because of the organizational structure of teams. This is the app team, and this is the mobile web team. And they haven't been talking enough, right? So I think, some companies are doing a better job of bringing these teams together to enable them to plan the user experience, the look and feel, and how content is laid out, and then separating out for the actual implementation on different platforms. So a much better experience is when companies have been really thoughtful about this, and you can make that look and feel very seamless, even though you're just moving out, right out to the mobile web. On Android, we're doing some work on this, and we've got some technology called Chrome Custom Tabs that you should look into. It's really helpful for enabling you to do things like changing the toolbar color and exit and enter animations to make that whole process of moving from the app to the mobile web more seamless. Moving on to the second chapter here. So the importance of great in-app search really can't be underestimated. So let's talk about a couple of crucial search implementations. So prominently displaying the search field. We found this back when we did the mobile web study about the importance of search. So on the poorer example, we have search in a place where people expect to look for it, but it's not how they expect to find it as a text, a piece of text here. What we saw in the study was people kind of did have some frustration looking around for search. Sometimes it was hidden under a menu. And it sounds one of the most obvious things, but I think my summary of what I saw in the study was that developers and designers aren't implementing like persistent search, a persistent search field enough. We advise that a persistent search field should be included when search is a really quite significant part of your experience in your app. But I think what's happening is plenty of people are thinking that search is important, but not that important to devote the screen real estate to. So check that out in your app. Should you be giving it more prominence than you currently are? So we have advice on this in material design, and we have persistent search, putting in a search field, and we also have expandable search, where we have the looking glass icon that can be expanded for search, of course. Think about the prominence of search in your app and how much it really matters to people when you're making that decision about which type of search you should implement. And then for implementation details, we have the search dialog and the search widget, and this link will take you to more information about that. What about filter and sort options? Hugely important. Again, we often saw that they were hidden or sort of buried or further down, and people couldn't get to them as much as they needed. That's what our study that we just did recently showed. We did see great implementations of it, but still there's more work to be done. Things like getting down to 242 results for shirt with no way to kind of filter or sort them further. So a better implementation is to have a really nice clear button filter. People can see that quite clearly and easily. And in this example, for apparel, you have this panel sliding out with all the right sorts of search options for them. So you could sort by best match, latest collection, that kind of thing. One thing I saw with filters like this was some companies were taking, for example, the sizing away when the inventory wasn't available. And that caused a problem for people because they didn't know if they would ever have their size in stock. So imagine, extra small being taken away just because it wasn't in stock. People didn't know if it'd come back. Better experience for that is something like, enabling them to perhaps sign up to find out when it is back in stock. But certainly showing it in a destable state is good. So here you have colors and price. And one other thing I like about this design is it's very clear when you're clearing the filters or applying the filters, and then a separate check at the top in order to close the panel so that there's not confusion about what closing the panel does. So keeping on this topic of search, we have other methods that will help with people with their search. One of those is adding custom suggestions that can be created from data in your application, so that can really help people with their search. And another one is recent query suggestions. So all these technologies and facilities can go to make that search experience better. So thinking through that search experience in more depth is a good topic. Commerce and conversions. So users expect a really smooth in-app experience for finding, learning about, and purchasing products. So let's look at a couple of things that the study revealed about commerce and conversions and helping to drive that conversion experience. So enabling comparison shopping features. So in this example on the left here, we're in a real estate app here, and people are they're only able to scroll down and look at the different homes. Anything they like, they have to commit to memory. And people, us, you and me, we're all cognitive misers. We don't like to use our brains that much, really. And we're making the user use their brain a lot here, remembering where they saw things and so forth. But we can do better. And some of those things that we saw that were implemented to help people in this way were letting people kind of bookmark items that they saw so that they can compare them. It's still pretty difficult on mobile to do this, but still, anything we can do helps. So the example I'm going to show you here had enabled people to compare. And then you can see it's quite constrained, with the size of the phone. But still, you're bringing that information together. It means they could ignore all the other homes that they don't care about. And they can compare the bedrooms. They can compare the bathrooms, the cost of the home, and so forth. We know this is needed because in the study, we saw people do workarounds for this. So in retail, we saw people add items to their cart just so that they could look at them all in the same place. And that was the users that thought about doing that. Other people struggled. So we know this is needed. So think about the comparisons and the browsing experience that people are needing within your app. And then making it easy to add and manage payment methods. I actually came across a poor example of this the other day, and it was when I went to purchase, I was going on vacation again. I like to go on vacation. And I was making a reservation for a rental home. And I got to the point where I needed to update my cards. So my model in my head was, well, a new card had arrived, and it's simply the same card as before. It just had a new date on it. In my mind, my mental model of my cards, that's the same card, just needs replacing. It's not a new payment method. So I expected to be able to edit my existing card, but there was no facility to do that. So I kind of had to understand the developer's model that I needed to add a new payment method. In this example, the person's got to the point where they're supposed to be checking out, but there's no way to edit a card or add a new card. That's somewhere else in some other settings. But most of us don't think, well, I'm going to wake up in the morning and think I need to manage my payment methods in that app, kind of as a separate activity, right? We tend to think about it when we need to do it, when we come to pay. So this is a problem here. So in this example, it's much better. There's an option to edit existing cards, to add a new payment method, and provide multiple payment methods here and lead people to a very clean form design here when the user has chosen to add a new credit card, and they can even scan their card if they wish to, so making that experience nice and clean. Now, one facility that we offer at Google is Android Pay, so making that a choice of one of the ways to pay. The idea here is it's really simple for the user and seamless for the user to pay through Android Pay, and I think there's a talk about it here at I/O, and there's more information that you can get at this link. So registration. Registration is really popular with companies and developers because it's seen to be that that's where we can get engagement from the user, and that's kind of where the user commits to us. We've known for a long time that providing these registration barriers up front can be a big hurdle for people to get to, and it's better to offer them something first so that they can feel, start to feel engagement from their side to the company. There's a couple of other things I want to talk about today with regard to registration. So we saw users struggle with signing in and signing up. It's a tricky thing, right? We often saw users starting to fill out a form if they were provided one and realizing they were signing in when they were supposed to be signing up and vice versa. It's probably happened to all of us. So we found better experience when people were just given the option to sign in or register. The words were very different. They could differentiate them, and then we could channel them down the right kind of route so that they didn't get into that muddle. We have lots of solutions for registration and identity at Google. We have a whole identity platform that I'd encourage you to look at. It's basically an auth system, and it has several components and different choices for you to make. So one of these is Sign In for Android. It enables the user to sign in with the same credentials that they use on Google. The whole intent is to make that process more seamless and simple for them. And talking of that, there's other ways to make password authentication a frictionless experience. We've all been in this situation where it just doesn't work for us, and it's quite painful on mobile to keep putting your password in and it's not working. It can be even worse in apps, because we often found that this was a place where people were sent back out to the mobile web, right? So then you're in that loop again, and that's even more aggravating. So we've talked about one solution for enabling people to sign in. Another one that we saw that's becoming much more popular is fingerprint sign-in. And in our study, people were pretty happy about this. They liked the idea very much of doing this. So I think this is a good thing to look into. And we have some more implementation details for you here by using fingerprint scans on supported devices. And Smart Lock is another part of our identity system. It enables you to automatically sign users into the app using credentials that they've saved. So that's another really good one, part of this federated identity provision. And if you haven't got that far with users, there's also sign-in hints. And this allows us to use the Credentials API. It enables you to give hints to the user for signing in, for their username, their email address. Everything is done to kind of ease that sign-in hurdle. So form entry. We've been talking in design about form entry for years and years. We did lots of work on form entry for desktops. And when we went to the mobile web, we kind of had to relearn all that again and again. You'll remember when those forms used to be really, really tiny and you had to expand them to fill out the form. It's always been a little bit better with apps because we've been designing forms from the get-go for the mobile devices. But I'm pleased to say I think we've come a long way, but there are still things we saw in our study that could be improved. So I've categorized this under building user-friendly forms. And some of the things I saw were still some apps requiring users to do a lot of work on their part, putting their cursor in several different fields for their phone numbers and things like this. Takes a lot of effort on the part of the user. And also not being able to see what form fields were coming up was a problem for users. It was hard for them to sort of build their mental model of what they would have to fill in next. It caused them frustration and was definitely a friction point. So better engagement here is doing more work on the back end. So, whether the user wants to write in their phone number with dashes in between the numbers, with spaces in between the numbers, or as just one long field, we need to cater for that and make it's a little bit more work for us on the development side, but it makes it a whole lot easier for the user to understand what they're doing and not get, an error returned. So also, where there are errors, providing those in line is really helpful. And here we have an app that does a really good job of moving the form up the field as the user fills it in. And we found that was very advantageous to users. So we have a lot of information on creating great text fields through material design. Talks a lot about the different aspects of creating a good form. And specifically for places, we can use Places autocomplete as part of the Places API again. And this can really help for filling in those form fields that require location. Another aspect of form design is matching the keyboard with the required text inputs. This is a fairly well-known thing to do, but we still saw significant apps not doing this well. So when the users put their cursor in the credit card field, and if you've got this in your app, you should check it out. Is it doing the right thing, right? In this example here, it's not doing the right thing. The user's left with this keyboard, and they don't have any way of getting the right keyboard up. Not usually. They hit the number key over here, and then they'll get the keyboard with the numbers along the top, as opposed to designing that appropriately, and once the cursor is in there, bringing up the numeric keyboard for them. So little things like this, all these little things on forms really add up, and just checking out your form design in this way is really helpful for people. So we've got information on specifying input method type and the correct keyboard that you can find at this link. Then lastly, let's look at usability and comprehension. These are those small things that you can do that we saw in our studies throughout the app to make a more seamless experience for users. It can be critical for ensuring a good user experience and not having users get stuck or abandon their experience at any point. This one's about providing text labels and visual keys to clarify visual information. So we saw this earlier. In my story, I was specifically missing a visual key. I just needed those waves in the picture to help me understand the orientation of the hotel. Take a look at this example here. Just take a couple of moments and decide for yourself what you think those icons represent. Some of them perhaps more obvious than others. Should we have a look at the answers? Here we go. So it's My Trips, Book, Club, and Account. Did anyone get them right? I think so, probably Account wasn't too bad. But the lesson here that we saw is, again, I think it's overgeneralizing. It's like the rule that we would give is when icons are vague, then they definitely need text labels. The trouble is in saying, when icons are vague, is we all have different levels of understanding with regard to that. You have to, I think, assume that a lot of your icons are going to be vague. I can give you an example. So, the icon for filter that looks kind of like this. You'd think that would be fairly universal. It's drawn in quite different ways across many different apps, and we certainly didn't find it universally understood among people. So I think we have to, change our kind of level set with regard to which, the number of icons in our apps that need to have labels if people are going to understand it. And this is a very great place where you can do simple A/B testing and see the difference between providing labels and not providing labels. Here we've got some implementation details for when you want to use text and icons for buttons. So if you have that there. And then talking of labeling things, that always makes me aware of making my application accessible. We have lots of guidelines here for you to make sure your application is accessible. And the last principle I'm going to go into today is asking for permissions in context. So this is something that we enabled with Android M, but we still see that a significant number of apps aren't making advantage of it. It's been able to be possible in iOS for a while now as well. So in this example, the user has just downloaded and opened the app, and they're immediately asked, can their location be used? So perhaps this app was suggested to them by somebody else. They said, oh, this is a really good app if you want to learn about home decor, and it's got some really cool things in you can buy. But it's kind of similar to how we would think of problematic registration, right? When you ask for that up front, and it's a hurdle to get over. This is the same thing for users. It's like the developers saying, provide me with your location before I give you anything else, right? And users are often going to say no, because they don't really understand why, and they just wanted to look around your app. So A better way to do that, and you can do that now because of Android M, is being able to do that in context at runtime. In this example, we have people searching for stores. So much better because the user has their own motivation, right? They want to be able to find that store, and then what happens next is even more clear for them. There's a map that comes up behind, and it asks, can we use your location? Well, of course you can, right? You're much more likely to get acceptance if you ask in context. We have lots of resources for you for this. We have great little videos and implementation details about being able to request permissions in runtime. And it's simply in these principles because although I know many of you know about it, we saw it a lot in the apps that we studied recently. So that's why it's here. So that brings me to the end of the principles I'm going to go through with you. We've gone through each of these chapters, and you can find more of these principles online. They're all online at Think with Google. And I made a short link for you here specifically to the principles, better mobile user experience. There's actually multiple sets of principles. Let me tell you what there is. There's mobile app principles, new set of 25 mobile principles. There's a new set of 25 principles for retail. That's both web and app. Again, we did a study, and so we collated the information, provided that there. And then there's the mobile web principles that we've published previously that you might have already seen. All at this link, same link. And if you want more implementation details on the mobile web side, the principles are also part of our Web Fundamentals site. And that particular link I provided with you there provides additional developer implementation details. Before I go, I want to tell you about one more story from the study. So in the study, a number of apps had implemented the ability to scan your credit card in order to pay. Now, we've had a few people in the study that had used that before and come across it and liked it. But because this is relatively new technology, we had some people that encountered it for the first time. Now, if you think about the word scan, my most familiar experience, I think, with the word scan is when I go to the grocery store and scan my credit card, right? And I'm putting my credit card right next, or putting it through another machine, really. That's scanning. Another place I know of the word scan is, putting paper on a photocopier. That's kind of a little further, longer ago. But still, that's scanning, putting something on top of each other. So the users come to this request to scan their credit card. That's their use of the word scan. And if you imagine them trying to translate that, often the first thing that's asked is, can we use your camera? Well, is the camera anything to do with scanning my credit card? Well, maybe. I don't really understand it, but yeah, OK, you can use my camera. And then it asks you to hold the credit card here. It will scan automatically. OK, following the instructions. No surprise then, we saw 3 people in the study do this. And they waited, and they waited. And they were terribly disappointed because they thought it had sounded so, simple way to pay. And this is just about us understanding what we're asking people to do and the language we're using. It's plain and simple usability. We'd all love this to work. Unfortunately, it doesn't work yet. But it makes sense, right, what they were doing because of what they were being told to do. So again, I return to that point I made earlier, which is understanding the user experience end to end, understanding the flow and the pain points. Really important, because I want you to have an experience where, you make a really good app experience for your users. Not one where the user is frustrated, and not the kind of frustration I felt like after I'd used my app and gone up to my hotel room and seen that car park out of my window. I want you to be able to make app experiences that make people feel like life is really frictionless, much more like a view of the beach. And so I want to end with giving you 3 takeaways. And these are 3 steps that you can think about doing after this talk. taking a look at your app and auditing your app against the 25 principles. Simply like, where are we doing, what are we doing in each of these experiences, and is it measuring up? That's going to get you a long, long way. But your app is unique too, right? So you have to really understand your key user journeys and understand those breakdown points. What I'd been provided for my hotel app was, really exciting to me, but it had points that broke down for me such that it didn't end up working that well in the end. And then finally thinking about doing your own user testing. And this guide from Google Ventures provides lots of resources for getting going for user research and user testing in a really small-scale way so that you can see the good things that you provide in the app and celebrate those, and also identify the pain points in your app so you can think about how to fix them. Thank you for your time.
You'll notice that we just printed out the first row. Now both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire data set like this. Now that we know how to work with the data set, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left, otherwise go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now I could do that in theory by adjusting the multiplier on the center view's width constraint. But it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now, there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now, Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. Okay, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned. simply by adding and removing 2 different groups of constraints, and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, click here. And otherwise, I'll see you on Route 85. Bye.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, many